Section 17 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by deongines, Salt Lake City, Utah. Micrographia by Robert Hooke. Section 17. Observation 12 of gravel in urine. I have often observed the sand or gravel of urine, which seems to be a tartareous substance generated out of a saline and a terrestrial substance crystallized together in the form of tartar, sometimes sticking to the sides of the urinal, but for the most part sinking to the bottom, and there lying in the form of coarse, common sand. These, through the microscope, appear to be a company of small bodies, partly transparent and partly opacious, some white, some yellow, some red, others of more brown and dusky colors. The figure of them is for the most part flat, in the manner of slats, or such like plated stones, that is, each of them seem to be made up of several other thinner plates, much like Muscovy glass or English spar, to the last of which the white plated gravel seems most likely, for they seem not only plated like that, but their sides shaped also into rhomboids, and sometimes into rectangles and squares. Their bigness and figure may be seen in the second figure of the seventh plate, which represents about a dozen of them lying upon a plate A, B, C, D, some of which, as A, B, C, D, seemed more regular than the rest, and E, which was a small one, sticking on the top of another, was a perfect rhomboid on the top and had 4 rectangular sides. The line E, which was the measure of the microscope, is 1/32 part of an English inch, so that the greatest breadth of any of them exceeded not 1/128th part of an inch. Putting these into several liquors, I found oil of vitriol, spirit of urine, and several other saline menstruums to dissolve them, and the first of these in less than a minute without ebullition. Water and several other liquors had no sudden operation upon them. This I mention because those liquors that dissolve them first make them very white, not vitiating, but rather rectifying their figure, and thereby make them afford a very pretty object for the microscope. How great an advantage it would be to such as are troubled with the stone to find some menstruum might dissolve them without hurting the bladder, is easily imagined, since some injections made of such bodies might likewise dissolve the stone, which seems much of the same nature. It may therefore, perhaps, be worthy some physician's enquiry whether there may not be something mixed with the urine in which the gravel or stone lies, which may again make it dissolve it, the first of which seems by its regular figures to have been sometimes crystallized out of it. For whether this crystallization be made in the manner as alum, peter, etc., are crystallized out of a cooling liquor, in which, by boiling, they have been dissolved, or whether it be made in the manner of tartarum vitriolatum, that is, by the coalition of an acid and a sulphureous substance, it seems not impossible but that the liquor it lies in may be again made a dissolvent of it. But leaving these enquiries to physicians or chemists, to whom it does more properly belong, I shall proceed. End of section 17.
Section 18 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Observation 13. Of the small diamonds or sparks in flints. Chancing to break a flint stone in pieces, I found within it a certain cavity all crusted over with a very pretty candied substance, some of the parts of which, upon changing the posture of the stone in respect of the incident light, exhibited a number of small but very vivid reflections, and having made use of my microscope, I could perceive the whole surface of that cavity to be all beset with a multitude of little crystalline or adamantine bodies, so curiously shaped that it afforded a not unpleasing object. Having considered those vivid repercussions of light, I found them to be made partly from the plain external surface of these regularly figured bodies, which afforded the vivid reflections, and partly to be made from within the somewhat pellucid body, that is, from some surface of the body opposite to that superficies of it, which was next the eye. And because these bodies were so small that I could not well come to make experiments and examinations of them, I provided me several small styrrhea of crystals or diamants, found in great quantities in Cornwall, and are therefore commonly called Cornish diamants. These being very pellucid, and growing in a hollow cavity of a rock, as I have been several times informed by those that have observed them, much after the same manner as these do in the flint, and having besides their outward surface very regularly shaped, retaining very near the same figures with some of those I observed in the other, became a convenient help to me for the examination of the proprieties of those kinds of bodies. And first for the reflections, in these I found it very observable, that the brightest reflections of light proceeded from within the pellucid body, that is, that the rays admitted through the pellucid substance in their getting out on the opposite side were by the contiguous and strong reflecting surface of the air very vividly reflected, so that more rays were reflected to the eye by this surface, though the ray in entering and getting out of the crystal had suffered a double refraction, than there were from the outward surface of the glass, where the ray had suffered no reflection at all. And that this was the surface of the air that gave so vivid a repercussion, I tried by this means. I sunk half of a styrrhea in water, so that only water was contiguous to the under surface, and then the internal reflection was so exceedingly faint that it was scarce discernible. Again, I tried to alter this vivid reflection by keeping off the air, with a body not fluid, and that was by rubbing and holding my finger very hard against the under surface, so as in many places the pulp of my finger did touch the glass, without any interjacent air between. Then observing the reflection, I found that wheresoever my finger or skin touched the surface, from that part there was no reflection. But in the little furrows or creases of my skin, where there remained little small lines of air, from them was returned a very vivid reflection as before. I tried further by making the surface of very pure quicksilver to be contiguous to the under surface of this pellucid body, and then the reflection from that was so exceedingly more vivid than from the air, as the reflection from air was then the reflection from the water. From all which trials I plainly saw that the strong reflecting air was the cause of this phenomenon. And this agrees very well with the hypothesis of light and pellucid bodies which I have mentioned in the description of Muscovy glass, for we there suppose glass to be a medium which does less resist the pulse of light, and consequently that most of the rays incident on it enter into it, and are refracted towards the perpendicular, whereas the air I suppose to be a body that does more resist it, and consequently more are repercussed than do enter it. The same kind of trials have I made with crystalline glass, with drops of fluid bodies, and several other ways, which do all seem to agree very exactly with this theory. So that from this principle, well established, we may deduce several corollaries not unworthy observation. And the first is, that it plainly appears by this, that the production of the rainbow is as much to be ascribed to the reflection of the concave surface of the air as to the refraction of the globular drops. This will be evidently manifest by these experiments. If you foliate that part of a glass ball that is to reflect an iris, as in the Cartesian experiment above mentioned, the reflections will be abundantly more strong and the colours more vivid, and if that part of the surface be touched with water, scarce affords any sensible colour at all. Next we learn that the great reason why pellucid bodies beaten small are white is from the multitude of reflections, not from the particles of the body, but from the contiguous surface of the air. And this is evidently manifested by filling the interstitia of those powdered bodies with water, whereby their whiteness presently disappears. From the same reason proceeds the whiteness of many kinds of sands, which in the microscope appear to be made up of a multitude of little pellucid bodies, whose brightest reflections may, by the microscope, be plainly perceived to come from their internal surfaces, and much of the whiteness of it may be destroyed by the effusion of fair water to be contiguous to those surfaces. The whiteness also of froth is for the most part to be ascribed to the reflection of the light from the surface of the air within the bubbles, and very little to the reflection from the surface of the water itself. For this last reflection does not return a quarter so many rays as that which is made from the surface of the air, as I have certainly found by a multitude of observations and experiments. The whiteness of linen, paper, silk, etc., proceeds much from the same reason, as the microscope will easily discover. For the paper is made up of an abundance of pellucid bodies, which afford a very plentiful reflection from within, that is, from the concave surface of the air contiguous to its component particles. Wherefore, by the effusion of water, oil, tallow, turpentine, etc., all those reflections are made more faint, and the beams of light are suffered to traject and run through the paper more freely. Hence further, we may learn the reason of the whiteness of many bodies, and by what means they may be in part made pellucid. As white marble, for instance, for this body is composed of a pellucid body exceedingly flawed. That is, there are abundance of thin and very fine cracks or chinks amongst the multitude of particles of the body that contain in them small parcels of air, which do so repercuss and drive back the penetrating beams, that they cannot enter very deep within that body, which the microscope does plainly inform us to be made up of a congeries of pellucid particles. And I further found it somewhat more evidently by some attempts I made towards the making transparent marble. For, by heating the stone a little, and baking it in oil, turpentine, oil of turpentine, etc., I found that I was able to see much deeper into the body of marble than before, and one trial, which was not with an unctuous substance, succeeded better than the rest, of which, when I have a better opportunity, I shall make further trial. This also gives us a probable reason of the so much admired phenomena of the oculus mundi, an oval stone which commonly looks like white alabaster, but being laid a certain time in water, it grows pellucid and transparent, and being suffered to lie again dry, it by degrees loses that transparency and becomes white as before. For the stone, being of a hollow spongy nature, has in the first and last of these appearances all those pores filled with the obtunding and reflecting air, whereas in the second all those pores are filled with a medium that has much the same refraction with the particles of the stone, and therefore those two being contiguous make, as 'twere, one continued medium, of which more is said in the 15th observation. There are a multitude of other phenomena that are produced from this same principle, which, as it has not been taken notice of by any yet that I know, so I think, upon more diligent observation, will it not be found the least considerable. But I have here only time to hint hypothesis, and not to prosecute them so fully as I could wish. Many of them having a vast extent in the production of a multitude of phenomena which have been by others either not attempted to be explained, or else attributed to some other cause than what I have assigned, and perhaps than the right. And therefore I shall leave this to the prosecution of such as have more leisure. Only before I leave it, I must not preterm it to hint that by this principle multitudes of the phenomena of the air, as about mists, clouds, meteors, halos, etc., are most plainly and, perhaps, truly explicable. Multitudes also of the phenomena in coloured bodies, as liquors, etc., are deducible from it. And from this I shall proceed to a second considerable phenomenon which these diamants exhibit, and that is the regularity of their figure, which is a propriety not less general than the former, it comprising within its extent all kinds of metals, all kinds of minerals, most precious stones, all kinds of salts, multitudes of earths, and almost all kinds of fluid bodies. And this is another propriety which, though a little superficially taken notice of by some, has not, that I know, been so much as attempted to be explicated by any. This propriety of bodies, as I think it the most worthy, and next in order to be considered after the contemplation of the globular figure, so have I long had a desire as well as a determination to have prosecuted it if I had had an opportunity, having long since proposed to myself the method of my inquiry therein, it containing all the allurements that I think any inquiry is capable of. For, first I take it to proceed from the most simple principle that any kind of form can come from. Next the globular, which was therefore the first I set upon, and what I have therein performed I leave the judicious reader to determine. For as that form proceeded from a propriety of fluid bodies, which I have called congruity or incongruity, so I think, had I time and opportunity, I could make probable that all these regular figures that are so conspicuously various and curious, and do so adorn and beautify such multitudes of bodies as I have above hinted, arise only from 3 or 4 several positions or postures of globular particles, and those the most plain, obvious, and necessary conjunctions of such figured particles that are possible. So that supposing such and such plain and obvious causes concurring the coagulating particles must necessarily compose a body of such a determinate regular figure, and no other, and this with as much necessity and obviousness as a fluid body encompassed with a heterogeneous fluid must be protruded into a spheroid or globe. And this I have ad oculum demonstrated with a company of bullets, and some few other very simple bodies, so that there was not any regular figure, which I have hitherto met withal, of any of those bodies that I have above named, that I could not with the composition of bullets or globules, and 1 or 2 other bodies imitate, even almost by shaking them together. And thus, for instance, we may find that the globular bullets will of themselves, if put on an inclining plane, so that they may run together, naturally run into a triangular order, composing all the variety of figures that can be imagined to be made out of equilateral triangles. And such will you find, upon trial, all the surfaces of alum to be composed of. For 3 bullets, lying on a plane, as close to one another as they can compose an equilateral triangular form, as in A in the 7th scheme, if a 4th be joined to them on either side as closely as it can, they 4 compose the most regular rhombus consisting of 2 equilateral triangles, as B. If a 5th be joined to them on either side in as close a position as it can, which is the propriety of the texture, it makes a trapezium, or 4-sided figure. 2 of whole angles are 120, and 2 60 degrees, as C. If a 6th be added, as before, either it makes an equilateral triangle, as D, or a rhomboid, as E, or an hexangular figure, as F, which is composed of 2 primary rhombs. If a 7th be added, it makes either an equilateral hexagonal figure, as G, or some kind of 6-sided figure, as H or I. And though there be never so many placed together, they may be ranged into some of these lately mentioned figures, all the angles of which will be either 60 degrees or 120, as the figure K, which is an equiangular hexagonal figure, is compounded of 12 globules, or may be of 25 or 27 or 36 or 42, etc. And by these kinds of texture or position of globular bodies may you find out all the variety of regular shapes into which the smooth surfaces of alum are formed, as upon examination anyone may easily find. Nor does it hold only in superficies, but in solidity also, for it's obvious that a 4th globule laid upon the 3rd in this texture composes a regular tetrahedron, which is a very usual figure of the crystals of alum. And, to hasten, there is no one figure into which alum is observed to be crystallized, but may by this texture of globules be imitated, and by no other. I could instance also in the figure of sea salt and sal gem that it is composed of a texture of globules placed in a cubical form, as L, and that all the figures of those salts may be imitated by this texture of globules and by no other whatsoever. and that the forms of vitriol and of saltpetre, as also of crystal, hoarfrost, etc., are compounded of these two textures, but modulated by certain proprieties. But I have not here time to insist upon, as I have not neither to shew by what means globules come to be thus contexed, and what those globules are, and many other particulars requisite to a full and intelligible explication of this propriety of bodies. Nor have I hitherto found indeed an opportunity of prosecuting the inquiry so far as I designed, nor do I know when I may, it requiring abundance of time, and a great deal of assistance to go through with what I designed, the model of which was this. First, to get as exact and full a collection as I could of all the differing kinds of geometrical figured bodies, some 3 or 4 bodies of each kind. Secondly, with them to get as exact a history as possibly I could learn of their places of generation or finding, and to inquire after as many circumstances that tended to the illustrating of this inquiry as possibly I could observe. Thirdly, to make as many trials as upon experience I could find requisite, in dissolutions and coagulations of several crystallizing salts, for the needful instruction and information in this inquiry. Fourthly, to make several trials on divers other bodies, as metals, minerals, and stones, by dissolving them in several menstruums, and crystallizing them, to see what figures would arise from those several compositums. Fifthly, to make compositions and coagulations of several salts together into the same mass, to observe of what figure the product of them would be, and in all to note as many circumstances as I should judge conducive to my inquiry. Sixthly, to inquire the closeness or rarity of the texture of these bodies by examining their gravity and their refraction, etc. Seventhly, to inquire particularly what operations the fire has upon several kinds of salts, what changes it causes in their figures, textures, or energies. Eighthly, to examine their manner of dissolution, or acting upon those bodies dissoluble in them, the texture of those bodies before and after the process, and this for the history. Next, for the solution, to have examined by what and how many means such and such figures, actions and effects could be produced possibly. And lastly, from all circumstances well weighed, I should have endeavoured to have shewn which of them was most likely, and, if the informations by these inquiries would have borne it, to have demonstrated which of them it must be and was. But to proceed, as I believe it next to the globular the most simple, so do I, in the second place, judge it not less pleasant. For that which makes an inquiry pleasant are, first, a noble inventum that promises to crown the successful endeavour, and such must certainly the knowledge of the efficient and concurrent causes of all these curious geometrical figures be, which has made the philosophers hitherto to conclude nature in these things to play the geometrician according to that saying of Plato, O seon Yale Madri. Or next, a great variety of matter in the inquiry, and here we meet with nothing less than the mathematics of nature, having every day a new figure to contemplate, or a variation of the same in another body. Which do afford us a third thing, which will yet more sweeten the inquiry, and that is a multitude of information. We are not so much to grope in the dark as in most other inquiries, where the inventum is great, for having such a multitude of instances to compare, and such easy ways of generating or compounding and of destroying the form, as in the solution and crystallization of salts, we cannot but learn plentiful information to proceed by. And this will further appear from the universality of the principle which nature has made use of almost in all inanimate bodies. And therefore, as the contemplation of them all conduces to the knowledge of any one, so from a scientifical knowledge of any one does follow the same of all and every one. And fourthly, for the usefulness of this knowledge, when acquired, certainly none can doubt that considers that it carries us a step forward into the labyrinth of nature in the right way towards the end we propose ourselves in all philosophical inquiries. So that knowing what is the form of inanimate or mineral bodies, we shall be the better able to proceed in our next inquiry after the forms of vegetative bodies. And last of all, of animate ones, that seeming to be the higher step of natural knowledge that the mind of man is capable of. End of section 18.
Section 19 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Section 19. Observation 14 of several kinds of frozen figures. I have very often in the morning, when there has been a great hoar-frost, with an indifferently magnifying microscope observed the small styria or crystalline beard, which then usually covers the face of most bodies that lie open to the cold air, and found them to be generally hexangular prismatical bodies, much like the long crystals of saltpeter, save only that the ends of them were differing, for whereas those of nitre are for the most part pyramidal, being terminated either in a point or edge, these of frost were hollow, and the cavity in some seemed pretty deep, and this cavity was the more plainly to be seen, because usually one or the other of the thick parallelogram sides was wanting, or at least much shorter than the rest. But this was only the figure of the bearded hoarfrost, and as for the particles of other kinds of hoarfrost, they seem for the most part irregular, of no certain figure. Nay, the parts of those curious branchings or vortices that usually in cold weather tarnish the surface of glass, appear through the microscope very rude and unshapen, as do most other kinds of frozen figures, which to the naked eye seem exceedingly neat and curious, such as the figures of snow, frozen urine, hail, several figures frozen in common water, etc. Some observations of each, of which I shall hereunto annex, because if well considered and examined, they may, perhaps, prove very instructive for finding out of what I have endeavored in the preceding observation to shew to be, next the globular figure which I caused by congruity, as I hope I have made probable in the sixth observation, the most simple and plain operation of nature, of which, notwithstanding, we are yet ignorant. First, several observables in the 6 branch figures formed on the surface of urine by freezing. 1. The figures were all frozen almost even with the surface of the urine in the vessel, but the bigger stems were a little prominent above the surface, and the parts of those stems which were nearest the center, A, were biggest above the surface. 2. I have observed several kinds of these figures, some smaller, no bigger than a 2-pence, others so big that I have by measure found one of its stems or branches above 4 foot long, and of these some were pretty round, having all their branches pretty near alike, others of them were more extended towards one side, as usually those very large ones were, which I have observed in ditches, which have been full of fuel water. 3. None of all these figures I have yet taken notice of had any regular position in respect of one another, or of the sides of the vessel, nor did I find any of them equally to exactness extended every way from the center A. 4. Wherever there was a center, the branchings from it, AB, AC, AD, AE, AF, AG, were never fewer or more than 6, which usually concurred or met another very near the same point or center A, though oftentimes not exactly, and were inclined to each other by an angle of very near 60°, I say very near, because, though having endeavored to measure them to most accurately I was able, with the largest compasses I had, I could not find any sensible variation from that measure, yet the whole 6 branched figures seem to compose a solid angle, they must necessarily be somewhat less. 5. The middle lines or stems of these branches, AB, AC, AD, AE, AF, AG, seemed somewhat wider and a little higher than any of those intermediate branchings of these figures, and the center A was the most prominent part of the whole figure, seeming apex of a solid angle or pyramid, each of the 6 planes being a little inclined below the surface of the urine. 6. The lateral branches issuing out of great ones, such as OP, MQ, etc., were each of them inclined to the great ones, by the same angle of about 60 degrees as the great ones were to another, and always the bigger branchings were prominent above the less, and the less above the least, by proportionate gradations. 7. The lateral branchings shooting out of the great ones went all of them from the center, and each of them was parallel to that great branch next to which it lay, so that as all the branches on one side were parallel to one another, so were they all of them to the approximate great branch as PO, QR, as they were parallel to each other and shot from the center, so they were parallel also to the great branch AB. 8. Some of the stems of the 6 branches proceeded straight, and of the thickness that gradually grew sharper towards the end, as AG. 9. Other of the stems of those branches grew bigger and knotty towards the middle, and the branches also as well as stems from cylinders grew into plates in a most admirable and curious order, so exceedingly regular and delicate as nothing could be more, as is visible in AB, AC, AD, AE, AF. But towards the end of some of these stems they began again to grow smaller, and to recover their former branchings, as about K and N. 10. Many of the lateral branches had co-lateral branches, if I may so call them, as QM had many such as ST, and most of those again subcollateral, as VW, and these again had others less, which one may call latero-subcollateral, and these again others, and they others, etc. in greater figures. 11. The branchings of the main stems joined not together by any regular line, nor that one side of the one lay over the other side of the other, but the small collateral and subcollateral branches did lie atop of one another, according to a certain order or method, which I always observed to be this. 12. The side of a collateral or subcollateral, etc. branch lay over the side of the approximate, as feathers in the wings of a bird, whose branchings proceed parallel to the biggest stem from which it sprung, and not to the biggest stem of all, unless that were a second stem backwards. 13. This rule that held in the branchings of the sexangular figure held also in the branchings of any other great or small stem, though it did not proceed from a center. 14. The exactness and curiosity of the figuration of these branches was in every particular so transcendent that I judge it almost impossible for humane art to imitate. 15. Tasting several clear pieces of this ice, I could not find any urinous taste in them, but those few I tasted seemed as insipid as water. 16. A figuration somewhat like this, though indeed in some particulars much more curious, I have several times observed in Regulus Martis Stellatus, but with this difference, that all the stems and branchings are bended in a most excellent and regular order, whereas in ice the stems and branchings are straight, but in all other particulars it agrees with this, and seems indeed nothing but of these stars or branched figures frozen on urine, distorted or wethed a little with certain proportions. Lead also has arsenic and some other things mixed with it. I have found to have this surface, when suffered to cool, figured somewhat like the branchings of urine, but much smaller. 17. But there is a vegetable which does exceedingly imitate these branches, and that is fern, where the main stem may be observed to shoot out branches, and the stem of each of these lateral branches send forth collateral branches and subcollateral branches, and those latero-subcollateral, etc. And all those much after the same order with branchings, divisions, and subdivisions in their branchings of these figures in frozen urine, so that if the figures of both be well considered, one would guess that there were not much greater need of a seminal principle for the production of fern than for the production of the branches of urine or the stella martis, there seeming to be much form and beauty in one as the other. And indeed, this plant of fern, if all particulars be well considered, will seem as simple and uncompounded a form as any vegetable next to mold or mushrooms, and would next after the invention of the forms of those deserve to be inquired into, for notwithstanding several have affirmed to have seed, and to be propagated thereby, yet, though I have made very diligent enquiry after that particular, I cannot find that there is any part of it that can be imagined to be more seminal than another, but this only here by the by. For the freezing figures in urine, I found it requisite, first, that the superficies be not disturbed with any wind, or other accommodation of the air or the like. Secondly, that it be not too long exposed, so as that the whole bulk be frozen, for oftentimes, in such cases, by reason of the swelling of the eyes, or from other cause, the curious branched figures disappear. Thirdly, an artificial freezing with snow and salt applied to the outside of the containing vessel succeeds not well, unless there be very little quantity in the vessel. Fourthly, if you take any clear and smooth glass, and wetting all the inside of it with urine, you expose it to a very sharp freezing, you will find it covered with a very regular and curious figure. 2. Observables in figured snow. Exposing a piece of black cloth or black hat to the falling snow, I have often with great pleasure observed such an infinite variety of curiously figured snow, that it would be impossible to draw the figure and shape of every one of them, as to imitate exactly the curious and geometrical mechanism of nature in any one. Some coarse draughts, such as the coldness of the weather and the ill provisions I had by me for such a purpose, would permit me to make, I have here added in the second figure of the eighth scheme. In all which I observed, that if they were any regular figures, they were always branched out with 6 principal branches, all of equal length, shape, and make, from the centre, being each of them inclined either of the next branches on either side of it by an angle of 60 degrees. No, as all the stems were for the most part in one flake exactly of the same make, so were they in different figures of very different ones, so that in a very little time I have observed above 100 several sizes and shapes of these dairy flakes. The branches also out of each stem of any one of these flakes were exactly alike in the same flake, so that of whatever figure one of the branches were, the other 5 were surely to be of the same, very exactly. That is, if the branchings of the one were small parallelepipeds or plates, the branchings of the other 5 were of the same, and generally the branchings were very conformable to the rules and method observed before. In the figures on urine, that is, the branching from each side of the stems were parallel to the next stem on that side. And if the stems were plated, the branches also were the same. If the stems were very long, the branches also were so, etc. Observing some of these figured flakes with a microscope, I found them not to appear so curious and exactly figured as one would have imagined, but like artificial figures, the bigger they were magnified, the more irregularities appeared in them, but this irregularity seemed ascribable to the thawing and breaking of the flake by the fall, and not at all to the defect of the plastic virtue of nature, whose curiosity in the formation of most of these kind of regular figures, such as those of salt, minerals, etc., appears by the help of the microscope to be very many degrees smaller than the most acute eye is able to perceive without it. And though one of these 6 branched stars appeared here below much of the shape described in the third figure of the 8th scheme, yet I am very apt to think that could we have a sight of one of them through a microscope as they are generated in the clouds before their figures are vitiated by external accidents, they would exhibit abundance of curiosity and neatness there also, though never so much magnified. For since I have observed the figures of salts and minerals to be some of them so exceedingly small that I have scarcely been able to perceive them with the microscope, and yet they have been regular, and since, as far as I have yet examined it, there seems to be but one and the same cause that produces both these effects, I think it not irrational to suppose that these pretty figured stars of snow, when at first generated, might also be very regular and exact. Third, several kinds of figures in water frozen. Putting fair water into a large capacious vessel of glass and exposing it to the cold, I observed after a little time several broad, flat, and thin laminae, or plates of ice, crossing the bulk of the water and one another very irregularly, only most of them seemed to turn one of their edges toward that side of the glass which was next it, and seemed to grow as 'twere from the inside of the vessel inwards towards the middle, almost like so many blades of fern. Having taken several of these plates out of water on the blade of a knife, I observed them figured much after the manner of herringbones or fern blades. That is, there was one bigger stem in the middle, like the backbone, and out of it, on either side, there were a multitude of small styria or icicles, like the smaller bones or the smaller branches in fern. Each of these branches on the one side were parallel to all the rest on the same side, and all of them seemed to make an angle with the stem, towards the top of 60 degrees, and towards the bottom or root of the stem of 120. See the fourth figure on the 8th plate. I observed likewise several very pretty varieties of figures in water frozen on the top of a broad flat marble stone, exposed to the cold with a little water on it, some like feathers, some of other shapes. Many of them were very much of the shape expressed in the 5th figure of the 8th scheme, which is extremely differing from any of the other figures. I observed likewise that the shootings of ice on the top of the water, beginning to freeze, were in straight prismatical bodies much like those of rock peter, that they crossed each other, usually without any kind of order or rule, that they were always a little higher than the surface of the water that lay between them, that by degrees those interjacent spaces would be filled with ice also, which usually would be as high as the surface of the rest. In flakes of ice that had been frozen on top of the water to any considerable thickness, I observed that both the upper and the under side of it were curiously quilled, furrowed, or grained, as it were, which, when the sun shone on the plate, was exceedingly easy to be perceived to be much after the shape of the lines in the 6th figure on the 8th scheme. That is, they consisted of several straight ends or parallel plates, which were of divers lengths and angles to one another without any certain order. The cause of all which regular figures, and hundreds of others, namely of salts, minerals, metals, etc., which I could have here inserted, would it not have been too long, seem to be deducible from the same principles which I have in the 13th observation hinted only, having not yet had time to complete a theory of them. But indeed, which I there also hinted, I judge it the second step by which the pyramid of natural knowledge, which is the knowledge of the form of bodies, is to be ascended. And whosoever will climb it must be well furnished with that which the noble Verolarum calls scalam intellectus. He must have scaling ladders, otherwise the steps are so large and high, there will be no getting up them, and consequently little hopes of attaining any higher station, such as to the knowledge or the most simple principles of vegetation manifested in mold or mushrooms, which, as I elsewhere endeavored to shew, seems to be the third step. For it seems to me that the intellect of man is like his body, destitute for wings, and cannot move from a lower to a higher and more sublime station of knowledge, otherwise than step by step, nay, even there where the way is prepared and already made passable, as in the elements of geometry or the like, where it is fain to climb a whole series of propositions by degrees before it attains the knowledge of one problem. But if the ascent be high, difficult, and above its reach, it must have recourse to a novum organum, some new engine or contrivance, some new kind of algebra or analytic art, before it can surmount it. End of section 19.
Section 20 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Section 20. Observation 15. Of Kettering stone and of the pores of inanimate bodies. This stone, which is brought from Kettering in Northamptonshire, and digged out of a quarry, as I am informed, has a grain altogether admirable, nor have I ever seen or heard of any other stone that has the like. It is made up of an innumerable company of small bodies, not all of the same size or shape, but for the most part not much differing from a globular form, nor exceed they one another in diameter above 3 or 4 times. They appear to the eye like the cob or ovary of a herring or some smaller fishes, but for the most part the particles seem somewhat less and not so uniform. But their variation from a perfect globular ball seems to be only by the pressure of the contiguous balls which have a little depressed and protruded those touched sides inward, and forced the other sides as much outwards beyond the limits of a globe, just as it would happen if a heap of exactly round balls of soft clay were heaped upon another, or as I have often seen a heap of small globules of quicksilver, reduced to that form by rubbing it much in a glazed vessel with some slimy or sluggish liquor, such as spittle, when though the top of the upper globules be very near spherical, yet those that are pressed upon by others exactly imitate the forms of these lately mentioned grains. Where these grains touch each other, they are so firmly united or settled together that they seldom part without breaking a hole in one or the other of them, such as A, B, C, etc., some of which fractions, as A, where the touch has been but light, break no more than the outward crust, or first shell of the stone, which is of a white color, a little dashed with a brownish yellow, and is very thin, like the shell of an egg. And I have seen some of those grains perfectly resemble some kind of eggs, both in color and shape. But where the union of the contiguous granules has been more firm, there the divulsion has made a greater chasm, as at B, insomuch that I have observed some of them quite broken in two, as at C, which has discovered to me a further resemblance they have to eggs, they having an appearance of a white and yelk, by two differing substances that envelop and encompass each other. That which we may call the white was pretty whitish near the yelk, but more dusky towards the shell. Some of them I could plainly perceive to be shot or radiated like a pyrites or firestone. The yelk in some I saw hollow, in others filled with a dusky brown and porous substance like a kind of pith. The small pores or interstitia, betwixt the globules, I plainly saw and found by other trials to be every way pervious to air and water, for I could blow through a piece of this stone of a considerable thickness as easily as I have blown through a cane, which minded me of the pores which Descartes allowed his materia subtilis between the ethereal globules. The object through the microscope appears like a congeries, or heap of pebbles, such as I have often seen cast up on the shore, by the working of the sea after a great storm, or like, in shape though not color, a company of small globules of quicksilver looked on with a microscope when reduced into that form by the way lately mentioned. And perhaps this last may give some hint at the manner of the formation of the former, for supposing some lapidescent substance to be generated or some way brought, either by some commixture of bodies in the sea itself, or protruded in, perhaps, out of some subterraneous caverns, to the bottom of the sea, and there remaining in the form of a liquor like quicksilver, heterogeneous to the ambient saline fluid, it may, by the working and tumblings of the sea to and fro, be jumbled and comminuted into such globules as may afterwards be hardened into flints, the lying of which one upon the other, when in the sea, being not very hard, by reason of the weight of the encompassing fluid, may cause the undermost to be a little, though not much, varied by a globular figure. But this only by the by. After what manner this Kettering stone should be generated, I cannot learn, having never been there to view the place and observe the circumstances. But it seems to me from the structure of it to be generated from some substance once more fluid, and afterwards by degrees growing harder, almost after the same manner as I supposed the generation of flints to be made. But whatever were the cause of its curious texture, we may learn this information from it, that even in those things which we account vile, rude, and coarse, nature has not been wanting to show abundance of curiosity and excellent mechanisma. We may here find a stone, by help of a microscope, to be made up of abundance of small balls, which do but just touch each other, and yet there being so many contacts, they make a firm hard mass, or a stone much harder than freestone. Next, though we can by a microscope discern so curious a shape in the particles, yet to the naked eye there scarce appears any such thing, which may afford us a good argument to think that even in these bodies also, whose texture we are not able to discern, though helped with microscopes, there may be yet latent so curious a schematisma, that it may abundantly satisfy the curious searcher who shall be so happy as to find some way to discover it. Next we here find a stone, though to the naked eye a very close one, yet every way perforated with innumerable pores, which are nothing else but the interstitia between those multitudes of minute globular particles that compose the bulk itself, and these pores are not only discovered by the microscope, but by this contrivance. I took a pretty large piece of this stone, and covering it all over with cement, save only at two opposite parts, I found myself able, by blowing in at one end that was left open, to blow my spittle, with which I had wet the other end, into an abundance of bubbles, which argued these pores to be open and pervious through the whole stone, which affords us a very pretty instance of the porousness of some seemingly close bodies, of which kind I shall anon have occasion to subjoin many more, tending to prove the same thing. I must not here omit to take notice that in this body there is not a vegetative faculty that should so contrive this structure for any peculiar use of vegetation or growth, whereas in the other instances of vegetable porous bodies there is an anima, or forma informans, that does contrive all the structures and mechanisms of the constituting body to make them subservient and useful to the great work or function they are to perform. And so I guess the pores in wood and other vegetables, in bones and other animal substances, to be as so many channels, provided by the great and all-wise Creator for the conveyance of appropriated juices to particular parts, and therefore that this may tend or be pervious all towards one part, and may have impediments as valves or the like to any other. But in this body we have very little reason to suspect there should be any such design, for it is equally pervious every way, not only forward, but backwards and sideways, and seems indeed much rather to be a homogeneous or similar to those pores, which may with great probability believe to be the channels of pellucid bodies, not directed or more open any one way than any other, being equally pervious every way. And according to these pores are more or greater in respect of the interstitial bodies, the more transparent are the so constituted concretes. And the smaller those pores are, the weaker is the impulse of light communicated through them, though the more quick be the progress. Upon this occasion, I hope it will not be altogether unseasonable if I propound my conjectures and hypotheses about the medium and conveyance of light. I suppose then that the great part of the interstitia of the world that lies between the bodies of the sun and stars and the planets and the earth to be an exceeding fluid body, very apt and ready to be moved and to communicate the motion of any one part to any other part, though never so far distant, nor do I much concern myself to determine what the figure of the particles of this exceedingly subtle fluid medium must be, nor whether it have any interstitiated pores or vacuities. It being sufficient to solve all the phenomena to suppose it an exceedingly fluid or the most fluid body in the world, and yet impossible to determine the other difficulties. That being so exceeding fluid a body, it easily gives passage to all other bodies to move to and fro in it. That it neither receives from any of its parts or from other bodies, nor communicates to any of its parts or to any other body any impulse or motion in a direct line that is not of a determinate quickness, and that when the motion is of such determinate swiftness, it both receives and communicates or propagates an impulse or motion to any imaginable distance in straight lines with an unimaginable celerity and vigor. That all kinds of solid bodies consist of pretty massive particles in respect of the particles of this fluid medium, which in many places do so touch each other that none of this fluid medium interposes much after the same manner, to use a gross similitude, as a heap of great stones compose one great congeries or mass in the midst of the water. That all fluid bodies, which we may call tangible, are nothing but some more subtle parts of those particles that serve to constitute all tangible bodies. That the water and such other fluid bodies are nothing but a congeries of particles agitated or made fluid by it, in the same manner as the particles of salt are agitated or made fluid by a parcel of water, in which they are dissolved, and subsiding to the bottom of it, constitute a fluid body much more massive and dense and less fluid than the pure water itself. That the air on the other side is a certain company of particles of quite another kind, that is, such as are very much smaller and more easily movable by the motion of this fluid medium, much like those very subtle parts of cochineal, other very deep tinging bodies, whereby a very small parcel of matter is able to tinge and diffuse itself over a very great quantity of the fluid dissolvement, or somewhat after the manner as smoke, and such like minute bodies, or streams, are observed to tinge a very great quantity of air. Only this last similitude is deficient in one propriety, and that is a perpetuity or continuance in that state of commixture with the air. But the former does more nearly approach to the nature and manner of the air's being dissolved by this fluid or ether. And this similitude will further hold in these proprieties, that as those tinctures may be increased by certain bodies, so may they be precipitated by others, as I shall afterwards show it to be very probable that the like accidents happen even to the air itself. Further, as these solutions and tinctures do alter the nature of these fluid bodies, as to their aptness to propagate a motion or impulse through them, even so does the particles of the air, water, and other fluid bodies, and of glass, crystal, etc., which are commixed with this bulk of the ether, alter the motion of the propagated pulse of light. That is, where these more bulky particles are more plentiful, and consequently a lesser quantity of the ether between them to be moved, there the motion must necessarily be the swifter, though not so robust, which will produce those effects which I have, I hope, with some probability, ascribed to it in the digression about colors, at the end of the observations on Muscovy glass. Now that other stones, and those which have the closest and hardest textures, and seem, as far as we are able to discover with our eyes, though helped with the best microscopes, freest from pores, are yet notwithstanding replenished with them, an instance or two will, I suppose, make more probable. A very solid and unflawed piece of clear white marble, if it be well polished and glazed, has so curiously smooth a surface that the best and most polished surface of any wrought glass seems not to the naked eye, nor through a microscope, to be more smooth and less porous. And yet, that this hard, close body is replenished with abundance of pores, I think these following experiments will sufficiently prove. The first is that if you take such a piece, and for a pretty while boil it in turpentine and oil of turpentine, you shall find that the stone will be all imbued with it. And whereas before it looked more white, but more opacious, now it will look more greasy, but be much more transparent. And if you let it lie but a little while, and then break off a part of it, you shall find the unctuous body to have penetrated it to such a determinate depth every way within the surface. This may be yet easier tried with a piece of the same marble a little warmed in the fire, and then a little pitch or tar melted on the top of it. For these black bodies, by their insinuating themselves into the invisible pores of the stone, tinge it with so black a hue that there can be no further doubt of the truth of this assertion, that it abounds with small imperceptible pores. Now that other bodies will also sink into the pores of marble, besides unctuous, I have tried and found that a very blue tincture, made in spirit of urine, would very readily and easily sink into it, as would also several tinctures drawn with spirit of wine. Nor is marble the only seemingly close stone, which by other kinds of experiments may be found porous. For I have by this kind of experiment on divers other stones found much the same effect, and in some, indeed, much more notable. Other stones I have found so porous that with the microscope I could perceive several small winding holes, much like wormholes, as I have noted in some kind of Purbeck stone. By looking on the surface of a piece newly flawed off, for if otherwise the surface has been long exposed to the air or has been scraped with any tool, those small caverns are filled with dust and disappear. And to confirm this conjecture yet further, I shall here insert an excellent account given into the Royal Society by the eminently learned physician Dr. Goddard of an experiment not less instructive than curious and accurate, made by himself on a very hard and seemingly close stone called Oculus Mundi, as I find it preserved in the records of that honorable society. A small stone of the kind, called by some authors Oculus Mundi, being dry and cloudy, weighed 5 and 209 over 256 grains. The same put under water for a night and somewhat more become transparent, and the superficies being wiped dry weighed 6 and 3 over 256 grains. The difference between these two weights, 50 over 256 of a grain. The same stone kept out of water 1 day and becoming cloudy again weighed 5 and 225 over 256 grains, which was more than the first weight, 16 over 256 of a grain. The same being kept 2 days longer weighed 5 and 202 over 256 grains, which was less than at first 7 over 256 of a grain. Being kept dry something longer, it did not grow sensibly lighter. Being put under water for a night and becoming again transparent and wiped dry, the weight was 6 and 3 over 256 grains, the same with the first after putting it in water, and more than the last weight, after keeping of it dry, 57 over 256 of a grain. Another stone of the same kind being variegated with milky white and gray like some sorts of agates, while it lay under water, was always environed with little bubbles, such as appear in water a little before boiling, next the sides of the vessel. There were also some the like bubbles on the surface of the water, just over it, as if either some exhalations came out of it, or that it did excite some fermentation in the parts of the water contiguous to it. There was little sensible difference in the transparency of the stone before the putting under water and after. To be sure, the milky white parts continued as before, but more difference in weight than in the former. For whereas before the putting into the water the weight was 18 and 97/128 grains, after it had lying in about 24 hours the weight was 20 and 27/128 grains. So the difference was 1 and 58/128 grains. The same stone was infused in the water scalding hot, and so continued for a while after it was cold, but got no more weight then upon infusing in the cold, neither was there any sensible difference in the weight both times. In which experiment there are 3 observables that seem very manifestly to prove the porousness of these seemingly close bodies. The first is their acquiring a transparency and losing their whiteness after steeping in water, which will seem the more strongly to argue it, if what I have already said about the making transparent or clarifying of some bodies as the white powder of beaten glass and the froth of some glutinous transparent liquor be well considered. For thereby it will seem rational to think that this transparency arises from the insinuation of the water, which has much the same refraction with such stony particles as may be discovered by sand viewed with a microscope, into those pores which were formerly replete with air, that has a very differing refraction and consequently is very reflective, which seems to be confirmed by the second observable, namely, the increase of weight after keeping and decrease upon drying, and thirdly, seemed yet more sensibly confirmed by the multitude of bubbles in the last experiment. We find also most acid salts very readily to dissolve and separate the parts of this body one from another, which is yet a further argument to confirm the porousness of bodies, and will serve as such to show that even glass also has an abundance of pores in it, since there are several liquors that which long staying in the glass will so corrode and eat into it, as at last to make it pervious to the liquor it contained, of which I have seen very many instances. Since therefore we find by other proofs that many of those bodies which we think the most solid ones, and appear so to our sight, have notwithstanding abundance of those grosser kinds of pores, which will admit several kinds of liquors into them, why should we not believe that glass and other transparent bodies abound with them, since we have many other arguments besides the propagation of light, which seem to argue for it? And whereas it may be objected that the propagation of light is no argument that there are those atomical pores in glass, since there are hypotheses plausible enough to solve those phenomena by supposing the pulse only to be communicated through the transparent body. To this I answer that hypothesis which the industrious Mercenus has published about the slower motion of the end of a ray in a denser medium than in a more rare and thin, seems altogether insufficient to solve abundance of phenomena, of which this is not the least considerable, that it is impossible from that supposition that any colors should be generated from the refraction of the rays. For since by that hypothesis the undulating pulse is always carried perpendicular, or at right angles with the ray, or line of direction, it follows that the stroke of the pulse of light, after it has been once or twice refracted through a prism, for example, must affect the eye with the same kind of stroke as if it had not been refracted at all. Nor will it be enough for a defendant of that hypothesis to say that perhaps it is because the refractions have made the rays more weak, or if so, then 2 refractions in the 2 parallel sides of a quadrangular prism would produce colors, but we have no such phenomenon produced. There are several arguments that I could bring to evince that there are in all transparent bodies such atomical pores, and that there is such a fluid body as I am arguing for, which is the medium or instrument by which the pulse of light is conveyed from the lucid body to the enlightened, but that it being a digression from the observations I was recording about the pores of Kettering stone, it would be too much, such if I should protract it too long, and therefore I shall proceed to the next observation. End of section 20.
Section 21 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Section 21, Observation 16, of charcoal or burnt vegetables. Charcoal, or a vegetable burnt black, affords an object no less pleasant than instructive. For if you take a small round charcoal and break it short with your fingers, you may perceive it to break with a very smooth and sleek surface, almost like the surface of black sealing wax. This surface, if it be looked on with an ordinary microscope, does manifest abundance of those pores which are also visible to the eye in many kinds of wood, ranged round the pith, both in a kind of circular order and a radiant one. Of these there are a multitude in the substance of the coal, everywhere almost perforating and drilling it from end to end, by means of which, be the coal never so long, you may easily blow through it, and this you may presently find by wetting one end of it with spittle and blowing at the other. But this is not all, for besides these many great and conspicuous irregular spots or pores, if a better microscope be made use of, there will appear an infinite company of exceedingly small and very regular pores, so thick and so orderly set, and so close to one another, that they leave very little room or space between them to be filled with a solid body, for the apparent interstitia or separating sides of these pores seem so thin in some places that the texture of a honeycomb cannot be more porous. Though this be not everywhere so, the intercurrent partitions in some places being very much thicker in proportion to the holes. Most of these small pores seemed to be pretty round, and were ranged in rows that radiated from the pith to the bark. They all of them seemed to be continued open pores, running the whole length of the stick, and that they were all perforated. I tried by breaking off a very thin sliver of the coal crosswise, and then with my microscope, diligently surveying them against the light, for by that means I was able to see quite through them. These pores were so exceedingly small and thick, that in a line of them, 1/18th part of an inch long, I found by numbering them no less than 150 small pores, and therefore in a line of them an inch long, must be no less than 2,700 pores, and in a circular area of an inch diameter must be about 5,725,350 of the like pores, so that a stick of an inch diameter may contain no less than 725,000 besides 5,000,000 of pores, which would, I doubt not, seem very incredible were not every one left to believe his own eyes. Nay, having since examined crocus, black and green ebony, lignum verte, etc., I found that all these woods have their pores, abundantly smaller than those of soft light wood, insomuch that those above Gauchacum seemed not above an 1/8th part of the bigness of the pores of beech, but that the interstitia were thicker. So prodigiously curious are the contrivances, pipes, or sluices by which the succus nutritius, or juice of a vegetable, is conveyed from place to place. This observation seems to afford us the true reason for several phenomena of coals, as, first, why they look black. And for this we need go no further than the scheme, for certainly a body that has so many pores in it as this is discovered to have, from each of which no light is reflected, must necessarily look black, especially when the pores are somewhat bigger in proportion to the intervals than they are cut in the scheme, black being nothing else but a privation of light, or a want of reflection. And wheresoever this reflecting quality is deficient, there does that part look black, whether it be from a porousness of the body, as in this instance, or in a deadening and dulling quality, such as I have observed in the scoria of lead, tin, silver, copper, etc. Next, we may also as plainly see the reason of its shining quality, and that is from the even breaking off of the stick, the solid interstitia having a regular termination or surface, and having a pretty strong reflecting quality that many small reflections become united to the naked eye, and make a very pretty shining surface. Third, the reason of its hardness and brittleness seems evident, for since all the watery or liquid substance that moistened and toughened these interstitia for the most solid parts are evaporated and removed, that which is left behind becomes of the nature almost of a stone, which will not at all, or very little, bend without a divulsion or solution of its continuity. It is not my design at present to examine the use and mechanisms of these parts of wood, that being more proper to another inquiry, but rather to hint that from this experiment we may learn, first, what is the cause of the blackness of many burnt bodies, which we may find to be nothing else but this, that the heat of the fire agitating and rarefying the waterish, transparent, and volatile water that is contained in them, by the continuation of that action does so totally expel and drive away all that which before filled the pores, and was dispersed also through the solid mass of it, and thereby caused a universal kind of transparency, that it not only leaves all the pores empty, but all the interstitia are also dry and opacous, and perhaps also yet further perforated, that light only is reflected back which falls upon the very outward edges of the pores, all they that enter into the pores of the body, never returning, but being lost in it. Now, that the charring or coaling of a body is nothing else, may be easily believed by one that shall consider the means of its production, which may be done after this, or any such manner. The body to be charred or coaled may be put into a crucible, pot, or any other vessel that will endure to be made red hot in the fire without breaking, and then covered over with sand, so as no part of it will be suffered to be open to the air, then set into a good fire, and there kept till the sand has continued red hot for a quarter, half, an hour or two, or more, according to the nature and bigness of the body to be coaled or charred, then taking it out of the fire and letting it stand till it be quite cold. The body may be taken out of the sand well charred and cleansed of its waterish parts, but in the taking of it out care must be had that the sand be very near cold, for else, when it comes into the free air, it will take fire and readily burn away. This may be done also in any closed vessel of glass, as a retort, or the like, and the several fluid substances which come over may be received in a fit recipient, which will yet further countenance this hypothesis. And their manner of charring wood in great quantity comes much to the same thing, namely, an application of a great heat to the body, and preserving it from the free access of the devouring air. This may be easily learned from the history of charring of coal, most excellently described and published by that most accomplished gentleman, Mr. John Evelyn, in the 100, 101, 103 pages of his Silva, to which I shall therefore refer the curious reader that desires a full information of it. Next, we may learn what part of the wood it is that is the combustible matter, for since we shall find that none, or very little of those fluid substances that are driven over into the receiver are combustible, and that most of that which is left behind is so, it follows that the solid interstitia of the wood are the combustible matter. Further, the reason why uncharred wood burns with a greater flame than that which is charred, as is evident, because those waterish or volatile parts issuing out of the fired wood, every way, not only shatter and open the body, the better for the fire to enter, but issuing out in vapours and wind, they become like so many aeolipils, or bellows, whereby they blow and agitate the fired part, and conduce to the more speedy and violent consumption or dissolution of the body. Third, from the experiment of charring of coals, whereby we see that notwithstanding the great heat and the duration of it, the solid parts of the wood remain, whilst they are preserved from the free access of the air undissipated, we may learn that which has not, that I know of, been published or hinted, nay, not so much as thought of by any, and that, in short, is this. First, that the air in which we live, move, and breathe, and which encompasses very many and cherishes most bodies it encompasses, that this air is the menstruum or universal dissolvent of all sulphurous bodies. Second, that this action it performs not, till the body be first sufficiently heated, as we find requisite also to the dissolution of many other bodies by several other menstruums. Third, that this action of dissolution produces or generates a very great heat, and that which we call fire, and this is common also to many dissolutions of other bodies made by menstruums, of which I could give multitudes of instances. Fourth, that this action is performed with so great a violence, and does so minutely act and rapidly agitate the smallest parts of the combustible matter, that it produces in the diaphanous medium of the air the action or pulse of light, which what it is I have elsewhere already shown. Fifthly, that the dissolution of sulphurous bodies is made by a substance inherent and mixed with the air, That is like, if not the very same, with that which is mixed in saltpetre, which by multitudes of experiments that may be made with saltpetre will, I think, most evidently be demonstrated. Sixthly, that this dissolution of bodies by the air, a certain part is united and mixed, or dissolved, and turned into the air, and made to fly up and down with it in the same manner as a metalline or other body dissolved into any menstruums, does follow the motions and progress of that menstruum till it be precipitated. Seventhly, that as there is one part that is dissolvable by the air, so there are other parts with which the part of the air mixing and uniting do make a coagulum, or precipitation, as one may call it, which causes it to be separated from the air. But this precipitate is so light, and in so small and rarefied or porous clusters, that it is very volatile, and is easily carried up by the motion of the air, though afterwards, when the heat and agitation that kept it rarefied ceases, it easily condenses, and commixed with other indissolvable parts, it sticks and adheres to the next body it meets withal, and this is a certain salt that may be extracted out of soot. Eighthly, that many dissolvable parts are very apt and prompt to be rarefied, and so, whilst they continue in that heat and agitation, are lighter than the ambient air, are thereby thrust and carried upward with great violence, and by that means carry along with them, not only that saline concrete I mentioned before, but many terrestrial, or indissoluble and irrarefiable parts, nay, many parts also which are dissolvable, but which are not suffered to stay long enough in a sufficient heat to make them prompt and apt for that action. And therefore we find in soot, not only a part, that being contained longer in a competent heat, will be dissolved by the air, or take fire and burn, but a part also which is fixed, terrestrial, and irrefirable. Ninth, that there are as these several parts that will rarefy and fly, or be driven up by the heat, so are there many others, that as they are indissolvable by the aerial menstruum, so are they of such sluggish and gross parts, that they are not easily rarefied by heat, and therefore cannot be raised by it, the volatility or fixedness of a body seeming to consist only in this, that the one is of a texture, or has component parts that will be easily rarefied into the form of air, and the other, that it has such as will not, without much ado, be brought to such a constitution, and this is that part which remains behind in a white body called ashes, which contains the substance, or salt, which chemists call alkali. What the particular natures of each of these bodies are, I shall not here examine, intending it in another place, but shall rather add that this hypothesis does so exactly agree with all phenomena of fire, and so genuinely explicate each particular substance that I have hitherto observed, that it is more than probable that this cause which I have assigned is the true, adequate, real, and only cause of these phenomena, and therefore I shall proceed a little further to show the nature and use of the air. Tenthly, therefore, the dissolving parts of the air are but few, that is, it seems of the nature of those saline menstruums, or spirits, that have very much phlegmy mixed with the spirits, and therefore a small parcel of it is quickly glutted, and will dissolve no more, and therefore unless some fresh part of this menstruum be applied to the body to be dissolved, the action ceases, and the body leaves to be dissolved and to shine, which is the indication of it, though placed or kept in the greatest heat, whereby saltpetre is a menstruum, when melted and red hot, that abounds more with these dissolvent particles, and therefore as a small quantity of it will dissolve a great sulphurous body, so will the dissolution be very quick and violent. Therefore, in the 11th place, it is observable that, as in other solutions, if a copious and quick supply of fresh menstruum, though but weak, be poured on or applied to the dissolvable body, it quickly consumes it. So this menstruum of the air, if by bellows or any other such contrivance, it be copiously applied to the shining body, is found to dissolve it as soon and as violently as the more strong menstruum of melted nitre. Therefore, 12thly, it seems reasonable to think that there is no such thing as an element of fire that should attract or draw up the flame, or toward which the flame should endeavour to ascend out of a desire or appetite of uniting with that as its homogeneal primitive and generating element, but that shining transient body which we call flame is nothing else but a mixture of air and volatile sulphurous parts of dissolvable or combustible bodies, which are acting upon each other whilst they ascend, that is, flame seems to be a mixture of air and the combustible volatile parts of any body, which parts the encompassing air does dissolve or work upon, which action, as it does intend the heat of the aerial parts of the dissolvent, so does it thereby further ratify these parts that are acting, or that are very near them, whereby they, growing much lighter than the heavy parts of that menstruum that are more remote, are thereby protruded and driven upward, and this may be easily observed also in dissolution made by any other menstruum, especially such as either create heat or bubbles. Now this action of the menstruum, or air, on the dissolvable parts, is made with such violence, or is such, that it imparts such motion and pulse to the diaphanous parts of the air, as I have elsewhere shown is requisite to produce light. This hypothesis I have endeavoured to raise from an infinite of observation and experiments, the process of which would be much too long to be here inserted, and will perhaps another time afford matter copious enough for a much larger discourse, the air being a subject which, though all the world has hitherto lived and breathed in, and been very unconversant about, has yet been so little truly examined or explained, that a diligent inquirer will be able to find but very little information from that which has been, till of late, written of it. But being once well understood, it will, I doubt not, enable a man to render an intelligible, nay probable, if not the true reason of all, the phenomena of fire, which, as it has been found by writers and philosophers of all ages a matter of no small difficulty, as may be sufficiently understood by their strange hypotheses and unintelligible solutions of some few phenomena of it, so will it prove a matter of no small concern and use in humane affairs, as I shall elsewhere endeavour to manifest when I come to show the use of the air in respiration, and for the preservation of the life, nay, for the conservation and restoration of the health and natural constitution of mankind, as well as all other aerial animals, and also the uses of this principle or property of the air in chemical, mechanical, and other operations. In this place I have only time to hint a hypothesis, which, if God permit me life and opportunity, I may elsewhere prosecute, improve, and publish. In the meantime, before I finish this discourse, I must not forget to acquaint the reader that having had the liberty granted me of making some trials on a piece of lignum falsale, shown to the Royal Society by the eminent ingenious and learned physician Dr. Int, who received it for a present from the famous Ingenioso Cavaliero du Ponzi, it being one of the fairest and best pieces of the lignum falsale he had seen. Having, I say, taken a small piece of this wood and examined it, I found it to burn in the open air almost like other wood, and instead of a resinous smoke or fume, it yielded a very bituminous one, smelling much of that kind of scent. But that which I chiefly took notice of was, that cutting off a small piece of it, about the bigness of my thumb, and charring it in a crucible with sand, after the manner I above prescribed, I found it infinitely to abound with the smallest sort of pores, so extremely thick, and so regularly perforating the substance of it long ways, that breaking it off across, I found it to look very like a honeycomb. But as for any of the second or bigger kind of pores, I could not find that it had any, so that it seems, whatever were the cause of its production, it was not without those small kinds of pores which we have only hitherto found in vegetable bodies, and comparing them with the pores which I found in the charcoals that I by this means made of several other kinds of wood, I find it resembled none so much as those of fire, to which it is not much unlike in grain also, and several other properties. And therefore, whatever is by some, who have written of it, and particularly by Francisco Stoluto, wrote a treatise in Italian of that subject, which was printed in Rome, 1637, affirm that it is a certain kind of clay or earth, which in tract of time is turned into wood. I rather suspect the quite contrary, that it was at first certain great trees of fir or pine, which by some earthquake or other casualty came to be buried under the earth, and was there, after a long time's residence, according to the several natures of the encompassing adjacent parts, either rotted and turned into a kind of clay, or petrified and turned into a kind of stone, or else had its pores filled with certain mineral juices, which being stayed in them, and in tract of time coagulated, appeared, upon cleaving out, like small metalline wires, or else from some flames or scorching forms that are the occasion oft times, and usually accompany earthquakes, might be blasted and turned into coal, or else from certain subterraneous fires, which are affirmed by that author to abound much about those parts, namely in a province of Italy, called Umbria, now the Duchy of Spolato, in the territory of Todi, anciently called Tudor, and between the two villages of Colleseco and Rosaro, not far distant from the highway leading to Rome, where it is found in greater quantity than elsewhere, are by reason of their being encompassed with earth, and so kept close from the dissolving air, charred and converted into coal. It would be too long a work to describe the several kinds of pores which I met withal, and by this means discovered in several other vegetable bodies. Nor is it my present design to expatiate upon instances of the same kind, but rather to give a specimen of as many kinds as I have had opportunity as yet of observing, reserving the prosecution and enlarging on particulars till a more fit opportunity, and in prosecution of this design, I shall here add. End of section 21. Recording by Todd.
Section 22 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Larry Wilson. Micrographia by Robert Hooke. Observation 17. Of petrified wood and other petrified bodies. Of this sort of substance I observed several pieces of very differing kinds, both for their outward shape, color, grain, texture, hardness, etc., some being brown and reddish, others gray, like a hone, others black and flint-like, some soft like a slate or whetstone, others as hard as a flint, and as brittle. That which I more particular examined was a piece about the bigness of a man's hand, which seemed to have been a part of some large tree, that by rottenness had been broken off from it before it began to be petrified. And indeed all that I have yet seen seemed to have been rotten wood before the petrification was begun. And not long since, examining and viewing a huge great oak that seemed with mere age to be rotten as it stood, I was very much confirmed in this opinion. For I found that the grain, color, and shape of the wood was exactly like this petrified substance. And with a microscope I found that all those microscopical pores which in sappy or firm and sound wood are filled with the natural or innate juices of those vegetables, in this they were all empty, like those of vegetables charred, but with this difference, that they seemed much larger than I have seen in any charcoals, nay, even than those of coals made of great blocks of timber, which are commonly called old coals. The reason of which difference may probably be that the charring of vegetables being an operation quickly performed, and whilst the wood is sappy, the more solid parts may more easily shrink together and contract the pores or interstitia between them, than in rotten wood, where that natural juice seems only to be washed away by adventitious or unnatural moisture. And so, though the material may be wasted from beneath the firm parts, yet those parts are kept asunder by adventitious moistures, and so by degrees settled in those postures. And this I likewise found in the petrified wood, that the pores were somewhat bigger than those of charcoal, each pore being near up half as big again, but they did not bear the disproportion which is expressed in the tenth scheme between the small specks or pores in the first figure, which representeth the pores of coal or wood charred, and the black spots of the second figure, which represent like microscopical pores in the petrified wood, for these last were drawn by a microscope, that magnified the object over 6 times more in diameter than the microscope by which those pores of coal were observed. Now, though they were a little bigger, yet did they keep the exact figure and order of pores of coals and of rotten wood, which last also were much of the same size. The other observations on this petrified substance that a while since by the appointment of the Royal Society I made, and presented to them an account of, were these that follow, which had the honour done them by the most accomplished Mr. Evelyn, my highly honoured friend, to be inserted and published among those excellent observations wherewith his Silva is replenished, and would therefore have been here omitted, had not the figure of them, as they appeared through the microscope, been before that engraven. This petrified substance resembled wood in that, first, all the parts of it seemed not at all dislocated or altered from their natural position, whilst they were wood, but the whole piece retained the exact shape of wood, having many of the conspicuous pores of wood still remaining pores, and showing a manifest difference visible enough between the grain of the wood and that of the bark, especially when any side of it was cut smooth and polite, for then it appeared to have a very lovely grain, like that of some curious close wood. Next, it resembled wood, in that all the smaller, and if I may so call those which are only visible with a good magnifying glass, microscopical pores of it appear, both when the substance is cut and polished transversely and parallel to the pores of it, perfectly like the microscopical pores of several kinds of wood, especially like and equal to those of several sorts of rotten wood which I have since observed, retaining both the shape, position, and magnitude of such pores. It was differing from wood, first, in weight, being to common water as 3 1/4 to 1, whereas there are few of our English woods that when very dry are found to be full as heavy as water. Second, in hardness, being very near as hard as flint, and in some places of it also resembling the grain of a flint, and like it would very readily cut glass, and would not without difficulty, especially in some parts of it, be scratched by a black hard flint. It would also as readily strike fire against a steel, or against a flint, as any common flint. Thirdly, in the closeness of it. For though all the microscopical pores of this petrified substance were very conspicuous in one position, yet by altering that position of the polished surface to the light, it was also manifest that those pores appeared darker than the rest of the body only because they were filled up with a more dusky substance and not because they were hollow. Fourthly, in its incombustibleness, in that it would not burn in the fire. Nay, though I kept it a good while red hot in the flame of a lamp, made very intense by the blast of a small pipe, and a large charcoal, yet it seemed not at all to have diminished its extension, but only I found it to have changed its colour, and to appear of a more dark and dusky brown colour, nor could I perceive that those parts which seemed to have been wood at first were anything wasted, but the parts appeared as solid and close as before. It was further observed also that as it did not consume like wood, so neither did it crack and fly like a flint, or such like hard stone, nor was it long before it appeared red hot. Fifthly, its dissolubleness. For putting some drops of distilled vinegar upon the stone, I found it presently to yield very many bubbles, just like those which may be observed in spirit of vinegar when it corrodes corals, though perhaps many of those small bubbles might proceed from some small parcels of air which were driven out of the pores of this petrified substance by the insinuating liquid menstruum. Sixthly, in its rigidness and friability, being not at all flexible but brittle like a flint, insomuch that I could with one knock of a hammer break off a piece of it, and with a few more reduce it into a pretty fine powder. Seventhly, it seemed also very differing from wood to the touch, feeling more cold than wood usually does, and much like other close stones and minerals. The reasons of all which phenomena seem to be, that petrified wood having lain in some place where it was well soaked with petrifying water, that is, such a water as is well impregnated with stony and earthy particles, did by degrees separate, either by straining and filtration, or perhaps by precipitation, cohesion, and coagulation, abundance of stony particles from the permeating water, which stony particles being by means of the fluid vehicle conveyed, not only into the microscopical pores, and so perfectly stopping them, but also into the pores or interstitia, by which may perhaps be even in the texture or schematisme of that part of the wood which through the microscope appears most solid, do thereby so augment the weight of the wood as to make it above 3 times heavier than water, and perhaps 6 times as heavy as it was when wood. Next, they thereby so lock up and fetter the parts of the wood that the fire cannot easily make them fly away, but the action of the fire upon them is only able to char those parts, as it were, like a piece of wood, if it be closed very fast up in clay, and kept a good while red hot in the fire, will by the heat of the fire be charred and not consumed, which may perhaps also be somewhat of the cause why the petrified substance appeared of a dark brown color after it had been burnt. By this intrusion of the petrifying particles, this substance also becomes hard and friable, and in the smaller pores of the wood, being perfectly wedged and stuffed up with those stony particles, the small parts of the wood have no place or pores into which they may slide upon bending, and consequently little or no flexion or yielding at all can be caused in such a substance. The remaining particles likewise of the wood among the stony particles may keep them from cracking and flying when put into the fire, as they are very apt to do in a flint. Nor is wood the only substance that may by this kind of transmutation be changed into stone. For I myself have seen and examined very many kinds of substances, and among very credible authors we may meet with histories of such metamorphoses wrought almost on all kinds of substances, both vegetable and animal, which histories it is not my business at present either to relate or epitomize, but only to set down some observation I had lately made on several kinds of petrified shell found about Kensham, which lies within 4 or 5 miles of Bristol, which are commonly called serpentine stones. Examining several of these very curiously figured bodies, which are commonly thought to be stones formed by some extraordinary plastic virtue latent in the earth itself, I took notice of these particulars. First, that these figured bodies or stones were of very differing substances as to hardness, some of clay, some of marl, some of soft stone. Almost all of the hardness of those soft stones, which masons call firestone, others as hard as Portland stone, others as hard as marble, and some as hard as flint or crystal. Next, they were of very differing substances as to transparency and color. Some white, some almost black, some metalline or like marcasites, some transparent like white marble, others like flawed crystal, some gray, some diverse colors, some radiated like those long petrified drops, which are commonly found at the peak and in other subterraneous caverns, which have a kind of pith in the middle. Thirdly, that they were very different as to the manner of their outward figuration, for some of them seemed to have been the substance that had filled the shell of some kind of shellfish, others to have been the substance that had contained or enwrapped one of those shells, on both which the perfect impression either of the inside or outside of such shells seems to be left, but for the most part those impressions seem to be made by an imperfect or broken shell, the great end or mouth of the shell being always wanting, and oftentimes the little end, and sometimes half, and in some there were impressions just as if they had been holes broken in the figurating, imprinting, or moulding shell. Some of them seemed to be made by such a shell very much bruised or flawed, insomuch that one would verily have thought that very figured stone had been broken or bruised, whilst the jelly were twere and so hardened, but within the grain of the stone there appeared not the least sign of any such bruise or breaking, but only on the very uttermost superficies. Fourthly, they were very different as to their outward covering, some having the perfect shell both in figure, color, and substance sticking on upon its surface, and adhering to it, but might very easily be separated from it, and like other common cockle or scallop shells, which some of them most accurately resembled, were very dissoluble in common vinegar. Others of them, especially those serpentine or helical stones, were covered or retained the shining or pearl-colored substance of the inside of a shell, which substance on some parts of them was exceeding thin, and might very easily be rubbed off. On other parts was pretty thick, and retained a white coat, or flaky substance on top, just like the outside of such shells. Some of them had very large pieces of the shell very plainly sticking onto them, which were easily to be broken or flaked off by degrees. They likewise, some of them, retained all along the surface of them very pretty kind of sutures, such as are observed in the skulls of several kinds of living creatures, which sutures were most curiously shaped in the manner of leaves, and every one of them in the same shell, exactly like one another, which I was able to discover plainly enough with my naked eye, but more perfectly and distinctly with my microscope. All these sutures, by breaking some of these stones, I found to be termini, or boundings of certain diaphragms, or partitions, which seemed to divide the cavity of the shell into a multitude of very proportionate and regular cells or caverns. These diaphragms, in many of them, I found very perfect and complete, of a very distinct substance from that which filled the cavities, and exactly the same kind with that which covered the outside, being for the most part whitish or mother of pearl colored. As for the cavities between those diaphragms, I found some of them filled with marl, and others with several kinds of stones, others for the most part hollow, only the whole cavity was usually covered over with a kind of tartareous petrified substance, which stuck about the sides, and was there shot into every curious regular figures, just as tartar or other dissolved salts are observed to stick and crystallize about the sides of the containing vessels, or like those little diamonds, which I before observed to have covered the vaulted cavity of a flint. Others had these cavities all lined with a kind of metalline or marcasite-like substance, which with a microscope I could as plainly see most curiously and regularly figured as I had done those in a flint. From all which and several other particulars which I observed, I cannot but think that all these, and most other kinds of stony bodies which are found thus strangely figured, do owe their formation and figuration, not to any kind of plastic virtue inherent in the earth, but to the shells of certain shellfishes, which either by some deluge, inundation, earthquake, or some such other means, came to be thrown to that place, and there be filled with some kind of mud or clay, or petrified water, or some other substance, which in tract of time has been settled together and hardened in those shelly moulds into those shaped substances we now find them. That the great and thin end of these shells, by that earthquake, or whatever other extraordinary cause it was that brought them thither, was broken off, and that many others were otherwise broken, bruised, and disfigured, that these shells which are thus spiraled, and separated with diaphragms, were some kind of nautili or porcelain shells, and that others were shells of cockles, mussels, periwinkles, scallops, etc., of various sorts. That these shells in many, from the particular nature of the containing or enclosed earth, or some other cause, have in tract of time rotted and mouldered away, and only left their impressions both on the containing and contained substances, and so left them pretty loose one within another, so that they may be easily separated by a knock or two of a hammer. That others of these shells, according to the nature of the substances adjacent to them, have by a long continuance in that posture been petrified and turned into the nature of stone, just as I even now observe several sorts of wood to be. That oftentimes the shell may be found with one kind of substance within, and quite another without, having perhaps been filled in one place, and afterwards translated to another, which I have very frequently observed in cockle, mussel, periwinkle, and other shells, which I have found by the seaside. Nay, further, that some parts of the same shell may be filled in one place, and some other caverns in another, and others in a third, or fourth, or fifth place, for so many differing substances have I found in one of these petrified shells, and perhaps all these differing from the encompassing earth or stone. The means how all which varieties may be caused, I think, will not be difficult to conceive to any one that has taken notice of those shells which are commonly found on the seashore. And he that shall thoroughly examine several kinds of such curiously formed stones will, I am very apt to think, find reason to suppose their generation or formation to be ascribable to some such accidents as I have mentioned, and not to any plastic virtue. For it seems to me quite contrary to the infinite prudence of nature, which is observable in all its works and productions, to design everything to a determinate end, and for the attaining of that end makes use of such ways as are, as far as the knowledge of man has yet been able to reach, altogether consonant and most agreeable to man's reason, and of no way or means that does contradict or is contrary to humane ratiocination. Whence it has a long time been a general observation and maxim that nature does nothing in vain. It seems, I say, contrary to that great wisdom of nature, that these prettily shaped bodies should have all those curious figures and contrivances, which many of them are adorned and contrived with, generated or wrought by a plastic virtue, for no higher end than only to exhibit such a form, which he that shall thoroughly consider all circumstances of such kind of figured bodies will, I think, have great reason to believe, though I confess one cannot presently be able to find out what nature's designs are. It were therefore very desirable that a good collection of such kind of figured stones were collected, and as many particulars, circumstances, and informations collected with them as could be obtained, that from such a history of observations well ranged, examined, and digested, the true original or production of all those kinds of stones might be perfectly and surely known. Such are thunderstones, lapidis stellares, lapidis judicae, and multitudes of other, whereof mention is made in Aldanandus Wormius and other writers of minerals. End of section 22.
Section 23 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Section 23. Observation 18. of the schematism or texture of cork, and of the cells and pores of some other such frothy bodies. I took a good clear piece of cork, and with a penknife sharpened as keen as a razor, I cut a piece of it off, and thereby left the surface of it exceeding smooth. Then examining it very diligently with a microscope, methought I could perceive it to appear a little porous. But I could not so plainly distinguish them as to be sure that they were pores, much less what figure they were of. But judging from the lightness and yielding quality of the cork, that certainly the texture could not be so curious, but that possibly, if I could use some further diligence, I might find it to be discernible with a microscope, I, with the same sharp penknife, cut off from the former smooth surface an exceeding thin piece of it, and placing it on a black object plate, because it was itself a white body, and casting the light on it with a deep plano-convex glass, I could exceeding plainly perceive it to be all perforated and porous, much like a honeycomb, but that the pores of it were not regular, yet it was not unlike a honeycomb in these particulars. First, in that it had a very little solid substance in comparison of the empty cavity that was contained between, as does more manifestly appear by the figure A and B of the 11 scheme. For the interstitia, or walls, as I may so call them, or partitions of those pores were near as thin in proportion to their pores as those thin films of wax in a honeycomb, which enclose and constitute the sexangular cells, are to theirs. Next, in that these pores or cells were not very deep, but consisted of a great many little boxes, separated out of one continued long pore by certain diaphragms, as is visible by the figure B, which represents a sight of those pores split the long ways. I no sooner discerned these, which were indeed the first microscopical pores I ever saw, and perhaps that were ever seen, for I had not met with any writer or person that had made any mention of them before this, but methought I had with the discovery of them presently hinted to me the true and intelligible reason of all the phenomena of cork. As first, if I inquired why it was so exceeding light a body, my microscope could presently inform me that here was the same reason evident that there is found for the lightness of froth, an empty honeycomb, wool, a sponge, a pumice stone, or the like, namely, a very small quantity of a solid body, extended into exceeding large dimensions. Next, it seemed nothing more difficult to give an intelligible reason why cork is a body so very unapt to suck and drink in water, and consequently preserves itself floating on the top of water, though left on it never so long, and why it is able to stop and hold air in a bottle, though it be there very much condensed, and consequently presses very strongly to get a passage out, without suffering the least bubble to pass through its substance. For, as to the first, since our microscope informs us that the substance of cork is altogether filled with air, and that that air is perfectly enclosed in little boxes or cells distinct from one another, it seems very plain why neither the water nor any other air can easily insinuate itself into them, since there is already within them an intus existence, and consequently why the pieces of cork become so good floats for nets and stopples for vials or other close vessels. And thirdly, if we inquire why cork has such a springiness and swelling nature when compressed, and how it comes to suffer so great a compression or seeming penetration of dimensions, so as to be made a substance as heavy again and more bulk for bulk as it was before compression, and yet suffered to return, is found to extend itself again into the same space. Our microscope will easily inform us that the whole mass consists of an infinite company of small boxes or bladders of air, which is a substance of a springy nature, and that will suffer a considerable condensation, as I have several times found by diverse trials, by which I have most evidently condensed it into less than a 20th part of its usual dimensions near the earth, and that with no other strength than that of my hands, without any kind of forcing engine, such as racks, levers, wheels, pulleys, or the like, but this only by and by. And besides, it seems very probable that those very films or sides of the pores have in them a springing quality, as almost all other kind of vegetable substances have, so as to help to restore themselves to their former position. And could we so easily and certainly discover the schematism and texture even of these films, and of several other bodies, as we can these of cork, there seems no probable reason to the contrary, but that we might as readily render the true reason of all their phenomena, as namely, what were the cause of the springiness and toughness of some, but as to their flexibility and restitution. What, of the friability or brittleness of some others and the like, but till such time as our microscope or some other means enable us to discover the true schematism and texture of all kinds of bodies, we must grope, as it were, in the dark, and only guess at the true reasons of things by similitudes and comparisons. But to return to our observation, I told several lines of these pores and found that there were usually about 80 of these small cells placed endways in the 18th part of an inch in length, whence I concluded there must be near 1100 of them, or somewhat more than 1,000 in the length of an inch, and therefore in a square inch above 1,000,000, or 1,166,400, and in a cubic inch above 1,200 millions, or 1,259,712,000. A thing almost incredible, did not our microscope assure us of it by ocular demonstration? Nay, did it not discover to us the pores of a body, which, were they diaphragmed, like those of cork, would afford us in 1 cubic inch more than 10 times as many little cells, as is evident in several charred vegetables? So prodigiously curious are the works of nature, that even these conspicuous pores of bodies, which seem to be the channels or pipes through which the succus nutritius, or natural juices of vegetables, are conveyed, and seem to correspond to the veins, arteries, and other vessels in sensible creatures, that these pores, I say, which seem to be the vessels of nutrition to the vastest body in the world, are yet so exceeding small, that the atoms which Epicurus fancied would go near to prove too big to enter them, much more to constitute a fluid body in them. And how infinitely smaller, then, must be the vessels of a mite, or the pores of one of those little vegetables I have discovered to grow on the backside of a rose leaf, and shall anon more fully describe, whose bulk is many millions of times less than the bulk of the small shrub it grows on, and even that shrub many millions of times less in bulk than several trees that have heretofore grown in England, and are this day flourishing in other hotter climates, as we are very credibly informed, if at least the pores of this small vegetable should keep any such proportion to the body of it, as we have found these pores of other vegetables to do to their bulk. But of these pores I have said more elsewhere. To proceed, then, cork seems to be, by the transverse constitution of the pores, a kind of fungus or mushroom, for the pores lie like so many rays tending from the center or pith of the tree outwards, so that if you cut off a piece from a board of cork transversely to the flat of it, you will, as it were, split the pores, and they will appear just as they are expressed in the figure B of the 11 scheme. But if you shave off a very thin piece from this board, parallel to the plane of it, you will cut all the pores transversely, and they will appear almost as they are expressed in the figure A, save only the solid interstitia will not appear so thick as they are there represented. So that cork seems to suck its nourishment from the subjacent bark of the tree immediately, and to be a kind of excrescence, or a substance distinct from the substances of the entire tree, something analogous to the mushroom or moss on other trees, or to the hairs on animals. And having inquired into the history of cork, I find it reckoned as an excrescency of the bark of a certain tree, which is distinct from the 2 barks that lie within it, which are common also to other trees, that 'tis some time before the cork that covers the young and tender sprouts comes to be discernible, that it cracks, flaws, and cleaves into many great chaps, the bark underneath remaining entire, that it may be separated and removed from the tree, and yet the two underbarks, such as are also common to that with other trees, not at all injured, but rather helped and freed from an external injury. Thus, Johnstonus in Dendrologia, speaking de subere, says, Arbor est procera, lignum est robustum, dempto cortica in aquis non fluitat, cortica in orbem detracto huator, crascescens enim praestringit et strangulat, intra triennium iterum repletor, caudax ubi adolescit crassus, cortex superior densus carnosus, duos digitos crassus, scaber rimosus, et qui nisi detrahator dehiscit, alioque subnascente expellitor. Interior qui subest novellos ita rubet ut arbor minio picta videator. Which histories, if well considered, and the tree, substance, and manner of growing, if well examined, would, I am very apt to believe, much confirm this my conjecture about the origination of cork. Nor is this kind of texture peculiar to cork only, for upon examination with my microscope, I have found that the pith of an elder, or almost any other tree, the inner pulp or pith of the caney hollow stalks of several other vegetables, as of fennel, carrots, daucus, burdocks, teasels, fern, some kinds of reeds, etc., have much such a kind of schematism as I have lately shown that of cork, save only that here the pores are ranged the long ways, or the same ways with the length of the cane, whereas in cork they are transverse. The pith also that fills that part of the stalk of a feather that is above the quill has much such a kind of texture, save only that which way soever I set this light substance, the pores seem to be cut transversely, so that I guess this pith which fills the feather not to consist of abundance of long pores separated with diaphragms, as cork does, but to be a kind of solid or hardened froth, or a congeries of very small bubbles consolidated in that form, into a pretty stiff as well as tough concrete, and that each cavern, bubble, or cell is distinctly separate from any of the rest, without any kind of hole in the encompassing films, so that I could no more blow through a piece of this kind of substance than I could through a piece of cork, or the sound pith of an elder. But though I could not with my microscope, nor with my breath, nor any other way I have yet tried, discover a passage out of one of those cavities into another, yet I cannot thence conclude that therefore there are none such, by which the succus nutritius, or appropriate juices of vegetables, may pass through them. For, in several of those vegetables, whilst green, I have with my microscope plainly enough discovered these cells or pores filled with juices, and by degrees sweating them out, as I have also observed in green wood all those long microscopical pores which appear in charcoal perfectly empty of anything but air. Now, though I have with great diligence endeavored to find whether there be any such thing in those microscopical pores of wood or piths, as the valves in the heart, veins, and other passages of animals, that open and give passage to the contained fluid juices one way, and shut themselves, and impede the passage of such liquors back again, yet have I not hitherto been able to say anything positive in it, though methinks it seems very probable that nature has in these passages, as well as in those of animal bodies, very many appropriated instruments and contrivances, whereby to bring her designs and end to pass, which 'tis not improbable but that some diligent observer, if helped with better microscopes, may in time detect. And that this may be so seems with great probability to be argued from the strange phenomena of sensitive plants, wherein nature seems to perform several animal actions with the same schematism or organization that is common to all vegetables, as may appear by some no less instructive than curious observations that were made by divers eminent members of the Royal Society on some of these kind of plants, whereof an account was delivered into them by the most ingenious and excellent physician, Dr. Clarke, which, having that liberty granted me by that most illustrious society, I have hereunto adjoined. Observations on the humble and sensible plants in M. Chiffin's garden in St. James Park, made August the 9th, 1661. Present, the Lord Brunker, Sir Robert Moray, Dr. Wilkins, Mr. Evelyn, Dr. Henshaw, and Dr. Clark. There are 4 plants, 2 of which are little shrub plants, with a little short stalk, about an inch above the ground, from whence are spread several sticky branches, round, straight, and smooth in the distances between the sprouts. But just under the sprouts there are 2 sharp, thorny prickles, broad in the letting on, as in the bramble, one just under the sprout, the other on the opposite side of the branch. The distances betwixt the sprouts are usually something more than an inch, and many upon a branch, according to its length, and they grow so, that if the lower sprout be on the left side of the branch, the next above is on the right, and so to the end, not sprouting by pairs. At the end of each sprout are generally 4 sprigs, 2 at the extremity, and 1 on each side, just under it. At the first sprouting of these from the branch to the sprig where the leaves grow, they are full of little short white hairs, which wear off as the leaves grow, and then they are smooth as the branch. Upon each of these sprigs are, for the most part, 11 pair of leaves, neatly set into the uppermost part of the little sprig, exactly one against another, as it were in little articulations, such as anatomists call anarthrosis, where the round head of a bone is received into another fitted for its motion, and standing very fitly to shut themselves and touch, the pairs just above them closing somewhat upon them, as in the shut sprig. So is the little round pedunculus of this leaf fitted into a little cavity of the sprig, visible to the eye in a sprig new plucked, or in a sprig withered on the branch, from which the leaves easily fall by touching. The leaf being almost an oblong square, and set into the pedunculus at one of the lower corners, receiveth from that not only a spine, as I may call it, which, passing through the leaf, divides it so lengthways that the outer side is broader than the inner next to the sprig, but little fibers passing obliquely towards the opposite broader side seem to make it here a little muscular, and fitted to move the whole leaf, which, together with the whole sprig, are set full with little short whitish hairs. One of these plants, whose branch seemed to be older and more grown than the other, only the tender sprouts of it, after the leaves are shut, fall and hang down. Of the other, the whole branches fall to the ground, if the sun shine very warm, upon the first taking off the glass, which I therefore call the humble plant. The other 2, which do never fall, nor do any of their branches flag and hang down, shut not their leaves, but upon somewhat a hard stroke. The stalks seem to grow up from a root, and appear more herbaceous. They are round and smooth, without any prickle. The sprouts from them have several pairs of sprigs, with much less leaves than the other on them, and have on each sprig generally 17 pair. Upon touching any of the sprigs with leaves on, all the leaves on that sprig contracting themselves by pairs, joined their upper superficies close together. Upon the dropping a drop of aqua fortis on the sprig betwixt the leaves, FF, all the leaves above shut presently, those below by pairs successively after, and by the lower leaves of the other branches, LL, KK, etc., and so every pair successively with some little distance of time betwixt, to the top of each sprig, and so they continued shut all the time we were there. But I, returning the next day, and several days since, found all the leaves dilated again on 2 of the sprigs, but from FF where the aqua fortis had dropped upwards, dead and withered. But those below on the same sprig, green and closing upon the touch, and are so to this day, August 14. With a pair of scissors, as suddenly as it could be done, one of the leaves BB was clipped off in the middle, upon which that pair and the pair above closed presently, after a little interval, DD, then EE, and so the rest of the pairs to the bottom of the sprig, and then the motion began in the lower pairs, LL, on the other sprigs, and so shut them by pairs upwards, though not with such distinct distances. Under a pretty large branch with its sprigs on, there lying a large shell betwixt 2 and 3 inches below it, there was rubbed on a strong scented oil. After a little time all the leaves on that sprig were shut, and so they continued all the time of our stay there. But at my return the next day, I found the position of the shell altered, and the leaves expanded as before, and closing upon the touch. Upon the application of the sunbeams by a burning glass, the more humble plant fell, the others shut their leaves. We could not so apply the smoke of sulphur as to have any visible effect from that at 2 or 3 times trial, but on another trial, the smoke touching the leaves, it succeeded. The humble plant fell upon taking off the glass wherewith it was covered. Cutting off one of the little sprouts, 2 or 3 drops of liquor were thrust out of the part from whence that was cut, very clear and pellucid, of a bright greenish color, tasting at first a little bitterish, but after leaving a licorice-like taste in my mouth. Since, going 2 or 3 times when it was cold, I took the glasses from the more humble plant, and it did not fall as formerly, but shut its leaves only. But coming afterwards, when the sun shone very warm, as soon as it was taken off, it fell as before. Since I plucked off another sprig, whose leaves were all shut, and had been so some time, thinking to observe the liquor should come from that I had broken off, but finding none, though with pressing to come, I, as dexterously as I could, pulled off one whose leaves were expanded, and then had upon the shutting of the leaves a little of the mentioned liquor from the end of the sprig I had broken from the plant, and this twice successively, as often almost as I durst rob the plant. But my curiosity carrying me yet further, I cut off one of the harder branches of the stronger plant, and there came of the liquor, both from that I had cut, and that I had cut it from, without pressure, which made me think that the motion of this plant upon touching might be from this, that there being a constant intercourse betwixt every part of this plant and its root, either by a circulation of this liquor, or a constant pressing of the subtler parts of it to every extremity of the plant. Upon every pressure, from whatsoever it proceeds, greater than that which keeps it up, the subtle parts of this liquor are thrust downwards towards its articulations of the leaves, where, not having room presently to get into the sprig, the little round pedunculus, from whence the spine and those oblique fibres I mentioned rise, being dilated, the spine and fibres, being continued from it, must be contracted and shortened, and so draw the leaf upwards to join with its fellow in the same condition with itself, where, being closed, they are held together by the implications of the little whitish hair, as well as by the still retreating liquor, which, distending the fibres that are continued lower to the branch and root, shorten them above. And when the liquor is so much forced from the sprout, whose fibres are yet tender, and not able to support themselves, but by that tenseness which the liquor, filling their interstices, gives them, the sprout hangs and flags. But, perhaps, he that had the ability and leisure to give you the exact anatomy of this pretty plant, to show you its fibres and visible canals through which this fine liquor circulateth, or is moved, and had the faculty of better and more copiously expressing his observations and conceptions, such a one would easily, from the motion of this liquor, solve all the phenomena, and would not fear to affirm that it is no obscure sensation this plant hath. But I have said too much, I humbly submit, and am ready to stand corrected. I have not yet made so full and satisfactory observations as I desire on this plant, which seems to be a subject that will afford abundance of information. But as far as I have had opportunity to examine it, I have discovered with my microscope very curious structures and contrivances. But designing much more accurate examinations and trials, both with my microscope and otherwise, as soon as the season will permit, I shall not till then add anything of what I have already taken notice of. But as far as I have yet observed, I judge the motion of it to proceed from causes very differing from those by which gut-strings or lute-strings, the beard of a wild oat, or the beard of the seeds of geranium, muscatum, or muskgrass, and other kinds of cranesbill, move themselves. of which I shall add more in the subsequent observations on those bodies. End of section 23. Section 24 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke, Section 24. Observation 19 of a plant growing in the blighted or yellow specks of damask rose leaves, bramble leaves, and some other kind of leaves. I have, for several years together, in the months of June, July, August, and September, when any of the green leaves of roses begin to dry and grow yellow, observed many of them, especially the leaves of the old shrubs of damask roses, all bespecked with yellow stains, and the undersides just against them to have little yellow hillocks of a gummus substance, and several of them to have small black spots in the midst of those yellow ones which, to the naked eye, appeared no bigger than the point of a pin, or the smallest black spot or tittle of ink one is able to make with a very sharp pointed pen. Examining these with a microscope, I was able plainly to distinguish, up and down the surface, several small yellow knobs of a kind of yellowish-red gummy substance, out of which I perceived there sprung multitudes of little cases or black bodies like seed cods, and those of them that were quite without the hillock of gum disclosed themselves to grow out of it with a small straw-colored and transparent stem, the which, seed and stem, appeared very like those of common moss, which I elsewhere describe, but that they were abundantly less, many hundreds of them being not able to equalize one single seed cod of moss. I have often doubted whether they were the seed cods of some little plant, or some kind of small buds, or the eggs of some very small insect. They appeared of a dark brownish red, some almost quite black, and of a figure much resembling the seed cod of moss, but their stalks on which they grew were of a very fine transparent substance, almost like the stalk of mold, but that they seemed somewhat more yellow. That which makes me to suppose them to be vegetables is for that I perceived many of those hillocks bare or destitute, as if those bodies lay yet concealed, as G. In others of them they were just springing out of their gummy hillocks, which all seemed to shoot directly outwards, as at A. In others, as at B, I found them just gotten out, with very little or no stalk, and the cods of an indifferent size. But in others, as C, I found them begin to have little short stalks or stems. In others, as D, those stems were grown bigger and larger, and in others, as at E, F, H, I, K, L, etc., those stems and cods were grown a great deal bigger, and the stalks were more bulky about the root and very much tapered towards the top, as at F and L is most visible. I did not find that any of them had any seed in them, or that any of them were hollow, but as they grew bigger and bigger, I found those heads or cods begin to turn their tops towards their roots, in the same manner as I had observed that of moss to do, so that in all likelihood nature did intend in that posture what she does in the like seed cods of greater bulk, that is, that the seed, when ripe, should be shaken out and dispersed at the end of it, as we find in columbine cods and the like. The whole oval, O, in the second figure of the 12 scheme, represents a small part of a rose leaf about the bigness of the little oval in the hillock C, marked with the figure X, in which I have not particularly observed all the other forms of the surface of the rose leaf, as being little to my present purpose. Now, if these cods have a seed in them so proportioned to the cod as those of pinks and carnations and columbines and the like, how unimaginably small must each of those seeds necessarily be? For the whole length of one of the largest of those cods was not 1/500th part of an inch, some not above 1/1000th, and therefore certainly very many thousand of them would be unable to make a bulk that should be visible to the naked eye. And if each of these contain the rudiments of a young plant of the same kind, what must we say of the pores and constituent parts of that? The generation of this plant seems in part ascribable to a kind of mildew or blight, whereby the parts of the leaves grow scabby or putrefied, as it were, so as that the moisture breaks out in little scabs or spots which, as I said before, look like little knobs of a red gummus substance. From this putrefied scab breaks out this little vegetable, which may be somewhat like a mold or moss, and may have its equivocal generation much after the same manner as I have supposed moss or mold to have, and to be a more simple and uncompounded kind of vegetation, which is set a-moving by the putrefactive and fermentative heat, joined with that of the ambient aerial, when, by the putrefaction and decay of some other parts of the vegetable, that for a while stayed its progress, it is unfettered and left at liberty to move in its former course, but by reason of its regulators moves and acts after quite another manner than it did when a coagent in the more compounded machine of the more perfect vegetable. And from this very same principle, I imagine the mistletoe of oaks, thorns, apple trees, and other trees to have its original. It's seldom or never growing on any of those trees till they begin to wax decrepit and decay with age, and are pestered with many other infirmities. Hither also may be referred those multitudes and varieties of mushrooms, such as that called jusiers, all sorts of grey and green mosses, etc., which infest all kind of trees, shrubs, and the like, especially when they come to any bigness. And this we see to be very much the method of nature throughout its operations. Putrefactive vegetables very often producing a vegetable of a much less compounded nature, and of a much inferior tribe, and putrefactive animal substances degenerating into some kind of animal production of a much inferior rank, and of a more simple nature. Thus we find the humours and substances of the body, upon putrefaction, to produce strange kinds of moving vermin. The putrefaction of the slimes and juices of the stomach and guts produce worms, almost like earthworms. The wheels and children's hands produce a little worm called a wheelworm. The blood and milk and other humours produce other kinds of worms, at least if we may believe what is delivered to us by very famous authors, though, I confess, I have not yet been able to discover such myself. And whereas it may seem strange that vinegar, meal, musty casks, etc., are observed to breed their differing kinds of insects or living creatures, whereas they, being vegetable substances, seem to be of an inferior kind, and so unable to produce a creature more noble or of a more compounded nature than they themselves are of, and so without some concurrent seminal principle may be thought utterly unfit for such an operation. I must add that we cannot presently positively say there are no animal substances, either mediately, as by the soil or fattening of the plant from whence they sprung, or more immediately, by the real mixture or composition of such substances joined with them, or perchance some kind of insect in such places where such kind of putrefying or fermenting bodies are, may, by a certain instinct of nature, eject some sort of seminal principle, which, cooperating with various kinds of putrefying substances, may produce various kinds of insects or animate bodies. For we find in most sorts of those lower degrees of animate bodies that the putrefying substances on which these eggs, seeds, or seminal principles are cast by the insect become, as it were, the matrices or wombs that conduce very much to their generation, and may perchance also to their variation and alteration, much after the same manner, as, by strange and unnatural copulations, several new kinds of animals are produced, as mules and the like, which are usually called monstrous, because a little unusual, though many of them have all their principal parts as perfectly shaped and adapted for their peculiar uses as any of the most perfect animals. If therefore the putrefying body on which any kind of seminal or vital principle chances to be cast becomes somewhat more than merely a nursing and fostering helper in the generation and production of any kind of animate body, the more near it approaches the true nature of a womb, the more power will it have on the byblow it encloses. But of this somewhat more in the description of the water gnat. Perhaps some more accurate inquiries and observations about these matters might bring the question to some certainty, which would be of no small concern in natural philosophy. But that putrefying animal substances may produce animals of an inferior kind, I see not any so very great a difficulty, but that one may, without much absurdity, admit. For as there may be multitudes of contrivances that go to the making up of one complete animate body, so that some of those coadjutors, in the perfect existence and life of it, may be vitiated, and the life of the whole destroyed, and yet several of the constituting contrivances remain entire, I cannot think it beyond imagination or possibility. No more than that a like accidental process, as I have elsewhere hinted, may also be supposed to explicate the method of nature in the metamorphosis of plants. And though the difference between a plant and an animal be very great, yet I have not hitherto met with any so cogent an argument as to make me positive in affirming these two to be altogether heterogeneous and of quite differing kinds of nature. And besides, as there are many zoophytes and sensitive plants, diverse of which I have seen, which are of a middle nature, and seem to be nature's transition from one degree to another, which may be observed in all her other passages, wherein she is very seldom observed to leap from one step to another, so have we, in some authors, instances of plants turning into animals, and animals into plants, and the like, and some other very strange, because unheeded, proceedings of nature, something of which kind may be met with in the description of the water gnat, though it be not altogether so direct to the present purpose. But to refer this discourse of animals to their proper places, I shall add, that though one should suppose, or it should be proved by observations, that several of these kinds of plants are accidentally produced by a casual putrefaction, I see not any great reason to question, but that, notwithstanding its own production was as 'twere casual, yet it may germinate and produce seed, and by it propagate its own, that is, a new species. For we do not know, but that the omnipotent and all-wise Creator might as directly design the structure of such a vegetable, or such an animal to be produced out of such or such a putrefaction or change of this or that body, towards the constitution or structure of which he knew it necessary, or thought it fit to make it an ingredient, as that the digestion or moderate heating of an egg, either by the female, or the sun, or the heat of the fire, or the like, should produce this or that bird, or that putrefactive and warm steam should, out of the blowings, as they call them, that is, the eggs of a fly, produce a living maggot, and that, by degrees, be turned into an aurelia, and that, by a longer and a proportioned heat, be transmuted into a fly. Nor need we, therefore, to suppose it the more imperfect in its kind than the more compounded vegetable or animal of which it is a part, for he might as completely furnish it with all kinds of contrivances necessary for its own existence, and the propagation of its own species, and yet make it a part of a more compounded body, as a clockmaker might make a set of chimes to be a part of a clock, and yet, when the watch part or striking part are taken away, and the hindrances of its motion removed, this chiming part may go as accurately, and strike its tune as exactly, as if it were still a part of the compounded automaton. So, though the original cause or seminal principle from which this minute plant on rose leaves did spring, were, before the corruption caused by the mildew, a component part of the leaf on which it grew, and did serve as a coagent in the production and constitution of it, yet might it be so consummate as to produce a seed which might have a power of propagating the same species. The works of the Creator seeming of such an excellency, that though they are unable to help to the perfecting of the more compounded existence of the greater plant or animal, they may have, notwithstanding, an ability of acting singly upon their own internal principle, so as to produce a vegetable body, though of a less compounded nature, and to proceed so far in the method of other vegetables as to bear flowers and seeds, which may be capable of propagating the like. so that the little cases which appear to grow on the top of the slender stalks may, for aught I know, though I should suppose them to spring from the perverting of the usual course of the parent vegetable, contain a seed which, being scattered on other leaves of the same plant, may produce a plant of much the same kind. Nor are damask rose leaves the only leaves that produce these kinds of vegetable sproutings, for I have observed them also in several other kinds of rose leaves, and on the leaves of several sorts of briars, and on bramble leaves they are oftentimes to be found in very great clusters, so that I have found in one cluster 300, 400, or 500 of them, making a very conspicuous black spot or scab on the back side of the leaf. End of section 24.
Section 25 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by MorganScorpion. Search MorganScorpion on YouTube to find my YouTube channel. Micrographia by Robert Hooke, Section 25. Observation 20 of blue mould and of the first principles of vegetation arising from putrefaction. The blue and white and several kinds of hairy mouldy spots, which are observable upon divers kinds of putrefied bodies, whether animal substances or vegetable, such as the skin, raw or dressed, flesh, blood, humours, milk, green cheese, etc., or rotten sappy wood, or herbs, leaves, barks, roots, etc. of plants, are all of them nothing else but several kinds of small and variously figured mushrooms, which, from convenient materials in those putrefying bodies, are, by the concurrent heat of the air, excited to a certain kind of vegetation, which will not be unworthy of our more serious speculation and examination, as I shall by and by show. But first, I must premise a short description of this specimen, which I have added of this tribe, in the first figure of the 12th scheme, which is nothing else but the appearance of a small white spot of hairy mould, multitudes of which I found to bespeck and whiten over the red covers of a small book, which, it seems, were of sheepskin, that being more apt to gather mould, even in a dry and clean room, than other leathers. These spots appeared, through a good microscope, to be a very pretty shaped vegetative body, which, from almost the same part of the leather, shot out multitudes of small, long, cylindrical and transparent stalks, not exactly straight, but a little bended with the weight of a round and white knob that grew on the top of each of them. Many of these knobs I observed to be very round, and of a smooth surface, such as A, etc., others smooth likewise, but a little oblong, as B, several of them a little broken, or cloven with chops at the top, as C, others flitted as 'twere, or flown all to pieces, as D. The whole substance of these pretty bodies was of a very tender constitution, much like the substance of the softer kind of common white mushrooms, for by touching them with a pin I found them to be bruised and torn. They seemed each of them to have a distinct root of their own, for though they grew near together in a cluster, yet I could perceive each stem to rise out of a distinct part or pore of the leather. Some of these were small and short, as seeming to have been but newly sprung up. Of these the balls were for the most part round. Others were bigger and taller, as being perhaps of a longer growth. And of these, for the most part, the heads were broken, and some much wasted, as E. What these heads contained I could not perceive. Whether they were knobs and flowers, or seed cases, I am not able to say, but they seemed most likely to be of the same nature with those that grow on mushrooms, which they did, some of them, not a little resemble. Both their smell and taste, which are active enough to make a sensible impression upon these organs, are unpleasant and noisome. I could not find that they would so quickly be destroyed by the actual flame of a candle, as at first sight of them I conceived they would be. But they remained entire after I had passed that part of the leather on which they struck 3 or 4 times through the flame of a candle, so that it seems they are not very apt to take fire, no more than the common white mushrooms are when they are sappy. There are a multitude of other shapes, of which these microscopical mushrooms are figured, which would have been a very long work to have described, and would not have suited so well with my design in this treatise. Only, amongst the rest, I must not forget to take notice of one that was a little like to, or resembled, a sponge, consisting of a multitude of little ramifications, almost as that body does, which indeed seems to be a kind of water mushroom, of a very pretty texture, as I elsewhere manifest. And a second, which I must not omit, because often mingled, and near adjoining to these I have described, and this appeared much like a thicket of bushes, or brambles, very much branched, and extended, some of them, to a great length in proportion to their diameter, like creeping brambles. The manner of the growth and formation of this kind of vegetable is the third head of inquiry, which, had I time, I should follow. The figure and method of generation in this concrete seeming to me, next after the inquiry into the formation, figuration, or crystallization of salts, to be the most simple, plain, and easy, and it seems to be a medium through which he must necessarily pass, that would with any likelihood investigate the forma informans of vegetables. For as I think that he shall find it a very difficult task who undertakes to discover the form of saline crystallizations without the consideration and prescience of the nature and reason of a globular form, and as difficult to explicate this configuration of mushrooms without the previous consideration of the form of salts, so will the inquiry into the forms of vegetables be no less, if not much more difficult, without the foreknowledge of the forms of mushrooms, these several inquiries having no less dependence one upon another than any select number of propositions in mathematical elements may be made to have. Nor do I imagine that the skips from the one to another will be found very great, if beginning from fluidity, or body without any form, we descend gradually till we arrive at the highest form of a brute animal's soul, making the steps or foundations of our inquiry, fluidity, orbiculation, fixation, angulization, or crystallization, germination, or ebullition, vegetation, plantanimation, animation, sensation, imagination. Now, that we may the better proceed in our inquiry, it will be requisite to consider, first, that the mould and mushrooms require no seminal property, but that the former may be produced at any time from any kind of putrefying animal, or vegetable substance, as flesh, etc., kept moist and warm, and the latter, if what Matthiolus relates be true, of making them by art, are as much within our command, of which matter take the epitome which Mr. Parkinson has delivered in his Herbal, in his chapter of mushrooms, because I have not Matthiolus now by me. Unto these mushrooms, saith he, may also be adjoined those which are made of art, whereof Matthiolus makes mention, that grow naturally among certain stones in Naples, and that the stones being digged up and carried to Rome, and other places, where they set them in their wine cellars, covering them with a little earth, and sprinkling a little warm water thereon, would within 4 days produce mushrooms fit to be eaten, at what time one will. As also that mushrooms may be made to grow at the foot of a wild poplar tree, within 4 days after. Warm water wherein some leaves have been dissolved shall be poured into the root, which must be slit, and the stalk above ground. Next, that as mushrooms may be generated without seed, so does it not appear that they have any such thing as seed in any part of them. For having considered several kinds of them, I could never find anything in them that I could with any probability guess to be the seed of it. so that it does not as yet appear, that I know of, that mushrooms may be generated from a seed, but they rather seemed to depend merely upon a convenient constitution of the matter out of which they are made, and a concurrence of either natural or artificial heat. Thirdly, that by several bodies, as salts and metals both in water and in the air, and by several kinds of sublimations in the air, actuated and guided with a congruous heat, there may be produced several kinds of bodies as curiously, if not of a more composed figure, several kinds of rising or ebulliating figures seem to manifest, as witness the shooting in the rectification of spirits of urine, heart-horn, blood, etc. Witness also the curious branches of evaporated dissolutions, some of them against the sides of the containing jar, others standing up or growing an end out of the bottom, of which I have taken notice of a very great variety. But above all the rest is a very pretty kind of germination which is afforded us in the silver tree. The manner of making which with mercury and silver is well known to the chemists, of which there is an ebullition or germination, very much like this of mushrooms, if I have been rightly informed of it. Fourthly, I have very often taken notice of, and also observed with a microscope, certain excrescencies or ebullitions in the snuff of a candle, which, partly from the sticking of the smoky particles as they are carried upwards by the current of the rarefied air and flame, and partly also from a kind of germination or ebullition of some actuated unctuous parts which creep along and filter through some small string of the wick, are formed into pretty round and uniform heads, very much resembling the form of hooded mushrooms, which, being by any means exposed to the fresh air, or that air which encompasses the flame, they are presently licked up and devoured by it, and vanish. The reason of which phenomenon seems to me to be no other than this: that when a convenient thread of the wick is so bent out by the sides of the snuff that are about half an inch or more removed above the bottom or lowest part of the flame, and that this part be wholly included in the flame, the oil, for the reason of filtration, which I have elsewhere rendered, being continually driven up, the snuff is driven likewise into this ragged bended end, and this being removed a good distance, as half an inch or more, above the bottom of the flame, the parts of the air that passes by it are already almost satiated with the dissolution of the boiling unctuous steam that issued out below, and therefore are not only glutted, that is, can dissolve no more than what they are already acting upon, but they carry up with them abundance of unctuous and sooty particles, which meeting with that rag of the wick that is plentifully filled with oil, and only spends it as fast as it evaporates, and not at all by dissolution or burning, by means of these steamy parts of the filtrated oil issuing out at the sides of this rag, and being enclosed with an air that is already satiated and cannot prey upon them nor burn them, the ascending sooty particles are stayed about it and fixed, so as that about the end of the rag or filament of the snuff, whence the greatest part of the steams issue, there is conglobated or fixed a round and pretty uniform cap, much resembling the head of a mushroom, which, if it be of any great bigness, you may observe that its underside will be bigger than that which is above the rag or stem of it. For the oil that is brought into it by filtration, being by the bulk of the cap a little sheltered from the heat of the flame, does by that means issue as much out beneath from the stalk or downwards as it does upwards. And by reason of the great access of the adventitious smoke from beneath, it increases most that way. That this may be the true reason of this phenomenon, I could produce many arguments and experiments to make it probable. First, that the filtration carries the oil to the top of the wick, at least as high as these rags, is visible to one that will observe the snuff of a burning candle with a microscope, where he may see an ebullition or bubbling of the oil as high as the snuff looks black. Next, that it does steam away more than burn. I could tell you of the dim burning of a candle, the longer the snuff be which arises from the abundance of vapours out of the higher parts of it. And thirdly, that in the middle of the flame of the candle, near the top of the snuff, the fire or dissolving principle is nothing near so strong as near the bottom and out edges of the flame, which may be observed by the burning asunder of a thread, that will first break in those parts that the edges of the flame touch, and not in the middle. And I could add several observables that I have taken notice of in the flame of a lamp actuated with bellows, and very many others that confirm me in my opinion, but that it is not so much to my present purpose, which is only to consider this concrete in the snuff of a candle, so far as it has any resemblance of a mushroom, to the consideration of which that I may return, I say we may also observe. In the fifth place, that the droppings or trillings of lapidescent waters in vaults underground seem to constitute a kind of petrified body, formed almost like some kind of mushrooms inverted, insomuch that I have seen some knobbed a little at the lower end, though for the most part, indeed, they are otherwise shaped and tapered towards the end, the generation of which seems to be from no other reason than this: that the water, by soaking through the earth and lime, for I guess that substance to add much to its petrifying quality, does so impregnate itself with stony particles, that, hanging in drops in the roof of the vault, by reason that the soaking of the water is but slow, it becomes exposed to the air, and thereby the outward part of the drop by degrees grows hard, by reason that the water gradually evaporating the stony particles near the outsides of the drop begin to touch, and by degrees to dry and grow closer together, and at length constitute a crust or shell about the drop, and this soaking by degrees, being more and more supplied, the drop grows longer and longer, and the sides harden thicker and thicker into a quill or cane, and at length that hollow or pith becomes almost stopped up and solid. Afterwards the soaking of the petrifying water, finding no longer a passage through the middle, bursts out and trickles down the outside, and as the water evaporates, leaves new superinduced shells, which more and more swell the bulk of those icicles. And because of the great supply from the vault of petrifying water, those bodies grow bigger and bigger next to the vault, and taper or sharpen towards the point. For the access from the arch of the vault being but very slow, and consequently the water being spread very thinly over the surface of the icicle, the water begins to settle before it can reach to the bottom, or corner end of it. Whence, if you break one of these, you would almost imagine it a stick of wood, petrified, it having so pretty a resemblance of pith and grain, and if you look on the outside of a piece, or of one whole, you would think no less, both from its vegetable roundness and tapering form. But whereas all vegetables are observed to shoot and grow perpendicularly upwards, this does shoot or propend directly downwards. By which last observables, we see that there may be a very pretty body shaped and concreted by mechanical principles, without the least show or probability of any other seminal formatrix. And since we find that the great reason of the phenomenon of this pretty petrification are to be reduced from the gravity of a fluid and pretty volatile body impregnated with stony particles, why may not the phenomena of ebullition or germination be in part possibly enough deduced from the levity of an impregnated liquor, which therefore perpendicularly ascending by degrees, evaporates and leaves the more solid and fixed parts behind in the form of a mushroom, which is yet further diversified and specificated by the forms of the parts that impregnated the liquor, and compose or help to constitute the mushroom. That the forementioned figures of growing salts, and the silver tree, are from this principle, I could very easily manifest, but that I have not now a convenient opportunity of following it. Nor have I made a sufficient number of experiments and observations to propound, explicate, and prove so useful a theory as this of mushrooms. For though the contrary principle to that of petrified icicles may be in part a cause, Yet I cannot but think that there is somewhat a more complicated cause, though yet mechanical, and possible to be explained. We therefore have further to inquire of it what makes it to be such a liquor, and to ascend, whether the heat of the sun and air, or whether that fermentation and putrefaction, or both together, as also whether there be not a third or fourth, whether a saline principle be not a considerable agent in this business also as well as heat, whether also a fixation, precipitation, or settling of certain parts out of the aerial menstruum may not be also a considerable coadjutor in the business. Since we find that many pretty beards, styriae of the particles of silver, may be precipitated upon a piece of brass put into a solution of silver very much diluted with fair water, which look not unlike a kind of mould or hoar upon that piece of metal, and the hoar frost looks like a kind of mould, and whether there may not be several others that do concur to the production of a mushroom, having not yet had sufficient time to prosecute according to my desires, I must refer this to a better opportunity of my own, or leave and recommend it to the more diligent inquiry and examination of such as can be masters both of leisure and conveniences for such an inquiry. And in the meantime I must conclude that as far as I have been able to look into the nature of this primary kind of life and vegetation, I cannot find the least probable argument to persuade me there is any other concurrent cause than such as is purely mechanical, and that the effects or productions are as necessary upon the concurrence of those causes as that a ship, when the sails are hoisted up and the rudder is set to such a position, should, when the wind blows, be moved in such a way or course to that or t'other place, or as that the bruised watch, which I mention in the description of moss, should, when those parts which hindered its motion were fallen away, begin to move, but after quite another manner than it did before. End of section 25. Section 26 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by MorganScorpion. Look me up on YouTube if you like ghost and horror stories. Micrographia by Robert Hooke. Section 26. Observation 21 of moss and several other small vegetative substances. Moss is a plant that the wisest of kings thought neither unworthy his speculation nor his pen, and though amongst plants it be in bulk one of the smallest, yet it is not the least considerable. For as to its shape, it may compare for the beauty of it with any plant that grows, and bears a much bigger breadth. It has a root almost like a seedy parsnip, furnished with small strings and suckers, which are all of them finely branched, like those of the roots of much bigger vegetables. Out of this springs the stem or body of the plant, which is somewhat quadrangular, rather than cylindrical, most curiously fluted, or lining with small creases, which run, for the most part, parallel the whole stem. On the sides of this are close and thick set a multitude of fair, large, well-shaped leaves, some of them of a rounder, others of a longer shape, according as they are younger or older when plucked, as I guess by this, that those plants that had the stalks growing from the top of them had their leaves of a much longer shape, all the surface of each side of which is curiously covered with a multitude of little oblong transparent bodies, in the manner as you see it expressed in the leaf B, in the 13th scheme. This plant, when young and springing up, does much resemble a house-leek, having thick leaves, almost like that, and seems to be somewhat akin to it in other particulars. Also from the top of the leaves there shoots out a small white and transparent hair or thorn. This stem, in time, come to shoot out into a long, round, and even stalk, which by cutting transversely, when dry, I manifestly found to be a stiff, hard, and hollow cane or reed, without any kind of knot or stop from its bottom, where the leaves encompassed it, to the top, on which there grows a large seed case, A, covered with a thin and more whitish skin, B, terminated in a long thorny top, which at first covers all the case, and by degrees, as that swells, the skin cleaves, and at length falls off, with its thorny top and all, which is a part of it, and leaves the seed case to ripen, and by degrees to shatter out its seed at a place underneath this cap, B, which before the seed is ripe appears like a flat bowed button, without any hole in the middle, but as it ripens the button grows bigger, and a hole appears in the middle of it, E, out of which in all probability the seed falls. For as it ripens by a provision of nature, that end of this case turns downwards after the same manner as the ears of wheat and barley usually do. And opening several of these dry red cases, F, I found them to be quite hollow, without anything at all in them. Whereas when I cut them asunder with a sharp penknife when green, I found in the middle of this great case another smaller round case, between which two the interstices were filled with multitudes of stringy fibres, which seemed to suspend the lesser case in the middle of the other, which, as far as I was able to discern, seemed full of exceeding small white seeds, much like the seed bag in the knop of a carnation, after the flowers have been 2 or 3 days, or a week, fallen off. But this I could not so perfectly discern, and therefore cannot positively affirm it. After the seed was fallen away, I found both the case, stalk, and plant all grow red and wither, and from other parts of the root continually to spring new branches or slips, which by degrees increased, and grew as big as the former, seeded, ripened, shattered, and withered. I could not find that it observed any particular seasons for these several kinds of growth, but rather found it to be springing, mature, ripe, seedy, and withered at all times of the year, but I found it most to flourish and increase in warm and moist weather. It gathers its nourishments, for the most part, out of some lapidescent or other substance corrupted or changed from its former texture or substantial form, for I have found it to grow on the rotten parts of stone, of bricks, of wood, of bones, of leather, etc. It oft grows on the barks of several trees, spreading itself, sometimes from the ground upwards, and sometimes from some chink or cleft of the bark of the tree, which has some putrefied substance in it. But this seems of a distinct kind from that which I observed to grow on putrefied inanimate bodies and rotten earth. There are also great varieties of other kinds of mosses which grow on trees, and several other plants, of which I shall here make no mention, nor of the moss growing on the skull of a dead man, which much resembles that of trees. Whether this plant does sometimes originally spring or rise out of corruption without any disseminated seed, I have not yet made trials enough to be very much either positive or negative. For as it seems very hard to conceive how the seed should be generally dispersed into all parts where there is a corruption begun, unless we may rationally suppose that this seed being so exceeding small, and consequently exceeding light, is thereby taken up and carried to and fro in the air into every place, and by the falling drops of rain is washed down out of it, and so dispersed into all places, and there only takes root and propagates, where it finds a convenient soil or matrix for it to thrive on. So if we will have it to proceed from corruption, it is not less difficult to conceive, first, how the corruption of any vegetable, much less of any stone or brick, should be the parent of so curiously figured and so perfect a plant as this is. But here indeed I cannot but add that it seems rather to be a product of the rain in those bodies where it is stayed, than of the very bodies themselves, since I have found it growing on marble and flint. but always the microscope, if not the naked eye, would discover some little hole of dirt in which it was rooted. Next, how the corruption of each of those exceedingly differing bodies should all conspire to the production of the same plant, that is, that stones, bricks, wood, or vegetable substances, and bones, leather, horns, or animate substances, unless we may with some plausibleness say that air and water are the coadjutors, or menstruums, all kinds of putrefactions, and that thereby the bodies, though whilst they retained their substantial forms, were of exceeding differing natures, yet, since they are dissolved and mixed into another, that they may be very homogeneous, they being almost resolved again into air, water, and earth, retaining perhaps one part of their vegetative faculty yet entire, which meeting with congruous assistance, such as the heat of the air and the fluidity of the water, and such like coadjutors and conveniences, acquires a certain vegetation for a time, wholly differing perhaps from that kind of vegetation it had before. To explain my meaning a little better by a gross similitude. Suppose a curious piece of clockwork that had had several motions and contrivances in it, which, when in order, would all have moved in their designed methods and periods. We will further suppose, by some means, that this clock comes to be broken, bruised, or otherwise disordered, so that several parts of it being dislocated, are impeded, and so stand still, and not only hinder its own progressive motion, and produce not the effect which they were designed for, but because the other parts also have a dependence upon them, put a stop to their motion likewise, and so the whole instrument becomes unserviceable, and not fit for any use. This instrument afterwards, by some shaking and tumbling, and throwing up and down, comes to have several of its parts shaken out, and several of its curious motions, and contrivances, and particles all fallen asunder. Here a pin falls out, and there a pillar, and here a wheel, and there a hammer and a spring, and the like, and among the rest, away falls those parts also which were bruised and disordered, and had all this while impeded the motion of the rest. Hereupon several of those other motions that yet remain, whole springs were not quite run down, being now at liberty, begin each of them to move, thus or thus, but quite after another method than before, there being many regulating parts, and the like, fallen away and lost. Upon this, the owner, who chances to hear and observe some of these effects, being ignorant of the watchmaker's art, wonders what is betide his clock, and presently imagines that some artist has been at work, and has set his clock in order, and made a new kind of instrument of it. But upon examining circumstances, he finds there was no such matter, but that the casual slipping out of a pin had made several parts of his clock fall to pieces, and that thereby the obstacle that all this while hindered his clock, together with other useful parts, were fallen out, and so his clock was set at liberty. And upon winding up those springs again when run down, he finds his clock to go, but quite after another manner than it was wont heretofore. And thus it may be, perhaps, in the business of moss and mould and mushrooms, and several other spontaneous kinds of vegetations, which may be caused by a vegetative principle, which was a coadjutor to the life and growth of the greater vegetable, and was by the destroying of the life of it stopped and impeded in performing its office, but afterwards, upon a further corruption of several parts that had all the while impeded it, the heat of the sun winding it up, as it were, the spring, sends it again into a vegetative motion, and this being single and not at all regulated as it was before, when a part of that greater machine, the pristine vegetable, is moved after quite a differing manner, and produces effects very differing from those it did before. But this I propound only as a conjecture, not that I am more inclined to this hypothesis than the seminal, which upon good reason I guess to be mechanical also, as I may elsewhere more fully show, but because I may, by this, hint a possible way how this appearance may be solved, supposing we should be driven to confess from certain experiments and observations made, that such or such vegetables were produced out of the corruption of another, without any concurrent seminal principle, as I have given some reason to suppose in the description of a microscopical mushroom, without derogating at all from the infinite wisdom of the Creator. For this accidental production, as I may call it, does manifest as much, if not very much more, of the excellency of his contrivance as anything in the more perfect vegetative bodies of the world, even as the accidental motion of the automaton does make the owner see that there was much more contrivance in it than at first he imagined. But of this I have added more in the description of mould, and the vegetables on rose leaves, etc., those being much more likely to have their original from such a cause than this which I have here described, in the 13th scheme, which indeed I cannot conceive otherwise of than as of a most perfect vegetable, wanting nothing of the perfections of the most conspicuous and vastest vegetables of the world, and to be of a rank so high as that it may very properly be reckoned with the tall cedar of Lebanon, as that kingly botanist has done. We know there may be as much curiosity of contrivance and excellency of form in a very small pocket clock, that takes not up an inch square of room, as there may be in a church clock that fills a whole room. And I know not whether all the contrivances and mechanisms requisite to a perfect vegetable may not be crowded into an exceedingly less room than this of moss, as I have heard of a striking watch so small that it served for a pendant in a lady's ear. And I have already given you the description of a plant growing on rose leaves that is abundantly smaller than moss, insomuch that near 1,000 of them would hardly make the bigness of one single plant of moss. And by comparing the bulk of moss with the bulk of the biggest kind of vegetable we meet with in story, of which kind we find in some hotter climates, as Guinea and Brazil, the stalk or body of some trees to be 20 foot in diameter, whereas the body or stem of moss, for the most part, is not above 1/60th part of an inch, we shall find that the bulk of the one will exceed the bulk of the other no less than 2,985,984 millions, or 2985984,000,000. And supposing the production on a rose leaf to be a plant, we shall have of those Indian plants to exceed a production of the same vegetable kingdom no less than 1,000 times the former number. So prodigiously various are the works of the Creator, and so all sufficient is he to perform what to man would seem impossible, they being both alike easy to him, even as 1 day and 1,000 years are to him as one and the same time. I have taken notice of such an infinite variety of those smaller kinds of vegetations, that should I have described every one of them, they would almost have filled a volume, and proved big enough to have made a new herbal. Such multitudes are they to be found in moist hot weather, especially in the summer time, on all kind of putrefying substances, which, whether they do more properly belong to the classes of mushrooms or moulds or mosses, I shall not now dispute, there being some that seem more properly of one kind, others of another, their colours and magnitudes being as much differing as their figures and substances. Nay, I have observed that putting fair water, whether rain water or pump water or May dew or snow water, it was almost all one, I have often observed, I say, that this water would, with a little standing, tarnish and cover all about the sides of the glass that lay under water with a lovely green. But though I have often endeavoured to discover with my microscope whether this green were like moss, or long-striped seaweed, or any other peculiar form, yet so ill and imperfect are our microscopes that I could not certainly discriminate any. Growing trees also, and any kinds of woods, stones, bones, etc., that have been long exposed to the air and rain, will be all over covered with a greenish scurf, which will very much foul and green any kind of clothes that are rubbed against it. Viewing this, I could not certainly perceive in many parts of it any determinate form, though in many I could perceive a bed, as 'twere, of young moss. But in other parts it looked almost like green bushes, and very confused, but always of whatever irregular figures the parts appeared of, they were always green, and seemed to be either some vegetable, or to have some vegetating principle. End of section 26. Section 27 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by MorganScorpion. Look for me on YouTube if you like ghost and horror stories. Micrographia by Robert Hooke. Section 27. Observation 22. Of common sponges and several other spongy fibrous bodies. A sponge is commonly reckoned among the zoophytes, or plant animals, and the texture of it, which the microscope discovers, seems to confirm it, for it is of a form whereof I never observed any other vegetable. And indeed it seems impossible that any should be of it, for it consists of an infinite number of small short fibres, or nervous parts, much of the same bigness, curiously jointed or contexted together in the form of a net, as is more plainly manifest by the little draught which I have added in the third figure of the 9th scheme, of a piece of it, which you may perceive represents a confused heap of the fibrous parts curiously jointed and implicated. The joints are, for the most part, where 3 fibres only meet, for I have very seldom met with any that had 4. At these joints there is no one of the 3 that seems to be the stock whereon the other grow, but each of the fibres are, for the most part, of an equal bigness, and seem each of them to have an equal share in the joint. The fibres are all of them much about the same bigness, not smaller towards the top of the sponge, and bigger nearer the bottom or root, as is usual in plants. The length of each between the joints is very irregular and different, the distance between some 2 joints being 10 or 12 times more than between some others. Nor are the joints regular and of an equitriagonal figure, but for the most part the 3 fibres so meet that they compose 3 angles very differing all of them from one another. The meshes likewise and holes of this reticulated body are not less various and irregular, some bilateral, others trilateral and quadrilateral figures. Nay, I have observed some meshes to have 5, 6, 7, 8, or 9 sides, and some to have only 1, so exceeding various is the lusus naturae in this body. As to the outward appearance of this vegetative body, they are so usual everywhere that I need not describe them, consisting of a soft and porous substance representing a lock, sometimes a fleece of wool, but it has besides these small microscopical pores which lie between the fibres, a multitude of round pores or holes, which, from the top of it, pierce into the body, and sometimes go quite through to the bottom. I have observed many of these sponges to have included likewise in the midst of their fibrous contextures pretty large friable stones, which must either have been enclosed whilst this vegetable was in formation, or generated in those places after it was perfectly shaped. The latter of which seems the more improbable, because I did not find that any of these stony substances were perforated with the fibres of the sponge. I have never seen nor been informed of the true manner of the growing of sponges on the rock, whether they are found to increase from little to great, like vegetables, that is, part after part, or like animals, all parts equally growing together, or whether they be matrices or feed-bags of any kind of fishes or some kind of watery insect, or whether they are at any times more soft and tender, or of another nature and texture, which things, if I knew how, I should much desire to be informed of. But from a cursory view that I at first made with my microscope, and some other trials, I supposed it to be some animal substance cast out, and fastened upon the rocks in the form of a froth, or congeries of bubbles, like that which I have often observed on rosemary and other plants, wherein is included a little insect, that all the little films which divide these bubbles one from another did presently, almost after the substance began to grow a little harder, break, and leave only the thread behind, which might be, as 'twere, the angle or thread between the bubbles, that the great holes or pores observable in these sponges were made by the eruption of the included heterogeneous substance, whether air or some other body, for many other fluid bodies will do the same thing, which breaking out of the lesser were collected into very large bubbles, and so might make their way out of the sponge, and in their passage might leave a round cavity, and if it were large, might carry up with it the adjacent bubbles, which may be perceived at the outside of the sponge, if it be first thoroughly wetted and suffered to plump itself into its natural form, or be then wrung dry and suffered to expand itself again, which it will freely do whilst moist. For when it has thus plumped itself into its natural shape and dimensions, 'tis obvious enough that the mouths of the larger holes have a kind of lip or rising round about them, but the other smaller pores have little or none. It may further be found that each of these great pores has many other small pores below that are united unto it and help to constitute it, almost like so many rivulets or small streams that contribute to the maintenance of a large river. Nor from this hypothesis would it have been difficult to explicate how those little branches of coral, small stones, shells, and the like, come to be included by these frothy bodies. But this, indeed, was but a conjecture, and upon a more accurate inquiry into the form of it with the microscope, it seems not to be the true origin of them. For whereas sponges have only 3 arms which join together at each knot, if they had been generated from bubbles, they must have had 4. But that they are animal substances, the chemical examination of them seems to manifest, they affording a volatile salt and spirit, like hartshorn, as does also their great strength and toughness, and their smell when burned in the fire or a candle, which has a kind of fleshy scent, not much unlike to hair. And having since examined several authors concerning them, among others, I find this account given by Bellonius in the 11th chapter of his 2nd book. De aquatilibus. Spongiae recentes, says he, asticis longe diversae, scopulis aquae marinae ad 2 vel 3 cubitos. Nonunquam quator tantum digitos immersis, ut fungi arboribus adherunt. Sordido quodam succo aut mucosa potius saniae refertae, usque adeo fetida. Ut vel eminus nauseam excitet, continetur autem iis cavernis, quas inanis insiccis et lotis spongiis cernimus. Putris pulmonis modo nigrae conspiciuntur, verum quae in sublimi aquae nascuntur multo magis opaca nigradine sufficae sunt. Vivere quidem spongius adherendo Aristoteles censet, absolute vero minime, sensumque aliquem habere, vel eo argumento, inquit, credantur, quod difficilime abstrahantur, nisae clanculum agatur, atque, ad avulsoris accessum ita contrahantur, ut eas evalere difficile sit, quod idem etiam faciunt quoties flatus tempestatesque urgant. Puto autem illis succum sordidum quem supra diximus canis loco a natura attributum fuisse. Atque meatibus. Latioribus tanquam intestinis aut interaneis uti. Coiturum, pars quae spongiae, cautibus adhaerent est tanquam folii petiolus, aquo veluti colum quodam gracile incipit. Quod deinde in latitudinem diffusum capitis globum facit. Recentibus nihil est fistulosum. Haesit tantque, tanquam radicibus. Superne omnes propemodum meatus concreti latent. Inferne vero quaterne aut quaenae patent, per quos eas sugere existimamus. From which description, they seem to be a kind of plant animal that adheres to a rock, and these small fibres or threads which we have described seem to have been the vessels which, 'tis very probable, were very much bigger, whilst the interstitia were filled, as he affirms, with a mucous, pulpy or fleshy substance, but upon the drying were shrunk into the bigness they now appear. The texture of it is such that I have not yet met with any other body in the world that has the like, but only one of a larger sort of sponge, which is preserved in the Museum Harveyanum, belonging to the most illustrious and most learned Society of the Physicians of London, which is of a horny, or rather of a petrified substance, and of this indeed the texture and make is exactly the same with common sponges, but only that both the holes and the fibres, or texture of it, is exceedingly much bigger, for some of the holes were above 1.5 inches over, and the fibres and texture of it was big enough to be distinguished easily with one's eye, but conspicuously with an ordinary single microscope. And these indeed seemed to have been the habitation of some animal, and examining Aristotle, I find a very consonant account hereunto, namely that he had known a certain little animal, called Pinothera, like a spider, to be bred in those caverns of a sponge, from within which, by opening and closing those holes, he ensnares and catches the little fishes, and in another place he says, that 'tis very confidently reported, that there are certain moths or worms that reside in the cavities of a sponge, and are there nourished. Notwithstanding all which histories, I think it well worth the inquiring into the history and nature of a sponge, it seeming to promise some information of the vessels in animal substances, which by reason of the solidarity of the inserted flesh that is not easily removed, without destroying also those interspersed vessels, are hitherto undiscovered, whereas here in a sponge the parenchyma, it seems, is but a kind of mucous jelly, which is very easily and clearly washed away. The reason that makes me imagine that there may probably be some such texture in animal substances is, that examining the texture of the filaments of tan leather, I find it to be much of the same nature and strength of a sponge, and with my microscope I have observed many such joints and knobs, as I have described in sponges. The fibres also in the hollow of several sorts of bones. After the marrow has been removed, I have found somewhat to resemble this texture, though I confess I never yet found any texture exactly the same, nor any for curiosity comparable to it. The filaments of it are much smaller than those of silk, and through the microscope appear very near as transparent, nay, some parts of them I have observed much more. Having examined also several kinds of mushrooms, I find their texture to be somewhat of this kind, that is, to consist of an infinite company of small filaments, every way contexed and woven together, so as to make a kind of cloth, and more particularly, examining a piece of touchwood, which is a kind of Jew's ear, or mushroom, growing here in England also, on several sorts of trees, such as elders, maples, willows, etc., and is commonly called by the name of spunk, but that we meet with to be sold in shops is brought from beyond seas. I found it to be made of an exceeding delicate texture, for the substance of it feels, and looks to the naked eye, and may be stretched any way, exactly like a very fine piece of chamois leather, or washed leather, but it is of a somewhat browner hue, and nothing near so strong. But examining it with my microscope, I found it of somewhat another make than any kind of leather. For whereas both chamois and all other kinds of leather I have yet viewed consist of an infinite company of filaments, somewhat like bushes interwoven one with another, that is, of bigger parts or stems, as it were, and smaller branchings that grow out of them, or like a heap of ropes' ends, where each of the larger ropes by degrees seem to split or untwist into many smaller cords, and each of those cords into smaller lines, and those lines into threads, etc., and these strangely entangled or interwoven one within another. The texture of this touchwood seems more like that of a lock or a fleece of wool, for it consists of an infinite number of small filaments, all of them, as far as I could perceive, of the same bigness like those of a sponge, but that the filaments of this were not a 20th part of the bigness of those of a sponge, and I could not so plainly perceive their joints, or their manner of interweaving, though, as far as I was able to discern with that microscope I had, I suppose it to have some kind of resemblance, but the joints are nothing near so thick, nor without much trouble visible. The filaments I could plainly enough perceive to be even, round, cylindrical, transparent bodies, and to cross each other every way. That is, there were not more seemed to lie horizontally than perpendicularly and thwartway, so that it is somewhat difficult to conceive how they should grow in that manner. By tearing off a small piece of it, and looking on the ragged edge, I could among several of those fibres perceive small joints, that is, one of those hairs split into two, each of the same bigness with the other out of which they seemed to grow. But having not lately had an opportunity of examining their manner of growth, I cannot positively affirm anything of them. But to proceed. The swelling of sponges upon wetting, and the rising of the water in it above the surface of the water that it touches, are both from the same cause, of which an account is already given in the 6th observation. The substance of them, indeed, has so many excellent properties, scarce to be met with in any other body in the world, that I have often wondered that so little use is made of it, and those only vile and sordid. Certainly, if it were well considered, it would afford much greater conveniences. That use which the divers are said to make of it seems, if true, very strange. But having made trial of it myself, by dipping a small piece of it in very good salad oil, and putting it in my mouth, and then keeping my mouth and nose under water, I could not find any such thing, for I was as soon out of breath as if I had had no sponge, nor could I fetch my breath without taking in water at my mouth. But I am very apt to think, that were there a contrivance whereby the expired air might be forced to pass through a wet or oily sponge before it were again inspired, it might much cleanse, and strain away from the air divers fuliginous and other noisome steams, and the dipping of it in certain liquors might, perhaps, so renew that property in the air which it loses in the lungs by being breathed, that 1 square foot of air might last a man for respiration much longer, perhaps, than 10 will now serve him of common air. End of section 27.
Section 28 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Section 28. Observation 23 of the curious texture of seaweeds. For curiosity and beauty I have not, among all the plants or vegetables I have yet observed, seen any one comparable to this seaweed I have here described. of which I am able to say very little more than what is represented by the second figure of the 9th scheme, namely, that it is a plant which grows upon the rocks under the water, and increases and spreads itself into a great tuft, which is not only handsomely branched into several leaves, but the whole surface of the plant is covered over with a most curious kind of carved work, which consists of a texture much resembling a honeycomb, for the whole surface on both sides is covered over with a multitude of very small holes, being no bigger than so many holes made with the point of a small pin, and ranged in the neatest and most delicate order imaginable, they being placed in the manner of a quincunx, or very much like the rows of the eyes of a fly, the rows or orders being very regular, which way soever they are observed. What the texture was, as it appeared through a pretty big magnifying microscope, I have here adjoined in the first figure of the 14th scheme, which round area ABCD represents a part of the surface about 1/8 part of an inch in diameter. Those little holes, which to the eye looked round like so many little spots, here appeared very regularly shaped holes, representing almost the shape of the sole of a round-toed shoe, the hinder part of which is, as it were, trod on or covered by the toe of that next below it. These holes seemed walled about with a very thin and transparent substance, looking of a pale straw color, from the edge of which, against the middle of each hole, were sprouted out 4 small transparent straw-colored thorns, which seemed to protect and cover those cavities from either side. 2, near the root of this plant, were sprouted out from several small branches of a kind of bastard coralline, curiously branched, though small. And to confirm this, having lately the opportunity of viewing the large plant, if I may so call it, of a sponge petrified, of which I made mention in the last observation, I found that each of the branches or figures of it did, by the range of its pores, exhibit just such a texture, the rows of pores crossing one another much after the manner as the rows of eyes do, which are described in the 26th scheme. Coralline also, and several sorts of white coral, I have with a microscope observed very curiously shaped. And I doubt not but that he that shall observe these several kinds of plants that grow upon rocks, which the sea sometimes overflows, and those heaps of others which are vomited out of it upon the shore, may find multitudes of little plants and other bodies, which like this will afford very beautiful objects for the microscope, and this specimen here is adjoined only to excite their curiosities who have the opportunity of observing, to examine and collect what they find worthy their notice. For the sea, among terrestrial bodies, is also a prolific mother, and affords as many instances of spontaneous generations as either the air or earth. End of section 28. Recording by Philip Gould. Section 29 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Section 29, Observation 24, of the surfaces of rosemary and other leaves. This which is delineated within the circle of the second figure of the 14th scheme is a small part of the back or underside of a leaf of rosemary, which I did not therefore make choice of because it had anything peculiar which was not observable with a microscope in several other plants, but because it exhibits at one view. First, a smooth and shining surface, namely AB, which is a part of the upper side of the leaf, that by a kind of hem or doubling of the leaf appears on this side. There are multitudes of leaves, which surfaces are like this smooth, and as it were quilted, which look like a curious quilted bag of green silk, or like a bladder, or some such pliable transparent substance, full stuffed out with a green juice or liquor. The surface of rue or herb grass is polished, and all over indented or pitted like the silkworm's egg, which I shall anon describe. The smooth surfaces of other plants are otherwise quilted. Nature in this, as it were, expresses her needlework or embroidery. Next, a downy or bushy surface, such as is all the underside almost, appearing through the microscope much like a thicket of bushes, and with this kind of down or hair the leaves and stalks of multitudes of vegetables are covered, and there seems to be as great a variety in the shape, bulk, and manner of the growing of these secondary plants, as I may call them, they being as it were a plant growing out of a plant, or somewhat like the hairs of animals, as there is to be found amongst small shrubs that compose bushes. But for the most part they consist of small transparent parts, some of which grow in the shape of small needles or bodkins, as on the thistle, cowhage cod, and nettle; others in the form of cat's claws, as in clyders, the beards of barley, the edges of several sorts of grass and reeds, etc., in other, as coltsfoot, rose campion, apse, poplar, willow, and almost all other downy plants. They grow in the form of bushes very much diversified in each particular plant. That which I have before in the 19th observation noted on rose leaves is of quite differing kind, and seems indeed a real vegetable distinct from the leaf. Thirdly, among these small bushes are observable an infinite company of small round balls, exactly globular, and very much resembling pearls, namely CCCC. Of these there may be multitudes observed in sage and several other plants, which I suppose was the reason why Athanasius Kircher supposed them to be all covered with spiders' eggs or young spiders, which indeed is nothing else but some kind of gummus exudation, which is always much of the same bigness. At first sight of these, I confess, I imagined that they may have been some kind of matrices or nourishing receptacles for some small insect, just as I have found oak apples and multitudes of such other large excrescences on the leaves and other parts of trees and shrubs to be for flies and divers other insects, but observing them to be there all the year, and scarce at all to change their magnitude, that conjecture seemed not so probable. But whatever the use of it, it affords a very pleasant object through the microscope, and may perhaps upon further examination prove very luciferous. End of section 29. Recording by Philip Gould.
Section 30 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by MorganScorpion. Check out my YouTube channel by entering MorganScorpion into the YouTube search box. Micrographia by Robert Hooke. Section 30. Observation 25. Of the stinging points and juice of nettles and some other venomous plants. A nettle is a plant so well known to everyone as to what the appearance of it is to the naked eye that it needs no description, and there are very few that have not felt as well as seen it, and therefore it will be no news to tell that a gentle and slight touch of the skin by a nettle does oftentimes not only create very sensible and acute pain, much like that of a burn or scald, but often also very angry and hard swellings and inflammation of the parts, such as will presently rise and continue swollen divers hours. These observations, I say, are common enough, but how the pain is so suddenly created, and by what means continued, augmented for a time, and afterwards diminished, and at length quite extinguished, has not, that I know, been explained by any. And here we must have recourse to our microscope, and that will, if almost any part of the plant be looked on, show us the whole surface of it very thick and set with turnpikes, or sharp needles, of the shape of those represented in the 15 scheme and first figure by AB, which are visible also to the naked eye, each of which consists of two parts very distinct for shape and differing also in quality from one another. For the part A is shaped very much like a round bodkin, from B tapering till it end in a very sharp point. It is of substance very hard and stiff, exceedingly transparent and clear, and, as I by many trials certainly found, is hollow from top to bottom. This I found by this experiment. I had a very convenient microscope with a single glass which drew about half an inch. This I had fastened into a little frame, almost like a pair of spectacles, which I placed before mine eyes, and so holding the leaf of a nettle at a convenient distance from my eye, I did first, with the thrusting of several of these bristles into my skin, perceive that presently after I had thrust them in, I felt the burning pain begin. Next I observed in divers of them, that upon thrusting my finger against their tops, the bodkin, if I may so call it, did not in the least bend, but I could perceive moving up and down within it a certain liquor, which upon thrusting the bodkin against its basis, or bag B, I could perceive to rise towards the top, and upon taking away my hand, I could see it again subside and shrink into the bag. This I did very often, and saw this phenomenon as plain as I could ever see a parcel of water ascend and descend in a pipe of glass. But the bases underneath these bodkins, on which they were fast, were made of a more pliable substance, and looked almost like a little bag of green leather, or rather resembled the shape and surface of a wild cucumber, or Cucumeris asinini, and I could plainly perceive them to be certain little bags, bladders, or receptacles full of water, or, as I guess, the liquor of the plant, which was poisonous. And those small bodkins were but the syringe pipes, or glister pipes, which first made way into the skin, and then served to convey that poisonous juice, upon the pressing of those little bags, into the interior and sensible parts of the skin, which, being so discharged, does corrode, or, as it were, burn that part of the skin it touches. And this pain will sometimes last very long, according as the impression is made deeper or stronger. The other parts of the leaf or surface of the nettle have very little considerable, but what is common to most of these kinds of plants, as the ruggedness or indenting, and hairiness, and other roughnesses of the surface or outside of the plant, of which I may say more in another place. As I shall likewise of certain little pretty clear balls or apples, which I have observed to stick to the sides of these leaves, both on the upper and under side, very much like the small apples which I have often observed to grow on the leaves of an oak, called oak apples, which are nothing but the matrices of an insect, as I elsewhere show. The chief thing, therefore, is, how this plant comes, by so slight a touch, to create so great a pain, and the reason of this seems to be nothing else but the corrosive penetrant liquor contained in the small bags or bladders, upon which grow out those sharp syringe pipes, as I before noted, and very consonant to this is the reason of the pain created by the sting of a bee, wasp, etc., as I elsewhere show. For by the dart, which is likewise a pipe, is made a deep passage into the skin, and then by the anger of the fly is his gory poisonous liquor injected, which being admitted among the sensible parts, and so mixed with the humours or stagnating juices of that part, does create an ebullition, perhaps, or effervescence, as is usually observed in the mingling of two different chemical saline liquors, by which means the parts become swelled, hard, and very painful. For thereby the nervous and sensible parts are not only stretched and strained beyond their natural tone, but are also pricked, perhaps, or corroded by the pungent and incongruous parts of the intruded liquor. And this seems to be the reason why aqua fortis and other saline liquors, if they come to touch the sensitive parts, as in a cut of the skin or the like, do so violently and intolerably excruciate and torment the patient. And 'tis not unlikely but the inventors of that diabolical practice of poisoning the points of arrows and poignards might receive their first hint from some such instance in natural contrivances, as this of the nettle, for the ground why such poisoned weapons kill so infallibly as they do, seems no other than this of our nettle's stinging, for the poignard or dart makes a passage or entrance into the sensitive or vital parts of the body, whereby the contagious substance comes to be dissolved by, and mixed with, the fluid parts or humours of the body, and by that means spread itself by degrees into the whole liquid part of the body, in the same manner as a few grains of salt put into a great quantity of water will by degrees diffuse itself over the whole. And this I take to be the reason of killing of toads, frogs, efts, and several fishes, by strewing salt on their backs, which experiment was shown to the Royal Society by a very ingenious gentleman, and a worthy member of it. For those creatures having always a continual exudation, as it were, of slimy and watery parts, sweating out of the pores of their skin, the saline particles by that means obtain a vehicle, which conveys them into the internal and vital parts of the body. This seems also to be the reason why bathing in mineral waters are such sovereign remedies for multitudes of distempers, especially chronical, for the liquid and warm vehicles of the mineral particles, which are known to be in very considerable quantities in those healing baths, by the body's long stay in them, do by degrees steep and insinuate themselves into the pores and parts of the skin, and thereby those mineral particles have their ways and passages opened to penetrate into the inner parts, and mingle themselves with the stagnant juices of the several parts. Besides, many of those offensive parts which were united with those stagnant juices, and were contrary to the natural constitution of the parts, and so become irksome and painful to the body, but could not be discharged, because nature had made no provision for such accidental mischiefs, are, by means of this soaking, and filling the pores of the skin with a liquor, afforded a passage through that liquor that fills the pores into the ambient fluid, and thereby the body comes to be discharged. So that 'tis very evident there may be a good as well as an evil application of this principle. And the ingenious invention of that excellent person, Dr. Wren, of injecting liquors into the veins of an animal, seems to be reducible to this head. I cannot stay, nor is this a fit place, to mention the several experiments made of this kind by the incomparable Mr. Boyle, the multitudes made by the lately mentioned physician Dr. Clarke, the history whereof, as he has been pleased to communicate to the Royal Society, so he may perhaps be prevailed with to make public himself. But I shall rather hint that certainly, if this principle were well considered, there might, besides the further improving of bathing and syringing into the veins, be thought on several ways, whereby several obstinate distempers of a humane body, such as the gout, dropsy, stone, etc., might be mastered and expelled, and good men might make as good a use of it, as evil men have made a perverse and diabolical. And that the filling of the pores of the skin with some fluid vehicle is of no small efficacy towards the preparing a passage for several kinds of penetrant juices and other dissoluble bodies to insinuate themselves within the skin and into the sensitive parts of the body, may be, I think, proved by an instance given us by Bellonius in the 26th chapter of the second book of his Observations, which, containing a very remarkable story, I have here transcribed. Cum chameleonis nigre radices, says he, apud pagum quendam livadocorio nuncupatum erui curarimus. Plurimi Graecae et Turcae spectatum venerant quid eruerimus, eas vero frustulatim secabimus, et filio tragiciebimus ut facilius exicari possant. Tocae in eo negotio occupatos nos videntes, similiter eas radices tractare et secare voluerunt. At cum summus esset istus, et omnes sudore maderent, quicumque eam radicum manibus tractaverant sudoremque absterserant, aut faciam digitis scalpsesserant, tantam proriginem iis locis quos attigerant postea senserunt, ut aduri viderentur. Chameleonis enim nigri radix ea virtute pollet, ut cuti applicata ipsam adeo inflamet, ut ned squillae, nec urticae urae centessima parte ita adurent, at prurigo non adeo caleritur sese prodit, post unum aut alterum porro horam, singuli variis faciae locis cutam adeo inflammatum habere copimus ut tota sanguinea videretur. Atque quo magis eam confricabimus, tanto magis excitabatur prurigo. Fonti acidebamus sub platano, atque initio proludico habebamus et ridebamus, aut tandem illi plurimum indignati sunt. Et nisi asseverassimus, nunquam expertus tali virtute eam plantem polere, haud dubie male nos multassent. Atamen nostra excusatio fuit ab illis facilitus accepta, cum eodum incommodo nos affectos conspicerent. Mirum sane quod in tantilo radice, tam ingensem efficiam nostro malo experti sumus. By which observation of his, it seems manifest that their being all covered with sweat who gathered and cut this root of the black chameleon thistle, this was the reason why they suffered that inconvenience. For it seems the like circumstance had not been before that noted, nor do I find any mention of such a property belonging to this vegetable in any of the herbals I have at present by me. I could give very many observations which I have made of this kind, whereby I have found that the best way to get a body to be insinuated into the substance or insensible pores of another is first to find a fluid vehicle that has some congruity, both to the body to be insinuated and to the body into whose pores you would have the other conveyed. And in this principle lies the great mystery of staining several sorts of bodies, as marble, woods, bones, etc., and of dyeing silks, clothes, wools, feathers, etc. But these being digressions, I shall proceed to end of section 30.
Section 31 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Section 31. Observation 26. Of cowage and the itching operation of some bodies. There is a certain down of a plant brought from the East Indies, called commonly, though very improperly, cow itch, the reason of which mistake is manifest enough for the description of it, which Mr. Parkinson sets down in his Herbal, Tribe 11, Chapter 2. Phaseolus siliqua hirsuta, the hairy kidney bean, called in Zarate where it grows, coage. We have had, says he, another of this kind brought us out of the East Indies, which being planted was in show like the former, but came not to perfection, the unkindly season not suffering it to show the flower. But of the cods that were brought, some were smaller, shorter, and rounder than the garden kind, others much longer, and many growing together, as it were, in clusters, and covered all over with a brown short hairiness, so fine that if any of it be rubbed, or fall on the back of one's hand or other tender parts of the skin, it will cause a kind of itching, but not strong, nor long enduring, but passing quickly away without either danger or harm. The beans were smaller than ordinary, and of a black shining color. Having one of these cods given me by a sea captain who had frequented those parts, I found it to be a small cod, about 3 inches long, much like a short cod of French beans, which had 6 beans in it. The whole surface of it was covered over with a very thick and shining brown down, or hair, which was very fine, and for its bigness stiff. Taking some of this down and rubbing it on the back of my hand, I found very little or no trouble, only I was sensible that several of these little downy parts were rubbing did penetrate, and were sunk or stuck pretty deep into my skin. After I had thus rubbed it for a pretty while, I felt very little or no pain, insomuch that I doubted whether it were the true cowage. But whilst I was considering, I found the down began to make my hand itch, and in some places to smart again, much like the stinging of a flea or gnat, and this continued a pretty while, so that by degrees I found my skin to be swelled with little red pustules, and to look as if it had been itchy. But suffering it without rubbing or scratching, the itching, tickling pain quickly grew languid, and within an hour I felt nothing at all, and the little protuberancies were vanished. The cause of which odd phenomenon I suppose to be much the same with that of the stinging of a nettle, for by the microscope I discovered this down to consist of a multitude of small and slender conical bodies, much resembling needles or bodkins, such as are represented by AB, CD, EF, of the first figure of the 16th scheme, that their ends, AAA, were very sharp, and the substance of them stiff and hard, much like the substance of several kinds of thorns and crooks growing on trees. And though they appeared very clear and transparent, yet I could not perceive whether they were hollow or not. But to me they appeared like solid transparent bodies without any cavity in them. Whether, though they may not be, a kind of cane filled with some transparent liquor which was hardened, because the cod which I had was very dry, I was not able to examine. Now, being such stiff, sharp bodies, it is easy to conceive how with rubbing they might easily be thrust into the tenderest parts of the skin, and there by reason of their exceeding fineness and dryness not create any considerable trouble or pain, till by remaining in those places moistened with the humours of the body, some caustic part sticking on them or residing within them might be dissolved and mixed with the ambient juices of that place, and thereby those fibres and tender parts adjoining become affected and as it were corroded by it, whence, while that action lasts, the pains created are pretty sharp and pungent, though small, which is the essential property of an itching one. That the pain also caused by the stinging of a flea, a gnat, a fly, a wasp, and the like, proceeds much from the very same cause, I elsewhere in their proper places endeavour to manifest. The stinging also of shred horsehair, which in merriment is often strowed between the sheets of a bed, seems to proceed from the same cause. End of section 31. Recording by Philip Gould.
Section 32 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by shelleturner. Micrographia by Robert Hooke. Section 32. Observation 27 of the beard of a wild oat, and the use that may be made of it for exhibiting always to the eye the temperature of the air as to dryness and moisture. This beard of a wild oat is a body of a very curious structure, though to the naked eye it appears very slight and inconsiderable, it being only a small black or brown beard or bristle, which grows out of the side of the inner husk that covers the grain of a wild oat. The whole length of it, when put in water so that it may extend itself to its full length, is not above 1.5 inches, and for the most part somewhat shorter, but when the grain is ripe and very dry, which is usually in the months of July and August, this beard is bent somewhat below the middle, namely about 2/5 from the bottom of it, almost to a right angle, and the under part of it is wreathed like a withe. The substance of it is very brittle when dry, and it will very easily be broken from the husk on which it grows. If you take one of these grains and wet the beard in water, you will presently see the small bended top to turn and move round, as if it were sensible, and by degrees, if it be continued wet enough, the joint or knee will straighten itself, and it be suffered to dry again, it will by degrees move round another way, and at length bend again into its former posture. If it be viewed with an ordinary single microscope, it will appear like a small wreathed sprig with 2 clefts, and if wet as before, and then looked on with this microscope, it will appear to unwreathe itself, and by degrees to straighten its knee, and the 2 clefts will become straight, and almost on opposite sides of the small cylindrical body. If it be continued to be looked on a little longer with a microscope, it will within a little while begin to wreathe itself again, and soon after return to its former posture, bending itself again near the middle, into a kind of knee or angle. Several of those bodies I examined with larger microscopes, and there found them much of the make of those 2 long wreathed cylinders delineated in the second figure of the 15 scheme, which 2 cylinders represent the wreathed part broken into 2 pieces, whereof the end AB is supposed to have joined to the end CD, so that EACF does represent the whole wreathed part of the beard, and EG, a small piece of the upper part of the beard which is beyond the knee, which, as I had not room to insert, so was it not very considerable, either for its form or any known property. But the under or wreathed part is notable for both. As to its form, it appeared if it were looked on sideways, almost like a willow or a small tapering rod of hazel, the lower or bigger half of which only is twisted round several times, in some 3, in others more, in others less, according to the bigness and maturity of the grain on which it grew, and according to the dryness and moisture of the ambient air, as I shall show more at large by and by. The whole outward superficies of this cylindrical body is curiously adorned or fluted with little channels and interjacent ridges or little protuberances between them, which run the whole length of the beard, and are straight where the beard is not twisted, and wreathed where it is. Just after the same manner, each of those sides is beset pretty thick with small brides or thorns, somewhat in form resembling that of porcupine quills, such as A in the figure, all whose points are directed like so many turnpikes towards the small end or top of the beard, which is the reason why, if you endeavor to draw the beard between your fingers the contrary way, you will find it to stick and grate, as it were, against the skin. The proportion of these small conical bodies, A, to that whereon they grow, the figure will sufficiently show, as also their manner of growing, their thickness, and nearness to each other, as that towards the root or bottom of the beard they are more thin and much shorter, insomuch that there is usually left between the top of the one and the bottom of that next above it more than the length of one of them, and that towards the top of the beard they grow more thick and close, though there be fewer ridges, so that the root and almost half the upper are hid by the tops of those next below them. I could not perceive any transverse pores unless the whole wreathed part were separated and cleft in those little channels by the wreathing into so many little strings as there were ridges, which was very difficult to determine. But there were in the wreathed part 2 very conspicuous channels or clefts, which were continued from the bottom F to the elbow EH, or all along the part which was wreathed, which seemed to divide the wreathed cylinder into 2 parts, a bigger and a less. The bigger was that which was at the convex side of the knee, namely on the side A, and was wreathed by O. This, as it seemed the broader, so did it also the longer. The other, P, which was usually pursed or wrinkled in the bending of the knee, as about E, seemed both the shorter and the narrower, so that at first I thought the wreathing and unwreathing of the beard might have been caused by the shrinking or swelling of that part, but upon further examination I found that the clefts KK, LL were stuffed up with a kind of spongy substance, which, for the most part, was very conspicuous near the knee, as in the cleft KK, when the beard was dry, upon the discovery of which I began to think that it was upon the swelling of this porous pith, upon the access of moisture or water, that the beard, being made longer in the midst, was straightened, and by the shrinking or subsiding of the parts of that spongy substance together, when the water or moisture was exhaled or dried, the pith or middle parts growing shorter, the whole became twisted. But this I cannot be positive in, for upon cutting the wreathed part in many places transversely, I was not so well satisfied with the shape and the manner of the pores of the pith. For looking on these transverse sections with a very good microscope, I found that the ends of those transverse sections appeared much of the manner of the third figure of the 15 scheme, A, B, C, F, E, and the middle of the pith, CC, seemed very full of pores indeed, but all of them seemed to run the long ways. This figure plainly enough shows in what manner those clefts K and L divided the wreathed cylinder into 2 unequal parts, and also of what kind of substance the whole body consists. For by cutting the same beard in many places, with transverse sections, I found much the same appearance with this expressed, so that those pores seem to run, as in most other such caney bodies, the whole length of it. The clefts of this body, KK and LL, seemed, as is also expressed in the figure, to wind very oddly in the inner part of the wreath, and in some parts of them they seem stuffed, as it were, with that spongy substance which I just now described. This so oddly constituted vegetable substance is first, that I have met with, taken notice of by Battista Porta in his Natural Magic, as a thing known to children and jugglers, and it has been called by some of those last-named persons, the better to cover their cheat, the leg of an Arabian spider, or the leg of an enchanted Egyptian fly, and has been used by them to make a small index, cross, or the like, to move round upon the wetting of it with a drop of water, and muttering certain words. But the use that has been made of it for the discovery of the various constitutions of the air, as to dryness and moistness, is incomparably beyond any other, for this it does to admiration. The manner of contriving it so as to perform this great effect is only thus. Provide a good large box of ivory, about 4 inches over, and of what depth you shall judge convenient, according to your intention of making use of 1, 2, 3, or more of these small beards, ordered in the manner which I shall by and by describe. Let all the sides of this box be turned of basket work, which here in London is easily enough procured, full of holes, in the manner almost of a lettuce. The bigger or more the holes are, the better, that so the air may have the more free passage to the enclosed beard, and may the more easily pass through the instrument. It will be better yet, though not altogether so handsome, if instead of the basket work on the sides of the box, the bottom and the top of the box be joined together only with 3 or 4 small pillars, after the manner represented in the 4 figure of the 15 scheme. Or, if you intend to make use of many of these small beards joined together, you may have a small long case of ivory, whose sides are turned of basket work, full of holes, which may be screwed on to the underside of a broad plate of ivory, on the other side of which is to be made the divided ring or circle, to which divisions the pointing of the hand or index, which is moved by the conjoined beard, may show all the minute variations of the air. There may be multitudes of other ways for contriving this small instrument, so as to produce this effect, which any one may, according to his peculiar use and the exigency of his present occasion, easily enough contrive and take, on which I shall not therefore insist. The whole manner of making any one of them is thus. Having your box or frame, AABB, fitly adapted for the free passage of the air through it, in the midst of the bottom, BBB, you must have a very small hole, C, into which the lower end of the beard is to be fixed, the upper end of which beard, AB, is to pass through a small hole of a plate, or top, AA, if you make use only of a single one, and on the top of it, E, is to be fixed a small and very light, index FG, made of a very thin sliver of a reed or cane. But if you make use of 2 or more beards, they must be fixed and bound together, either with a very fine piece of silk or with a very small touch of hard wax or glue, which is better, and the index FG is to be fixed on the top of the second, third, or fourth in the same manner as on the single one. Now, because that in every of these contrivances the index FG will, with some temperatures of air, move 2, 3, or more times round, which without some other contrivance than this will be difficult to distinguish, therefore I thought of this expedient. The index or hand FG, being raised a pretty way above the surface of the plate AA, fixed in at a little distance from the middle of it a small pin, H, so as almost to touch the surface of the plate AA, and then in any convenient place of the surface of the plate. Fix a small pin, on which put on a small piece of paper or thin pasteboard, vellum, or parchment, made of a convenient size and shaped in the manner of that in the figure expressed by IK, so that having a convenient number of teeth every turn or return of the pin, H, may move this small indented circle, a tooth forward or backwards, by which means the teeth of the circle being marked, it will be thereby very easy to know certainly how much variation any change of weather will make upon the small wreathed body. In the making of this secondary circle of vellum or the like, great care is to be had that it be made exceeding light and to move very easily, for otherwise a small variation will spoil the whole operation. The box may be made of brass, silver, iron, or any other substance, if care be taken to make it open enough to let the air have a sufficiently free access to the beard. The index also may be various ways contrived, so as to show both the number of the revolutions it makes and the minute divisions of each revolution. I have made several trials and instruments for discovering the dryness and moisture of the air with this little wreathed body, and find it to vary exceedingly sensibly with the least change in the constitution of the air as to dryness and moisture, so that with one breathing upon it I have made it untwist a whole bout, and the index or hand has showed or pointed to various divisions on the upper face or ring of the instrument, according as it was carried nearer and nearer to the fire, or as the heat of the sun increased upon it. Other trials I have made with gut strings, to find them nothing near so sensible, though they also may be so contrived as to exhibit the changes of the air as to dryness and moisture, both by their stretching and shrinking in length, and also by their wreathing and unwreathing themselves. But these are nothing near so exact or so tender, for their varying property will in a little time change very much. But there are several other vegetable substances that are much more sensible than even this beard of a wild oat. Such I have found the beard of the seed of muskgrass or Geranium muscatum, and those of other kinds of crane's bill seeds and the like. But always the smaller the wreathing substance be, the more sensible is it of the mutations of the air, a conjecture at the reason of which I shall by and by add. The lower end of this wreathed cylinder, being stuck upright in a little soft racks, so that the bended part or index of it lay horizontal, I have observed it always with moisture to unwreathe itself from the east, for instance, by the south to the west, and so by the north to the east again, moving with the sun, as we commonly say, and with the heat and drouth to retwist, and the wreath itself the contrary way, namely, from the east, for instance, by the north to the west, and so onwards. The cause of all which phenomena seems to be the differing texture of the parts of these bodies, each of them, especially the beard of a wild oat and of musk-grass seed, seeming to have two kind of substances, one that is very porous, loose, and spongy, into which the watery steams of the air may be very easily forced, which will be thereby swelled and extended in its dimensions, just as we may observe all kind of vegetable substance upon steeping in water to swell and grow bigger and longer. And a second that is more hard and close, into which the water can very little or not at all penetrate, this therefore retaining always very near the same dimensions, and the other stretching and shrinking, according as there is more or less moisture or water in its pores, by reason of the make and shape of the parts. The whole body must necessarily unwreath and wreath itself. And upon this principle, it is very easy to make several sorts of contrivances that should thus wreath and unwreath themselves, either by heat and cold, or by dryness and moisture, or by any greater or less force, from whatever cause it proceed, whether from gravity or weight, or from wind, which is motion of the air, or from some springing body, or the like. This, had I time, I should enlarge much more upon, for it seems to me to be the very first footstep of sensation and animate motion, the most plain, simple, and obvious contrivance that nature has made use of to produce a motion, next to that of rarefaction and condensation by heat and cold. And were this principle very well examined, I am very apt to think it would afford us a very great help to find out the mechanism of the muscles, which indeed, as far as I have hitherto been able to examine, seems to me not so very perplex as one might imagine, especially upon the examination which I made of the muscles of crabs, lobsters, and several sorts of large shellfish, and comparing my observations on them with the circumstances I observed in the muscles of terrestrial animals. Now, as in this instance of the beard of a wild oat, we see there is nothing else requisite to make it wreathe and unwreathe itself, and to straighten and bend its knee, than only a little breath of moist or dry air, or a small atom, almost of water or liquor, and a little heat to make it again evaporate. For by holding this beard, placed and fixed as I before directed, near a fire, and dipping the tip of a small shred of paper in well rectified spirit of wine, and then touching the wreath's cylindrical part, you may perceive it to untwist itself, and presently again, upon the avellation of the spirit, by the great heat, it will retwist itself. And thus will it move forward and backwards, as oft as you repeat the touching it with the spirit of wine. So may, perhaps, the shrinking and relaxing of the muscles be by the influx and evaporation of some kind of liquor or juice, but of this inquiry I shall add more elsewhere. End of section 32.
Section 33 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Section 33. Observation 28 of the seeds of Venus looking-glass, or corn violet. From the leaves and downs and beards of plants, we come at last to the seeds, and here indeed seems to be the cabinet of nature, wherein are laid up its jewels. The providence of nature about vegetables is in no part manifested more than in the various contrivances about the seed, nor indeed is there in any part of the vegetable so curious carvings and beautiful adornments as about the seed. This in the larger sorts of seeds is most evident to the eye, nor is it less manifest through the microscope. In those seeds whose shape and structure, by reason of their smallness, the eye is hardly able to distinguish. Of these there are multitudes, many of which I have observed through a microscope, and find that they do, for the most part, every one afford exceedingly pleasant and beautiful objects. For besides those that have various kinds of carved surfaces, there are other that have smooth and perfectly polished surfaces, others a downy hairy surface. Some are covered only with a skin, others with a kind of shell, others with both, as is observable also in greater seeds. Of these seeds I have only described 4 sorts, which may serve as a specimen of what the inquisitive observers are likely to find among the rest. The first of these seeds, which are described in the scheme 17, are those of corn violets. The seed is very small, black, and shining, and to the naked eye looks almost like a very small flea. But through the microscope it appears a large body, covered with a tough, thick, and bright reflecting skin, very irregularly shrunk and pitted, insomuch that it is almost an impossibility to find 2 of them wrinkled alike, so great a variety may there be even in this little seed. This, though it appeared one of the most promising seeds for beauty to the naked eye, yet through the microscope it appeared but a rude misshapen seed, which I therefore drew, that I might thereby manifest how unable we are by the naked eye to judge of beauteous or less curious microscopical objects. Cutting some of them in sunder, I observed them to be filled with a greenish yellow pulp, and to have a very thick husk in proportion to the pulp. End of section 33.
Section 34 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Deongines, Salt Lake City, Utah. Micrographia by Robert Hooke. Observation 29 of the seeds of time. These pretty fruits here represented in the 18 scheme are nothing else but 9 several seeds of time. They are all of them in differing posture, both as to the eye and the light, nor are they all of them exactly of the same shape, there being a great variety both in the bulk and figure of each seed. But they all agreed in this, that being looked on with a microscope, they each of them exactly resembled a lemon or orange dried, and this both in shape and color. Some of them are a little rounder, of the shape of an orange, as A and B. They have each of them a very conspicuous part, by which they were joined to their little stalk, and one of them had a little piece of stalk remaining on. The opposite side of the seed, you may perceive very plainly by the figure, is very copped and prominent, as is very usual in lemons, which prominencies are expressed in D, E, and F. They seemed each of them a little creased or wrinkled, but E was very conspicuously furrowed, as if the inward make of this seed had been somewhat like that of a lemon also. But upon dividing several seeds with a very sharp penknife and examining them afterward, I found their make to be in nothing but bulk differing from that of peas, that is, to have a pretty thick coat, and all the rest an indifferent white pulp, which seemed very close, so that it seems nature does not very much alter her method in the manner of enclosing and preserving the vital principle in the seed, in these very small grains, from that of beans, peas, etc. The grain affords a very pretty object for the microscope, namely, a dish of lemons placed in a very little room. Should a lemon or nut be proportionably magnified to what this seed of thyme is, it would make it appear as big as a large hayrick, and it would be no great wonder to see Homer's Iliads and Homer and all crammed into such a nutshell. We may perceive even in these small grains, as well as in greater, how curious and careful nature is in preserving the seminal principle of vegetable bodies, in what delicate, strong, and most convenient cabinets she lays them, and closes them in a pulp for their safer protection from outward dangers, and for the supply of convenient elemental juice when the heat of the sun begins to animate and move these little automatons or engines, as if she would, from the ornaments wherewith she has decked these cabinets, hint to us that in them she has laid up her jewels and masterpieces. And this, if we are but diligent in observing, we shall find her method throughout. There is no curiosity in the elemental kingdom, if I may so call the bodies of air, water, and earth, that are comparable in form to those of minerals, air and water having no form at all, unless a potentiality to be formed into globules, and the clods and parcels of earth are all irregular, whereas in minerals she does begin to geometrize, and practice, as 'twere, the first principles of mechanics, shaping them of plain regular figures, as triangles, squares, etc., and tetradons, cubes, etc. But none of their forms are comparable to the more compounded ones of vegetables, for here she goes a step further, forming them both of more complicated shapes, and adding also multitudes of curious mechanic contrivances in their structure. For whereas in vegetables there was no determinate number of the leaves or branches, nor no exactly certain figure of leaves, or flowers, or seeds, in animals all those things are exactly defined and determined, and wherever there is either an excess or defect of those determinate parts or limbs, there has been some impediment that has spoiled the principle which was most regular. Here we shall find not only most curiously compounded shapes, but most stupendous mechanisms and contrivances. Here the ornaments are in the highest perfection, nothing in all the vegetable kingdom that is comparable to the deckings of a peacock, nay, to the curiosity of any feather, as I elsewhere shew, nor to that of the smallest and most despicable fly. But I must not stay on these speculations. though perhaps it were very well worth while for one that had leisure to see what information may be learned of the nature or use or virtues of bodies by their several forms and various excellencies and properties. Who knows but Adam might from some such contemplation give names to all creatures, if at least his names had any significancy in them of the creature's nature on which he imposed it, as many, upon what grounds I know not, have supposed. And who knows but the Creator may, in those characters, have written and engraven many of his most mysterious designs and counsels, and given man a capacity which, assisted with diligence and industry, may be able to read and understand them. But not to multiply my digression more than I can the time, I will proceed to the next, which is end of section 34.
Section 35 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Section 35. Observation 30 of the seeds of poppy. The small seeds of poppy, which are described in the Scheme 19, both for their smallness, multiplicity, and prettiness, as also for their admirable soporific quality, deserve to be taken notice of among the other microscopical seeds of vegetables. For first, though they grow in a case or hive oftentimes bigger than one of these pictures of the microscopical appearance, yet are they for the most part so very little that they exceed not the bulk of a small nit, being not above 1/32nd part of an inch in diameter, whereas the diameter of the hive of them oftentimes exceeds 2 inches, so that it is capable of containing near 200,000, and so in all likelihood does contain a vast quantity, though perhaps not that number. Next, for their prettiness, they may be compared to any microscopical seed I have yet seen, for they are of a dark brownish-red color, curiously honeycombed all over with a very pretty variety of network, or a small kind of embossment of very orderly raised ridges, the surface of them looking not unlike the inside of a beeve's stomach. But that which makes it most considerable of all is the medicinal virtues of it, which are such as are not afforded us by any mineral preparation, and that is for the procuring of sleep, a thing as necessary to the well-being of a creature as his meat, and that which refreshes both the voluntary and rational faculties, which, whilst this affection has seized the body, are for the most part unmoved and at rest. And methinks nature does seem to hint some very notable virtue or excellency in this plant from the curiosity it has bestowed upon it. First, in its flower, it is of the highest scarlet dye, which is indeed the prime and chiefest color, and has been in all ages of the world most highly esteemed. Next, it has as much curiosity showed also in the husk or case of the seed as any one plant I have yet met withal. And thirdly, the very seeds themselves, the microscope discovers to be very curiously shaped bodies. And lastly, nature has taken such abundant care for the propagation of it, that one single seed grown into a plant is capable of bringing some 100,000s of seeds. It were very worthy some able man's inquiry whether the intention of nature, as to the secondary end of animal and vegetable substances, might not be found out by some such characters and notable impressions as these, or from divers other circumstances, as the figure, color, place, time of flourishing, springing and fading, duration, taste, smell, etc. For if such there are, as an able physician upon good grounds has given me cause to believe, we might then, instead of studying herbals, where so little is delivered of the virtues of a plant and less of truth, have recourse to the book of nature itself, and there find the most natural, useful, and most effectual and specific medicines, of which we have amongst vegetables. 2 very noble instances to encourage such a hope, the one of the Jesuit powder for the cure of intermitting fevers, and the other of the juice of poppy for the curing the defect of sleeping. End of section 35.
Section 36 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Deongines, Salt Lake City, Utah. Micrographia by Robert Hooke. Section 36. Observation 31 of purslane seed. The seeds of purslane seem of very notable shapes, appearing through the microscope, shaped somewhat like a nautilus or porcelain shell, as may be seen in the 20 scheme, it being a small body coiled round in the manner of a spiral, at the greater end whereof, which represents the mouth or orifice of the shell, there is left a little white transparent substance like a skin, represented by BBBB, which seems to have been the place whereunto the stem was joined. The whole surface of this cochlea or shell is covered over with abundance of little prominencies or buttons, very orderly ranged into spiral rows, the shape of each of which seems to resemble a wart upon a man's hand. The order, variety, and curiosity in the shape of this little seed makes it a very pleasant object for the microscope. One of them being cut asunder with a very sharp penknife, discovered this carved casket to be of a brownish red and somewhat transparent substance, and manifested the inside to be filled with a whitish green substance or pulp, the bed wherein the seminal principle lies enveloped. There are multitudes of other seeds, which in shape represent or imitate the forms of divers other sorts of shells, as the seed of scurvy grass very much resembles the make of a concha venerea, a kind of purslane shell. Others represent several sorts of larger fruits. Sweat marjoram and pot marjoram represent olives. Carrot seeds are like a cleft of a coconut husk. Others are like artificial things, as succory seeds are like a quiver full of arrows. The seeds of amaranthus are of an exceeding lovely shape, somewhat like an eye. The skin of the black and shriveled seeds of onions and leeks are all over knobbed like a seal's skin. Sorrel has a pretty black shining 3 square seed, which is picked at both ends with 3 ridges that are bent the whole length of it. It were almost endless to reckon up the several shapes, they are so many and so various. Leaving them, therefore, to the curious observer, I shall proceed to the observations on the parts of animals. End of section 36.
Section 37 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Section 37. Observation 32. Of the figure of several sorts of hair and of the texture of the skin. Viewing some of the hairs of my head with a very good microscope, I took notice of these particulars. 1. That they were, for the most part, cylindrical, some of them were somewhat prismatical, but generally they were very near round, such as are represented in the second figure of the 5th scheme by the cylinders EEE, nor could I find any that had sharp angles. 2. That part which was next the top was bigger than that which was nearer the root. 3. That they were all along, from end to end transparent, though not very clear, the end next the root appearing like a black transparent piece of horn, the end next the top more brown, somewhat like transparent horn. 4. that the root of the hairs were pretty smooth, tapering inwards, almost like a parsnip, nor could I find that it had any filaments or any other vessels, such as the fibers of plants. 5. That the top, when split, which is common in long hair, appeared like the end of the stick, beaten till it be all flittered, there being not only 2 splinters, but sometimes half a score and more. 6. That they were all, as far as I was able to find, solid cylindrical bodies, not pervious like a cane or bulrush, nor could I find that they had any pith or distinction of rind, or the like, such as I had observed in horse hairs, the bristles of a cat, the Indian deer's hair, etc. Observations on several other sorts of hair. For the bristles of a hog, I found them to be first a hard, transparent, horny substance, without the least appearance of pores or holes in it, and this I tried with the greatest care I was able, cutting many of them with a very sharp razor, so that they appeared, even in the glass, to have a pretty smooth surface, but somewhat waved by the saving to and fro of the razor, as is visible in the end of the prismatical body A of the same figure, and then making trials with causing the light to be cast on them all the various ways I could think of, that was likely to make the pores appear, if there had been any, I was not able to discover any. Next, the figure of the bristles was very various, neither perfectly round, nor sharp-edged, but prismatical, with diverse sides and round angles, as appears in the figure A. The bending of them in any part where they before appeared clear would all flaw them and make them look white. The moustachios of a cat, part of one of which is represented by the short cylinder B of the same figure, seem to have, all of them that I observed, a large pith in the middle, like the pith of an elder, whose texture was so close that I was not able to discover the least sign of pores, and those parts which seemed to be pores, as they appeared in one position to the light, in another I could find a manifest reflection to be cast from them. This I instance in, to hint that it is not safe to conclude any thing to be positively this or that, though it appear never so plain and likely when looked on with microscope in one posture, before the same be examined by placing it in several other positions. And this I take to be the reason why many have believed and asserted the hairs of a man's head to be hollow, and like so many small pipes perforated from end to end. Now, though I grant that by an analogy one may suppose them so, and from the Polonian disease one may believe them such, yet I think we have not the least encouragement to either from the microscope, much less positively to assert them such. And perhaps the very essence of the plica polonica may be the hairs growing hollow and of an unnatural constitution. And as for the analogy, though I am apt enough to think that the hairs of several animals may be perforated somewhat like a cane, or at least have a kind of pith in them, first, because they seem as it were a kind of vegetable growing on an animal, which growing, they say, remains a long while after the animal is dead, and therefore should, like other vegetables, have a pith, and secondly, because horns and feathers and porcupines' quills and cats' bristles and the long hairs of horses, which come very near the nature of a man's hair, seem all of them to have a kind of pith, and some of them to be porous, yet I think it not, in the cases where we have such helps for the sense as the microscope affords, safe, concluding or building on more than we sensibly know. Since we may, by examining, find that nature does in the make of the same kind of substance often vary her method in framing of it. Instances enough to confirm this we may find in the horns of several creatures. As what a vast difference is there between the horns of an ox and those of some sorts of stags as to their shape, and even in the hairs of several creatures we find a vast difference, as the hair of a man's head seems, as I said before, long, cylindrical, and sometimes a little prismatical, solid or impervious, and very small. The hair of an Indian deer, a part of the middle of which is described in the third figure of the fifth scheme marked with F, is bigger in compass through all the middle of it than the bristle of an hog, but the end of it is smaller than the hair of any kind of animal, as may be seen by the figure G. The whole belly of it, which is about 2 or 3 inches long, looks to the eye like a thread of coarse canvas that has been newly unwreathed, it being all waved or bended to and fro, much after that manner, but through the microscope it appears all perforated from side to side and spongy, like a small kind of spongy coral, which is often found upon the English shores. But though I cut it transversely, I could not perceive that it had any pores that ran the long way of the hair. The long hairs of horses, C and D, seem cylindrical and somewhat pithy. The bristles of a cat, B, are conical and pithy. The quills of porcupines and hedgehogs, being cut transversely, have a whitish pith in the manner of a star or spar rowel. Pig's hair, A, is somewhat triagonal and seems to have neither pith nor pore, and other kinds of hair have quite a differing structure and form, and therefore I think it no way agreeable to a true natural historian to pretend to be so sharp-sighted as to see what a preconceived hypothesis tells them should be there, where another man, though perhaps as seeing but not forestalled, can discover no such matter. But to proceed. I observed several kinds of hairs that had been dyed, and found them to be a kind of horny cylinder, being of much about the transparency of a pretty clear piece of ox horn. These appeared quite throughout tinged with the colours they exhibited. And it is likely that those hairs being boiled or steeped in those very hot tinged liquors in the dye fat, and the substance of the hair being much like that of an ox horn, the penetrant liquor does so far mollify and soften the substance that it sinks into the very centre of it, and so the tinged parts come to be mixed and united with the very body of the hair, and do not, as some have thought, only stick on upon the outward surface. And this the boiling of horn will make more probable, for we shall find by that action that the water will insinuate itself to a pretty depth within the surface of it, especially if this penetrancy of the water be much helped by the salts that are usually mixed with dyeing liquors. Now, whereas silk may be dyed or tinged into all kind of colours without boiling or dipping into hot liquors, I guess the reason to be twofold. First, because the filaments or small cylinders of silk are abundantly smaller and finer, and so have a much less depth to be penetrated than most kind of hairs, and next, because the substance or matter of silk is much more like a glue than the substance of hair is, and that I have reason to suppose, first, because when it is spun or drawn out of the worm, it is a perfect glutinous substance, and very easily sticks and cleaves to any adjacent body, as I have several times observed, both in silkworms and spiders. Next, because that I find that water does easily dissolve and mollify the substance again, which is evident from their manner of ordering those bottoms or pods of the silkworm before they are able to unwind them. It is no great wonder, therefore, if those dyes or tinged liquors do very quickly mollify and tinge the surfaces of so small and so glutinous a body. And we need not wonder that the colours appear so lovely in the one and so dull in the other, if we view but the tinged cylinders of both kinds with a good microscope. For whereas the substance of hair at best is but a dirty duskish white, somewhat transparent, the filaments of silk have a most lovely transparency and clearness, the difference between those two being not much less than that between a piece of horn and a piece of crystal, the one yielding a bright and vivid reflection from the concave side of the cylinder, that is, from the concave surface of the air that encompasses the back part of the cylinder, the other yielding a dull and perturbed reflection from the several heterogeneous parts that compose it. And this difference will be manifest enough to the eye if you get a couple of small cylinders, the smaller of crystal glass, the other of horn, and then varnishing them over very thinly with some transparent color, which will represent to the naked eye much the same kind of object which is represented to it from the filaments of silk and hair by the help of the microscope. Now, since the threads of silk and serge are made up of a great number of these filaments, we may henceforth cease to wonder at the difference. From much the same reason proceeds the vivid and lovely colors of feathers, wherein they very far exceed the natural as well as artificial colors of hair, of which I shall say more in its proper place. The teguments indeed of creatures are all of them adapted to the peculiar use and convenience of that animal which they enwrap, and very much also for the ornament and beauty of it, as will be most evident to any one that shall attentively consider the various kinds of clothings wherewith most creatures are by nature invested and covered. Thus I have observed that the hair or fur of those northern white bears that inhabit the colder regions is exceedingly thick and warm. The like have I observed of the hair of a Greenland deer, which being brought alive to London, I had the opportunity of viewing. Its hair was so exceeding thick, long, and soft, that I could hardly with my hand grasp or take hold of his skin, and it seemed so exceeding warm, as I have never met with any before. And as for the ornamentative use of them, it is most evident in a multitude of creatures, not only for color, as the leopards, cats, reindeer, etc., but for the shape, as in horses' manes, cats' beards, and several other of the greater sort of terrestrial animals, but is much more conspicuous in the vestments of fishes, birds, insects, of which I shall by and by give some instances. As for the skin, the microscope discovers as great a difference between the texture of those several kinds of animals as it does between their hairs. But all that I have yet taken notice of, when tanned or dressed, are of a spongy nature, and seem to be constituted of an infinite company of small, long fibers or hairs, which look not unlike a heap of tow or oakum, every of which fibers seem to have been some part of a muscle, and probably, whilst the animal was alive, might have its distinct function, and serve for the contraction and relaxation of the skin, and for the stretching and shrinking of it this or that way. And indeed, without such a kind of texture as this, which is very like that of spunk, it would seem very strange how anybody so strong as the skin of an animal usually is, and so close as it seems, whilst the animal is living, should be able to suffer so great an extension any ways, without at all hurting or delacerating any part of it. But since we are informed by the microscope that it consists of a great many small filaments which are implicated or entangled one within another, almost no otherwise than the hairs in a lock of wool, or the flakes in a heap of tow, though not altogether so loose, but the filaments are here and there twisted, as it were, or interwoven, and here and there they join and unite with one another, so as indeed the whole skin seems to be but one piece, we need not much wonder. And though these fibers appear not through a microscope exactly jointed or contexted as in sponge, yet, as I formerly hinted, I am apt to think that could we find some way of discovering the texture of it, whilst it invests the living animal, or had some very easy way of separating the pulp or intercurrent juices, such as in all probability fill those interstitia, without delacerating, bruising, or otherwise spoiling the texture of it, as it seems to be very much by the ways of tanning and dressing now used, we might discover a much more curious texture than I have hitherto been able to find, perhaps somewhat like that of sponges. That of chamois leather is indeed very much like that of spunk, have only that the filaments seem nothing near so even and round, nor altogether so small, nor has it so curious joints as spunk has, some of which I have lately discovered like those of a sponge, and perhaps all these three bodies may be of the same kind of substance, though two of them indeed are commonly accounted vegetable, which, whether they be so or no, I shall not now dispute. But this seems common to all three, that they undergo a tanning or dressing, whereby the interspersed juices are wasted and washed away before the texture of them can be discovered. What their way is of dressing or curing sponges, I confess I cannot learn, but the way of dressing spunk is, by boiling it a good while in the strong lixivium, and then beating it very well, and the manner of dressing leather is sufficiently known. It were indeed extremely desirable, if such a way could be found, whereby the parenchyma or flesh of the muscles, and several other parts of the body, might be washed or wafted clean away, without vitiating the form of the fibrous parts or vessels of it, for hereby the texture of those parts, by the help of a good microscope, might be most accurately found. But to digress no further, we may, from this discovery of the microscope, plainly enough understand how the skin, though it looks so close as it does, comes to give a passage to so vast a quantity of excrementitious substances, as the diligent Sanctorius has excellently observed it to do in his Medicina Statica, for it seems very probable, from the texture after dressing, that there are an infinite of pores that every way pierce it, and that those pores are only filled with some kind of juice, or some very pulpy soft substance, and thereby the steams may almost as easily find a passage through such a fluid vehicle as the vaporous bubbles which are generated at the bottom of a kettle of hot water do find a passage through that fluid medium into the ambient air. Nor is the skin of animals only thus pervious, but even those of vegetables also seem to be the same. For otherwise I cannot conceive why, if two sprigs of rosemary, for instance, be taken as exactly alike in all particulars as can be, and the one be set with the bottom in a glass of water, and the other be set just without the glass, but in the air only, though you stop the lower end of that in the air very carefully with wax, yet shall it presently almost wither, whereas the other that seems to have a supply from the subjacent water by its small pipes or microscopical pores, preserves its greenness for many days and sometimes weeks. Now this to me seems not likely to proceed from any other cause than the avallation of the juice through the skin, for by the wax all those other pores of the stem are very firmly and closely stopped up, and from the more or less porousness of the skins or rinds of vegetables may, perhaps, be somewhat of the reason given why they keep longer green or sooner wither. For we may observe by the bladdering and cracking of the leaves of bays, holly, laurel, etc., that their skins are very close, and do not suffer so free a passage through them of the included juices. But of this and of the experiment of the rosemary I shall elsewhere more fully consider, seeming to me an extreme luciferous experiment, such as seems indeed very plainly to prove that schematism, or structure of vegetables altogether mechanical, and as necessary that, water and warmth being applied to the bottom of the sprig of a plant, some of it should be carried upwards into the stem, and thence distributed into the leaves, as that the water of the Thames covering the bottom of the mills at the bridge foot of London, and by the ebbing and flowing of it, passing strongly by them, should have some part of it conveyed to the cisterns above, and thence into the several houses and cisterns up and down the city. End of section 37.
Section 38 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Section 38. Observation 33. Of the scales of a sole and other fishes. Having hinted somewhat at the skin and covering of terrestrial animals, I shall next add an observation I made on the skin and scales of a sole, a small fish, commonly enough known, and here, in fishes, as well as other animals, nature follows its usual method, framing all parts so as that they are both useful and ornamental in all its composures, mingling utile and dulce together, and both these designs, it seems to follow, though our unassisted senses are not able to perceive them. This is not only manifest in the covering of this fish, but in multitudes of others, which it would be too long to enumerate, witness particularly that small sand shell which I had mentioned in the 11 observation, and infinite other small shells and scales, divers of which I have viewed. This skin I viewed was flead from pretty large sole, and then expanded and dried. The inside of it, when dry to the naked eye, looked very like a piece of canvas. But the microscope discovered that texture to be nothing else but the inner ends of those curious scalloped scales III in the second figure of the 21 scheme, namely the part of GGGG of the larger representation of a single scale in the first figure of the same scheme, which on the back side, through an ordinary single magnifying glass, looked not unlike the tiles in a house. The outside of it, to the naked eye, exhibited nothing more of ornament, save the usual order of ranging the scales into a triagonal form, only the edges seemed a little to shine, the finger being rubbed from the tailwards towards the head. The scale seemed to stay and raise it, but through an ordinary magnifying glass it exhibited a most curiously carved and adorned surface, such as is visible in a second figure, each of those, formerly almost imperceptible, scales appearing much of the shape III, that is, they were round and protuberant and somewhat shaped like a scallop, the whole scale being creased with curiously waved and indented ridges, with proportionable furrows between, each of which was terminated with a very sharp, transparent, bony substance, which, like so many small turnpikes, seemed to arm the edges. The back part KKK was the skin into which each of these scales were very deeply fixed, in the curious regular order visible in the second figure. The length and shape of the part of the scale which was buried by the skin is evidenced by the first figure, which is the representation of one of them plucked out in view through a good microscope, namely the part LFGGFL, wherein is also more plainly to be seen the manner of carving of the scalloped part of every particular scale, how each ridge or bar EEE is alternatively hollowed or engraven, and how every gutter between them is terminated with very transparent and hard-pointed spikes, and how every other of these, as AAAA, are much longer than the interjacent ones DDD. The texture or form also of the hidden part appears, namely the middle part GGG seems to consist of a great number of small quills or pipes, by which, perhaps, the whole may be nourished, and the side parts FF consist of a more fibrous texture, though indeed the whole scale seemed to be of a very tough gristly substance like the larger scales of other fishes. The scales of the skin of a dogfish, which is used by such as work in wood for the smoothing of their work, and consists plainly enough to the naked eye of a great number of small horny points, through the microscope appeared each of them curiously ridged and very neatly carved, and indeed you can hardly look on the scales of any fish but you may discover abundance of curiosity and beautifying, and not only in these fishes but in the shells and crusts or armor of most sorts of marine animals so invested. End of section 38.
Section 39 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke, Section 39. Observation 34. Of the sting of a bee. The sting of a bee, delineated in the second figure of the 16th scheme, seems to be a weapon of offense, and is as great an instance that nature did really intend revenge as any. In the first, because there seems to be no other use of it. Secondly, by reason of its admirable shape, seeming to be purposely shaped for that very end. Thirdly, from the virulency of the liquor it ejects, and the sad effects and symptoms that follow it. But whatever be the use of it, certain it is that the structure of it is very admirable. What it appears to the naked eye I need not describe, the thing being known almost to every one, but it appears through the microscope to consist of two parts, the one a sheath without a chape or top, shaped almost like the holster of a pistol, beginning at D and ending at B. This sheath I could most plainly perceive to be hollow, and to contain in it both a sword or dart, and the poisonous liquor that causes the pain. The sheath, or case, seemed to have several joints or settings together, marked by FGHIKLMNO. It was armed moreover near the top with several crooks, or forks, PQRST on one side, and PQRSTU on the other, each of which seemed like so many thorns growing on a briar, or rather like so many cat's claws. For the crooks themselves seemed to be little sharp transparent points, or claws, growing out of little protuberancies on the side of the sheath, which, by observing the figure diligently, is easy enough to be perceived, and from several particulars I suppose the animal has a power of displaying them and shutting them in again as it pleases, as a cat does its claws, or as an adder or viper can its teeth or fangs. The other part of the sting was the sword, as I may so call it, which is sheathed, as it were, in it, the top of which, AB, appears quite through at the smaller end, just as if the chape of the sheath of a sword were lost, and the end of it appeared beyond the scabbard. The end of this dart, A, was very sharp, and it was armed likewise with the like tender hooks or claws with those of the sheath, such as VXY, XYZZ. These crooks, I am very apt to think, can be closed up also or laid flat to the sides of the sword when it is drawn into the scabbard, as I have several times observed it to be, and can be spread again or extended whenever the animal pleases. The consideration of which very pretty structure has hinted to me that certainly the use of these claws seems to be very considerable, as to the main end of this instrument, for the drawing in and holding the sting in the flesh. For the point being very sharp, the top of the sting or dagger, AB, is very easily thrust into an animal's body, which being once entered, the bee, by endeavoring to pull it into the sheath, draws, by reason of the crooks, VXY and XYZZ, which lay hold of the skin on either side, the top of the sheath, TSRV, into the skin after it, and the crooks, TS and RV, being entered, when the bee endeavors to thrust out the top of the sting out of the sheath again, they lay hold of the skin on either side, and do not only keep the sheath from sliding back, but helps the top inwards, and thus by an alternate and successive retracting and emitting of the sting in and out of the sheath, the little enraged creature by degrees makes his revengeful weapon pierce the toughest and thickest hides of his enemies, insomuch that some few of these stout and resolute soldiers with these little engines do often put to flight a huge nasty bear, one of their deadly enemies, and thereby show the world how much more considerable in war a few skilful engineers and resolute soldiers politically ordered, that know how to manage such engines, are, than a vast unwieldy rude force, that confides in and acts only by its strength. But, to proceed, that he thus gets in his sting into the skin, I conjecture, because when I have observed this creature living, I have found it to move the sting thus, to and fro, and thereby also perhaps does, as 'twere, pump or force out the poisonous liquor, and make it hang at the end of the sheath about B in a drop. The crooks I suppose also to be the cause why these angry creatures, hastily removing themselves from their revenge, do often leave these weapons behind them, sheathed as 'twere in the flesh, and by that means cause the painful symptoms to be greater and more lasting, which are very probably caused partly by the piercing and tearing of the skin by the sting, but chiefly by the corrosive and poisonous liquor that is by this syringe pipe conveyed among the sensitive parts thereof, and thereby more easily gnaws and corrodes those tender fibers, as I have showed in the description of a nettle and of cowage. End of section 39. Recording by Philip Gould. Section 40 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Section 40. Observation 35. Of the contexture and shape of the particles of feathers. Examining several sorts of feathers, I took notice of these particulars in all sorts of wing feathers, especially in those which served for the beating of the air in the action of flying. That the outward surface of the quill and stem was of a very hard, stiff, and horny substance, which is obvious enough, and that the part above the quill was filled with a very white and light pith, and with the microscope I found this pith to be nothing else but a kind of natural congeries of small bubbles, the films of which seemed to be of the same substance with that of the quill, that is, of a stiff, transparent, horny substance. Which particular seems to me very worthy a more serious consideration. For here we may observe nature, as 'twere, put to its shifts, to make a substance which shall be both light enough, and very stiff and strong, without varying from its own established principles, which we may observe to be such, that very strong bodies are, for the most part, very heavy also. A strength of the parts usually requiring a density, and a density a gravity. And therefore, should nature have made a body so broad and so strong as a feather, almost any other way than what it has taken, the gravity of it must necessarily have many times exceeded this. For this pith seems to be like so many stops or cross pieces in a long optical tube, which do very much contribute to the strength of the whole, the pores of which were such as that they seem not to have any communication with one another, as I have elsewhere hinted. But the mechanism of nature is usually so excellent that one and the same substance is adapted to serve for many ends. For the chief use of this, indeed, seems to be for the supply of nourishment to the downy or feathery part of the stem. For 'tis obvious enough in all sorts of feathers that 'tis placed just under the roots of the branches that grow out of either side of the quill, or stalk, and is exactly shaped according to the ranking of those branches, coming no lower into the quill than just the beginning of the downy branches, and growing only on the under side of the quill where those branches do so. Now in a ripe feather, as one may call it, it seems difficult to conceive how the succus nutritius should be conveyed to this pith, for it cannot, I think, be well imagined to pass through the substance of the quill, since, having examined it with the greatest diligence I was able, I could not find the least appearance of pores. But he that shall well examine an unripe or pinned feather will plainly enough perceive that the vessel for the conveyance of it to be the thin, filmy pith, as 'tis called, which passes through the middle of the quill. As for the make and contexture of the down itself, it is indeed very rare and admirable, and such as I can hardly believe, that the like is to be discovered in any other body in the world. For there is hardly a large feather in the wing of a bird but contains near 1,000,000 of distinct parts, and every one of them shaped in a most regular and admirable form, adapted to a particular design. For examining a middle-sized goose quill, I easily enough found with my naked eye that the main stem of it contained about 300 longer and more downy branchings upon one side, and as many on the other, of more stiff but somewhat shorter branchings. Many of these long and downy branchings, examined with an ordinary microscope, I found divers of them to contain near 1200 small leaves, as I may call them, such as EF of the first figure of the 22nd scheme, and as many stalks on the other side, such as IK of the same figure. Each of the leaves or branchings, EF, seemed to be divided into about 16 or 18 small joints, as may be seen plainly enough in the figure, out of most of which there seem to grow small long fibers, such as are expressed in the figure, each of them very proportionably shaped according to its position or placed on the stalk EF. Those on the underside of it, namely 1, 2, 3, 4, 5, 6, 7, 8, 9, etc., being much longer than those directly opposite to them on the upper, and divers of them, such as 2, 3, 4, 5, 6, 7, 8, 9, etc., were terminated with small crooks, much resembling those small crooks which are visible enough to the naked eye in the seed buttons of burdocks. The stalks likewise, IK on the other side, seem divided into near as many small knotted joints, but without any appearance of strings or crooks, each of them about the middle, K, seem divided into two parts by a kind of fork, on one side of which, namely KL, was extended near the length of KI, the other M was very short. The transverse sections of the stems of these branchings manifested the shape or figure of it to be much like INOE, which consisted of a horny skin or covering, and a white seemingly frothy pith, much like the make of the main stem of a feather. The use of this strange kind of form is indeed more admirable than all the rest, and as such deserved to be much more seriously examined and considered than I have hitherto found time or ability to do. For certainly it may very much instruct us in the nature of the air, especially as to some properties of it. The stems of the downy branches, INOE, being ranged in the order visible enough to the naked eye at a distance of IF, or somewhat more, the collateral stalks and leaves, if I may so call those bodies I newly described, are so ranged that the leaves or hairy stalks of the one side lie at top, or are incumbent on the stalks of the other, and cross each other, much after the manner expressed in the second figure of the 22nd scheme, by which means every of those little hooked fibers of the leaved stalk get between the naked stalks, and the stalks being full of knots, and a pretty way disjoined, so as that the fibers can easily get between them, the two parts are so closely and admirably woven together that it is able to impede, for the greatest part, the transcursion of the air. And though they are so exceeding small, as that the thickness of one of those stalks amounts not to a 500th part of an inch, yet do they compose so strong a texture, as notwithstanding the exceeding quick and violent beating of them against the air by the strength of the bird's wing, they firmly hold together. And it argues an admirable providence of nature in the contrivance and fabric of them, for their texture is such that though by any external injury the parts of them are violently disjoined, so as that the leaves and stalks touch not one another, and consequently several of these rents would impede the bird's flying, yet for the most part of themselves they readily rejoin and recontext themselves, and are easily, by the bird stroking the feather or drawing it through its bill, all of them settled and woven into their former and natural posture. For there are such an infinite company of those small fibers in the underside of the leaves, and most of them have such little crooks at their ends, that they readily catch and hold the stalks they touch. From which strange contexture it seems rational to suppose that there is a certain kind of mesh, or hole so small that air will not very easily pass through it, as I hinted also in the 6th observation about small glass canes, for otherwise it seems probable that nature would have drawn over some kind of thin film, which should have covered all those almost square meshes, or holes, there seeming through the microscope to be more than half of the surface of the feather, which is open and visibly pervious, which conjecture will yet seem more probable from the texture of the brushy wings of the Tinea argentea, or white feather winged moth, which I shall anon describe. But nature, that knows best its own laws and the several properties of bodies, knows also best how to adapt and fit them to her desired end. And whoso would know those properties must endeavor to trace nature in its working, and to see what course she observes. And this, I suppose, will be no inconsiderable advantage, which the schematisms and structures of animate bodies will afford the diligent inquirer, namely most sure and excellent instructions, both as to the practical part of mechanics and to the theory and knowledge of the nature of the bodies and motions. End of section 40. Recording by Philip Gould. Section 41 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Section 41. Observation 36. Of peacocks, ducks, and other feathers of changeable colors. The parts of the feathers of this glorious bird appear, through the microscope, no less gaudy than do the whole feathers. For as to the naked eye, 'tis evident that the stem or quill of each feather in the tail sends out multitudes of lateral branches, such as AB in the third figure of the 22nd scheme represents a small part of about 1/32nd part of an inch long, and each of the lateral branches emit multitudes of little sprigs, threads or hairs on either side of them, such as CD, CD, CD. So each of those threads in the microscope appears a large, long body, consisting of a multitude of bright reflecting parts, whose figure 'tis no easy matter to determine, as he that examines it shall find, for every new position of it to the light makes it perfectly seem of another form and shape, and nothing what it appeared a little before. Nay, it appeared very differing ofttimes from so seemingly inconsiderable a circumstance, that the interposing of one's hand between the light and it makes a very great change, and the opening or shutting a casement, and the like, very much diversifies the appearance. And though by examining the form of it very many ways, which would be tedious here to enumerate, I suppose I have discovered the true figure of it, yet oftentimes upon looking on it in another posture, I have almost thought my former observations deficient, though indeed upon further examination I have found even those also to confirm them. These threads therefore I find to be a congeries of small laminae, or plates, as E, etc., each of them shaped much like this of ABCD in the fourth figure, the part AC being a ridge, prominency, or stem, and B and D the corners of two small thin plates that grow into the small stalk in the middle, so that they make a kind of little feather. Each of these plates lie one close to another, almost like a company of sloping ridge or gutter tiles. They grow on each side of the stalk opposite to one another by 2 and 2, from top to bottom, in the manner expressed in the fifth figure, the tops of the lower covering the roots of the next above them. The underside of each of these laminated bodies is of a very dark and opacious substance, and suffers very few rays to be trajected, but reflects them all toward that side from whence they come, much like the foil of a looking-glass. But their upper sides seem to me to consist of a multitude of thin-plated bodies, which are exceeding thin, and lie very close together, and thereby, like mother-of-pearl shells, do not only reflect a very brisk light, but tinge that light in a most curious manner, and by means of various positions in respect of the light, they reflect back now one color, and then another, and those most vividly. Now that these colors are only fantastical ones, that is, such as arise immediately from the refractions of the light, I found by this that water wetting these colored parts destroyed their colors, which seemed to proceed from the alteration of the reflection and refraction. Now, though I was not able to see those hairs at all transparent by a common light, yet by looking on them against the sun I found them to be tinged with a darkish red color, nothing akin to the curious and lovely greens and blues they exhibited. What the reason of color seems to be in such thin-plated bodies I have elsewhere shown, but how water cast upon those threads destroys their colors I suppose to be performed thus. The water falling upon these plated bodies from its having a greater congruity to feathers than the air, insinuates itself between those plates and so extrudes the strong reflecting air, whence both these parts grow more transparent, as the microscope informs, and colorless also at best, retaining a very faint and dull color. But this wet being wasted away by the continual evaporations and steams that pass through them from the peacock whilst that bird is yet alive, the colors again appear in their former luster, the interstitia of these plates being filled with the strongly reflecting air. The beauteous and vivid colors of the feathers of this bird, being found to proceed from the curious and exceeding smallness and fineness of the reflecting parts, we have here the reason given us of all those gauderies in the apparel of other birds also, and how they come to exceed the colours of all other kinds of animals, besides insects. For since, as we here and elsewhere also show, the vividness of a colour depends upon the fineness and transparency of the reflecting and refracting parts, and since our microscope discovers to us that the component parts of feathers are such, and that the hairs of animals are otherwise, and since we find also by the experiment of that noble and most excellent person I formerly named, that the difference between silk and flax as to its colour is nothing else, for flax, reduced to a very great fineness of parts, both white and coloured, appears as white and as vivid as any silk, but loses that brightness and its silken aspect as soon as it is twisted into thread, by reason that the component parts, though very small and fine, are yet pliable flakes and not cylinders, and thence by twisting become united into one opacious body, whereas the threads of silk and feathers retain their lustre by preserving their cylindrical form entire without mixing, so that each reflected and refracting beam that composes the gloss of silk preserves its own property of modulating the light entire. And since we find the same confirmed by many other experiments elsewhere mentioned, I think we may safely conclude this for an axiom, that wheresoever we meet with transparent bodies spun out into very fine parts, either clear or any ways tinge the colours resulting from such a composition, must necessarily be very glorious, vivid, and clear, like those of silk and feathers. This may perhaps hint some useful way of making other bodies besides silk be susceptible of bright tinctures, but of this only by the by. The changeable coloured feathers also of ducks and several other birds I have found by examination with my microscope to proceed from much the same causes and textures. End of section 41. Recording by Philip Gould.
Section 42 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by John Brandon. Micrographia by Robert Hooke. Observation 37. Of the feet of flies and several other insects. The foot of a fly, delineated in the first figure of the 23 scheme, which represents 3 joints, the 2 talons, and the 2 patterns in a flat posture, and in the second figure of the same scheme, which represents only 1 joint, the talons and patterns in another posture, is of a most admirable and curious contrivance. For by this the flies are enabled to walk against the sides of glass, perpendicularly upwards, and to contain themselves in that posture as long as they please. Nay, to walk and suspend themselves against the under surface of many bodies, as the ceiling of a room, or the like, and this with as great a seeming facility and firmness as if they were a kind of antipods, and had a tendency upwards, as we are sure they have the contrary, which they also evidently discover, in that they cannot make themselves so light as to stick or suspend themselves on the under surface of a glass well polished and cleansed. Their suspension therefore is wholly to be ascribed to some mechanical contrivance in their feet, which what it is, we shall in brief explain by showing that its mechanism consists principally in 2 parts. That is, first, its 2 claws, or talons, and secondly, 2 palms, patterns, or soles. The 2 talons are very large in proportion to the foot, and handsomely shaped in the manner described in the figures by AB and AC. The bigger part of them, from A to DD, is all hairy or bristled, but toward the top, at C and B, smooth, the tops or points, which seem very sharp, turning downwards and inwards, are each of them moved on a joint at A, by which the fly is able to open or shut them at pleasure, so that the points B and C being entered in any pores, and the fly endeavoring to shut them, the claws not only draw one against another, and so fasten each other, but they draw the whole foot,
GGADD forward, so that on a soft footing the tenters or points GGGG, whereof a fly has about 10 in each foot, to wit, 2 in every joint, run into the pores, if they find any, or at least make their way, and this is sensible to the naked eye, in the feet of a chaffer, which if he be suffered to creep over the hand, or any other part of the skin of one's body, does make his steps as sensible to the touch as the sight. By this contrivance, as it often fails the chaffer, when he walks on hard and close bodies, so would it also our fly, though he be a much lesser and nimbler creature, and therefore nature has furnished his foot with another additament, much more curious and admirable, and that is with a couple of palms, patterns, and soles DD, the structure of which is this. From the bottom or under part of the last joint of his foot, K, arise 2 small, thin-plated horny substances, each consisting of 2 flat pieces, DD, which seem to be flexible, like the covers of a book about FF, by which means the planes of the 2 sides EE do not always lie in the same plane, but may be sometimes shut closer. So each of them may take a little hold themselves on a body. But that is not all, for the undersides of these soles are all beset with small bristles or tenters, like the wire teeth of a card used for working wool, the points of all which tend forwards, hence the 2 talons drawing the feet forwards, as I before hinted, and these being applied to the surface of the body, with all the points looking the contrary way, that is, forwards and outwards. If there be any irregularity or yielding in the surface of the body, the fly suspends itself very firmly and easily, without the access or need of any such sponges filled with an imaginary gluten, as many have for want of good glasses perhaps, or a troublesome and diligent examination supposed. Now that the fly is able to walk on glass proceeds partly from some ruggedness of the surface, and chiefly from a kind of tarnish or dirty smoky substance which adheres to the surface of that very hard body, and though the pointed parts cannot penetrate the surface of glass, yet may they find pores enough in the tarnish, or at least make them. This structure I somewhat the more diligently surveyed, because I could not well comprehend how, if there were such a glutinous matter in those supposed sponges, as most that have observed that object in a microscope have hitherto believed, how, I say, the fly could so readily unglue and loosen its feet, and because I have not found any other creature to have a contrivance any ways like it, and chiefly that we might not be cast upon unintelligible explanations of the phenomena of nature, at least others than the true ones, where our senses were able to furnish us with an intelligible, rational, and true one. Somewhat a like contrivance to this of flies shall we find in most other animals, such as all kinds of flies and case-winged creatures. Nay, in a flea, an animal abundantly smaller than this fly. Other creatures, as mites, the land crab, etc., have only 1 small, very sharp talon at the end of each of their legs, which all drawing towards the center or middle of their body enable these exceeding light bodies to suspend and fasten themselves to almost any surface. Which how they are able to do will not seem strange if we consider first how little body there is in one of these creatures compared to their superficies, or outside, their thickness perhaps oftentimes not amounting to the 100th part of an inch. Next, the strength and agility of these creatures compared to their bulk being proportionable to their bulk, perhaps 100 times stronger than an horse or man. And thirdly, if we consider that nature does not always appropriate the instruments so as they are the most fit and convenient to perform their offices, and the most simple and plain that possibly can be. This we may see further verified also in the foot of a louse, which is very much differing from those I have been describing, but more convenient and necessary for the place of its habitation, each of his legs being footed with a couple of small claws, which he can open or shut at pleasure, shaped almost like the claws of a lobster or crab, but with appropriated contrivances for his peculiar life, which being to move its body to and fro upon the hairs of the creature it inhabits. Nature has furnished one of its claws with joints, almost like the joints of a man's fingers, so as thereby it is able to encompass or grasp a hair as firmly as a man can a stick or rope. Nor is there a less admirable and wonderful mechanism in the foot of a spider, whereby he is able to spin, weave, and climb, or run on his curious transparent clue, of which I shall say more in the description of that animal. And to conclude, we shall in all things find that nature does not only work mechanically, but by such excellent and most compendious as well as stupendous contrivances, that it were impossible for all the reason in the world to find out any contrivance to do the same thing that should have more convenient properties. And can any be so sottish as to think all those things the productions of chance? Certainly either their ratiocination must be extremely depraved, or they did never attentively consider and contemplate the works of the Almighty. End of section 42. Recording by John Brandon. Section 43 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by John Brandon. Micrographia by Robert Hooke. Observation 38. Of the structure and motion of the wings of flies. The wings of all kinds of insects are for the most part very beautiful objects, and afford no less pleasing an object to the mind to speculate upon than to the eye to behold. This of the blue fly, among the rest, wants not its peculiar ornaments and contrivances. It grows out of the thorax, or middle part of the body of a fly, and is seated a little behind the center of gravity in the body, towards the head, but that eccentrically is curiously balanced, first by the expanded area of the wings, which lies all more backwards than the root, by the motion of them, whereby the center of their vibration is much more backwards towards the tail of the fly than the root of the wing is. What the vibrative motion of the wing is, and after what manner they are moved, I have endeavored by many trials to find out. And first, for the manner of their motion, I endeavored to observe several of those kind of small spinning flies, which will naturally suspend themselves, as it were, poised and steady in one place of the air, without rising or falling, or moving forwards or backwards. For by looking down on those, I could, by a kind of faint shadow, perceive the utmost extremes of the vibrative motion of their wings, which shadow, whilst they so endeavored to suspend themselves, was not very long. But when they endeavored to fly forwards, it was somewhat longer. Next, I tried it by fixing the legs of a fly upon the top of the stalk of a feather with glue, wax, etc., and then making it endeavor to fly away. For being thereby able to view it in any posture, I collected that the motion of the wing was after this manner. The extreme limits of the vibrations were usually somewhat about the length of the body distant from one another, oftentimes shorter, and sometimes also longer. But the foremost limit was usually a little above the back, and the hinder somewhat beneath the belly. Between which two limits, if one may guess by the sound, the wings seem to be moved forwards and backwards with an equal velocity. And if one may, from the shadow or faint representation the wings afforded, and from the consideration of the nature of the thing, guess at the posture or manner of the wings moving between them, it seemed to be this: The wing being supposed placed in the utmost limit seems to be put so that the plane of it lies almost horizontal, but only the forepart does dip a little, or is somewhat more depressed. In this position is the wing vibrated or moved to the lower limit, being almost arrived at the lower limit, the hinder part of the wing moving somewhat faster than the former. The area of the wing begins to dip behind, and in that posture seems it to be moved to the upper limit back again, and thence back again in the first posture, the former part of the area dipping again as it is moved downwards by means of the quicker motion of the main stem which terminates or edges the fore part of the wing. And these vibrations or motions to and fro between the two limits seem so swift that 'tis very probable, from the sound it affords, if it be compared with the vibration of a musical string tuned unison to it, it makes many hundreds, if not some thousands of vibrations in a second minute of time. And if we may be allowed to guess by the sound, the wing of a bee is yet more swift, for the tone is much more acute, and that in all likelihood proceeds from the exceeding swift beating of the air by the small wing. And it seems the more likely, too, because the wing of a bee is less in proportion to its body than the other wing to the body of a fly, so that for aught I know, it may be one of the quickest vibrating spontaneous motions of any in the world, and though perhaps there may be many flies in other places that afford a yet more shrill note with their wings, yet 'tis more probable that the quickest vibrating spontaneous motion is to be found in the wing of some creature. Now, if we consider the exceeding quickness of these animal spirits that must cause these motions, we cannot choose but admire the exceeding vividness of the governing faculty or anima of the insect, which is able to dispose and regulate so the motive faculties as to cause every peculiar organ not only to move or act so quick, but to do it also so regularly. Whilst I was examining and considering the curious mechanism of the wings, I observed that under the wings of most kind of flies, bees, etc., there were placed certain pendulums or extended drops, as I may so call them, from their resembling motion and figure, for they much resembled a long hanging drop of some transparent viscous liquor, and I observed them constantly to move, just before the wings of the fly began to move, so that at the first sight I could not but guess that there was some excellent use as to the regulation of the motion of the wing, and did fancy that it might be something like the handle of a cock, which by vibrating to and fro might, as 'twere, open and shut the cock, and thereby give a passage to the determinate influences into the muscles. Afterwards, upon some other trials, I supposed that they might be for some use in respiration, which for many reasons I supposed those animals to use, and methought it was not very improbable, but that they might have convenient passages under the wings for the emitting, at least of the air, if not admitting, as in the gills of fishes, is most evident. Or perhaps this pendulum might be somewhat like the staff of a pump, whereby these creatures might exercise their analogous lungs, and not only draw in but force out the air they live by. But these were but conjectures, and upon further examination seemed less probable. The fabric of the wing, as it appears through a moderately magnifying microscope, seems to be a body consisting of two parts, as is visible in the 4 figure of the 23 scheme, and by the 2 figure of the 26 scheme. The one is a quilly or finny substance, consisting of several long, slender, and variously blended quills or wires, something resembling the veins of leaves. These are, as 'twere, the fins or quills which stiffen the whole area, and keep the other part distended, which is a very thin transparent skin or membrane, variously folded and plaited, but not very regularly, and is besides exceeding thickly bestuck with innumerable small bristles, which are only perceptible by a bigger magnifying microscope, and not with that neither, but with a very convenient augmentation of skylight projected on the object with a burning glass, as I have elsewhere showed, and by looking through it against the light. Instead of the small hairs in several other flies, there are infinite of small feathers, which cover both the under and upper sides of this thin film, as in almost all the sorts of butterflies and moths. And those small parts are not only shaped very much like the feathers of birds, but like those variegated with all the variety of curious, bright, and vivid colors imaginable. And those feathers are likewise so admirably and delicately ranged as to compose very fine flourishings and ornamental paintings, like Turkey and Persian carpets, but of far more surpassing beauty, as is evident enough to the naked eye, in the painted wings of butterflies, but much more through an ordinary microscope. Intermingled likewise with these hairs may be perceived multitudes of little pits or black spots in the extended membrane, which seem to be the root of the hairs that grow on the other side. These two bodies seem dispersed over the whole surface of the wing. The hairs are best perceived by looking through it against the light, or by laying the wing upon a very white piece of paper in a convenient light, for thereby every little hair most manifestly appears, a specimen of which you may observe drawn in the fourth figure of the 23 scheme, A, B, C, D, E, F, whereof represent some parts of the bones or quills of the wing, each of which you may perceive to be covered over with a multitude of scales or bristles. The former A, B is the biggest stem of all the wing, and may be properly enough called the cut air, it being that which terminates and stiffens the foremost edge of the wing. The foredge of this is armed with a multitude of little bristles, or tenter hooks, in some standing regular and in order, in others not, all the points of which are directed from the body towards the tip of the wing. Nor is this edge only thus fringed, but even all the whole edge of the wing is covered with a small fringe, consisting of short and more slender bristles. This subject, had I time, would afford excellent matter for the contemplation of the nature of wings and flying, but because I may perhaps get a more convenient time to prosecute that speculation, and recollect several observations that I have made of that particular, I shall at present proceed to. End of section 43. Recording by John Brandon.
Section 44 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke, Section 44. Observation 39. Of the eyes and head of a great dronefly, and of several other creatures. I took a large great dronefly that had a large head, but a small and slender body in proportion to it, and cutting off its head, I fixed it with the forepart or face upwards upon my object plate. This I made choice of rather than the head of a great blue fly, because my enquiry being now about the eyes, I found this fly to have, first, the biggest cluster of eyes in proportion to his head, of any small kind of flies that I have yet seen, it being somewhat inclining towards the make of the large dragonflies. Next, because there is a greater variety in the knobs or balls of each cluster than is of any small fly. Then examining it according to my usual manner, by varying the degrees of light, and altering its position to each kind of light, I drew that representation of it which is delineated in the 24th scheme, and found these things to be as plain and evident as notable and pleasant. First, that the greatest part of the face, nay, of the head, was nothing else but two large and protuberant bunches, or prominent parts, A, B, C, D, E, A, the surface of each of which was all covered over, or shaped into a multitude of small hemispheres, placed in a triagonal order, that being the closest and most compacted, and in that order ranged over the whole surface of the eye in very lovely rows, between each of which, as is necessary, were left long and regular trenches, the bottoms of every of which were perfectly entire, and not at all perforated or drilled through, which I most certainly was assured of by the regularly reflected image of certain objects which I moved to and fro between the head and the light. And by examining the cornea or outward skin, after I had stripped it off from the several substances that lay within it, and by looking both upon the inside and against the light. Next, that of those multitudes of hemispheres, there were observable 2 degrees of bigness, the half of them that were lowermost, and looked towards the ground, or their own legs, namely CDE, CDE being a pretty deal smaller than the other, namely ABCE. ABCE that looked upward and sideways or forright and backward, which variety I have not found in any other small fly. Thirdly, that every one of these hemispheres, as they seemed to be pretty near the true shape of a hemisphere, so was the surface exceeding smooth and regular, reflecting as exact regular and perfect an image of any object from the surface of them, as a small ball of quicksilver of that bigness would do, but nothing near so vivid, the reflection from these being very languid, much like the reflection from the outside of water, glass, crystal, etc., insomuch that in each of these hemispheres I have been able to discover a landscape of those things which lay before my window, one thing of which was a large tree, whose trunk and top I could plainly discover, as I could also the parts of my window and my hand and fingers, if I held it between the window and the object, a small draught of 19 of which, as they appeared in the bigger magnifying glass to reflect the image of the 2 windows of my chamber, are delineated in the figure 3 of the 23rd scheme. Fourthly, that these rows were so disposed that there was no quarter visible from his head that there was not some of these hemispheres directed against, so that a fly may be truly said to have an eye every way, and to be really circumspect. And it was further observable that that way where the trunk of his body did hinder his prospect backward, these protuberances were elevated, as it were, above the plane of his shoulders and back, so that he was able to see backwards, also over his back. Fifthly, in living flies, I have observed that when any small mote or dust, which flies up and down the air, chances to light upon any part of these knobs, as it is sure to stick firmly to it and not fall, though through the microscope it appears like a large stone or stick, which one would admire, especially since it is no ways probable that there is any wet or glutinous matter upon these hemispheres. But I hope I shall render the reason in another place. So the fly presently makes use of his 2 forefeet instead of eyelids, with which, as with 2 brooms or brushes, they being all bestuck with bristles, he often sweeps or brushes off whatever hinders the prospect of any of his hemispheres, and then, to free his legs from that dirt, he rubs them one against another, the pointed bristles or tenters of which looking both one way, the rubbing of them to and fro, one against another, does cleanse them in the same manner as I have observed those that card wool, to cleanse their cards by placing their cards so as the teeth of both look the same way, and then rubbing them one against another. In the very same manner do they brush and cleanse their bodies and wings, as I shall by and by show. Other creatures have other contrivances for the cleansing and clearing their eyes. Sixthly, that the number of the pearls or hemispheres in the clusters of this fly was near 14,000, which I judged by numbering certain rows of them several ways, and casting up the whole content, accounting each cluster to contain about 7,000 pearls, 3,000 of which were of a size, and consequently the rows not so thick, and the 4,000 I accounted to be the number of the smaller pearls, next the feet and proboscis. Other animals I observed to have yet a greater number, as the dragonfly or udderwort, and others to have a much less company, as an ant, etc., and several other small flies and insects. Seventhly, that the order of these eyes, or hemispheres, was altogether curious and admirable, they being placed in all kinds of flies and aerial animals in a most curious and regular ordination of triangular rows, in which order they are ranged the nearest together that possibly they can, and consequently leave the least pits or trenches between them. But in shrimps, crawfishes, lobsters, and such kinds of crustaceous water animals, I have yet observed them ranged in a quadrangular order, the rows cutting each other at right angles, which as it admits of a less number of pearls in equal surfaces, though have those creatures a recompense made them, by having their eyes a little movable in their heads, which the other altogether want. So infinitely wise and provident do we find all the dispensations in nature, that certainly Epicurus and his followers must very little have considered them, who ascribed those things to the production of chance, that will, to a more attentive considerer, appear the products of the highest wisdom and providence. Upon the anatomy or dissection of the head, I observed these particulars. First, that this outward skin, like the cornea of the eyes of the greater animals, was both flexible and transparent, and seemed, through the microscope, perfectly to resemble the very substance of the cornea of a man's eye. For having cut out the cluster and removed the dark and mucous stuff that is subjacent to it, I could see it transparent like a thin piece of skin, having as many cavities in the inside of it, and ranged in the same order as it had protuberances on the outside, and this propriety I found the same in all the animals that had it, whether flies or shellfish. Secondly, I found that all animals that I have observed with those kind of eyes have within this cornea a certain clear liquor or juice, though in a very little quantity. And I observed thirdly, that within that clear liquor they had a kind of dark mucous lining, which was all spread round within the cavity of the clutter, and seemed very near adjoining to it, the colour of which in some flies was grey, in others black, in others red, in others of a mixed colour, in others spotted, and that the whole clusters, when looked on whilst the animal was living, or but newly killed, appeared of the same colour that his coat, as I may so call it, appeared of, when that outward skin or cornea was removed. Fourthly, that the rest of the capacity of the clusters was in some, as in dragonflies, etc., hollow or empty, in others filled with some kind of substance, in blue flies with a reddish musculous substance, with fibres tending from the centre or bottom outwards, and divers other, with various and differing kinds of substances. That this curious contrivance is the organ of sight to all those various crustaceous animals which are furnished with it, I think we need not doubt, if we consider but the several congruities it has with the eyes of greater creatures. At first, that it is furnished with a cornea, with a transparent humour, and with a uvea or retina, that the figure of each of the small hemispheres are very spherical, exactly polished and most vivid, lively and plump, when the animal is living, as in greater animals, and in like manner dull, flaccid, and irregular, or shrunk, when the animal is dead. Next, that those creatures that are furnished with it have no other organs that have any resemblance to the known eyes of other creatures. Thirdly, that those which they call the eyes of crabs, lobsters, shrimps, and the like, and are really so, are hemisphered, almost in the same manner as those of flies are, and that they really are so, I have very often tried, by cutting off these little movable knobs, and putting the creature again into the water, that it would swim to and fro, and move up and down as well as before, but would often hit itself against the rocks or stones, and though I put my hand just before its head, it would not at all start or fly back till I touched it, whereas whilst those were remaining, it would start back, and avoid my hand or a stick at a good distance before it touched it. And if in crustaceous sea animals, then it seems very probable also that these knobs are the eyes in crustaceous insects, which are also of the same kind, only in a higher and more active element. This the conformity or congruity of many other parts common to either of them will strongly argue, their crustaceous armour, their number of legs, which are 6, besides the 2 great claws, which answer to the wings in insects, and in all kind of spiders, as also in many other insects that want wings, we shall find the complete number of them, and not only the number, but the very shape, figure, joints and claws of lobsters and crabs, as is evident by scorpions and spiders, as is visible in the second figure of the 31st scheme, and in the little mite-worm, which I call a land crab, described in the second figure of the 33rd scheme, but in their manner of generation being oviparous, etc. And it were very worthy observation whether there be not some kinds of transformation and metamorphosis in the several states of crustaceous water animals, as there is in several sorts of insects, for if such could be met with, the progress of the variations could be much more conspicuous in those larger animals than they can be in any kind of insects our colder climate affords. These being their eyes, it affords us a very pretty speculation to contemplate their manner of vision, which, as it is very differing from that of biocular animals, so is it not less admirable. That each of these pearls or hemispheres is a perfect eye, I think we need not doubt, if we consider only the outside or figure of any one of them, for they being each of them covered with a transparent protuberant cornea, and containing a liquor within them, resembling the watery or glassy humours of the eye, must necessarily refract all the parallel rays that fall on them out of the air into a point not far distant within them, where, in all probability, the retina of the eye is placed, and that opacious, dark, and mucous inward coat that I formerly showed, I found to subtend the concave part of the cluster, is very likely to be that tunicle or coat, it appearing through the microscope to be placed a little more than a diameter of those pearls below or within the tunica cornea. And if so, then is there in all probability a little picture or image of the objects without, painted or made at the bottom of the retina against every one of those pearls, so that there are as many impressions on the retina or opacous skin as there are pearls or hemispheres on the cluster. But because it is impossible for any protuberant surface whatsoever, whether spherical or other, so to refract the rays that come from far remote lateral points of any object, as to collect them again, and unite them each in a distinct point, and that only those rays which come from some point that lies in the axis of the figure produced are so accurately refracted to one and the same point again, and that the lateral rays, the further they are removed, the more imperfect is their refracted confluence. It follows, therefore, that only the picture of those parts of the external objects that lie in or near the axis of each hemisphere are discernibly painted or made on the retina of each hemisphere, and that therefore each of them can distinctly sensate or see only those parts which are very near perpendicularly opposed to it, or lie in or near its optic axis. Now, through there may be by each of those eye pearls a representation to the animal of a whole hemisphere, in the same manner as in a man's eye there is a picture or sensation in the retina of all the objects lying almost in a hemisphere. Yet, as in a man's eye also, there are but some very few points which, lying in or near the optic axis, are distinctly discerned. So there may be multitudes of pictures made of one object in the several pearls, and yet but one, or some very few that are distinct. The representation of any object that is made in any other pearl, but that which is directly or very near directly opposed, being altogether confused, and unable to produce a distinct vision. So that we see that though it has pleased the all-wise Creator to endue this creature with such multitudes of eyes, yet has he not endued it with the faculty of seeing more than other creature. For whereas this cannot move his head, at least can move it very little, without moving his whole body, biocular creatures can, in an instant, or the twinkling of an eye, which being very quick, is vulgarly used in the same signification, move their eyes so as to direct the optic axis to any point, nor is it probable that they are able to see attentively at one time more than one physical point. For though there be a distinct image made in every eye, yet it is very likely that the observing faculty is only employed about some one object for which they have most concern. Now, as we accurately distinguish the sight or position of an object by the motion of the muscles of the eye requisite to put the optic line in a direct position, and confusedly by the position of the imperfect picture of the object at the bottom of the eye, so are these crustaceous creatures able to judge confusedly of the position of objects by the picture or impression made at the bottom of the opposite pearl, and distinctly by the removal of the attentive or observing faculty from one pearl to another. But what this faculty is, as it requires another place, so a much deeper speculation. Now, because it were impossible, even with this multitude of eyeballs, to see any object distinct, for as I hinted before, only those parts that lay in, or very near, the optic lines could be so, the infinitely wise Creator has not left the creature without the power of moving the head a little in aerial crustaceous animals, and the very eyes also in crustaceous sea animals, so that by these means they are enabled to direct some optic line or other against any object, and by that means they have the visive faculty as complete as any animal that can move its eyes. Distances of objects also, it is very likely, they distinguish, partly by the consonant impressions made in some two convenient pearls, one in each cluster, for, according as those congruous impressions affect, through pearls nearer approach to each other, the nearer is the object, and the farther they are distant, the more distant is the object, partly also by the alteration of each pearl requisite to make the sensation or picture perfect, for it is impossible that the pictures of two objects variously distant can be perfectly painted or made on the same retina or bottom of the eye not altered, as will be very evident to any one that shall attentively consider the nature of refraction. Now, whether this alteration may be in the figure of the cornea, in the motion of access or recess of the retina towards the cornea, or in the alteration of a crystalline humour, if such there be, I pretend not to determine, though I think we need not doubt, but that there may be as much curiosity of contrivance and structure in every one of those pearls as in the eye of a whale or elephant, and the Almighty's fiat could as easily cause the existence of the one as the other. And as 1 day and 1,000 years are the same with him, so may 1 eye and 10,000. This we may be sure of, that the filaments or sensitive parts of the retina must be most exceedingly curious and minute, since the whole picture itself is such. What must needs the component parts be of that retina, which distinguishes the part of an object's picture, that must be many millions of millions less than that in a man's eye? And how exceeding curious and subtile must the component parts of the medium that conveys light be, when we find the instrument made for its reception or refraction to be so exceedingly small? We may, I think, from this speculation be sufficiently discouraged from hoping to discover, by any optic or other instrument, the determinate bulk of the parts of the medium that conveys the pulse of light, since we find that there is not less accurateness shown in the figure and polish of those exceedingly minute lenticular surfaces than in those more large and conspicuous surfaces of our own eyes. And yet can I not doubt but that there is a determinate bulk of those parts, since I find them unable to enter between the parts of Mercury, which being in motion must necessarily have pores, as I shall elsewhere show, and here pass by as being a digression. As concerning the horns, FF, the feelers or smellers, GG, the proboscis, HH, and I, the hairs and bristles, KK, I shall endeavour to describe in the observation 42. End of chapter 44.
Section 45 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Devorah Allen. Micrographia by Robert Hooke. Section 45. Observation 40. Of the teeth of a snail. I have little more to add of the teeth of a snail, besides the picture of it, which is represented in the first figure of the 25th scheme, save that his bended body, A, B, C, D, E, F, which seemed fashioned very much like a row of small teeth, orderly placed in the gums, and looks as if it were divided into several smaller and greater black teeth, was nothing but one small, bended, hard bone, which was placed in the upper jaw of the mouth of a house snail, with which I observed this very snail to feed on the leaves of a rose-tree, and to bite out pretty large and half-round bits, not unlike the figure of a C, nor very much differing from it in bigness. The upper part, A, B, C, D, of this bone, I found to be much whiter, and to grow out of the upper chap of the snail, G, 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 and not to be anything near so much creased as the lower and blacker part of it, H, I, H, K, K, H, which was exactly shaped like teeth, the bone growing thinner, or tapering to an edge towards K, K, K. It seemed to have 9 teeth, or prominent parts, IK, IK, IF, etc., which were joined together by the thinner interposed parts of the bone. The animal to which these teeth belong is a very anomalous creature, and seems of a kind quite distinct from any other terrestrial animal or insect, the anatomy whereof exceedingly different from what has been hitherto given of it, I should have inserted, but that it will be more proper in another place. I have never met with any kind of animal whose teeth are all joined in one, save only that I lately observed that all the teeth of a rhinoceros, which grow on either side of its mouth, are joined into one large bone, the weight of one of which I found to be near 11 pound avoirdupois, so that it seems one of the biggest sort of terrestrial animals, as well as one of the smallest, has his teeth thus shaped. End of section 45.
Section 46 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Observation 41. Of the eggs of silkworms and other insects. The eggs of silkworms, one of which I have described in the second figure of the 25th scheme, afford a pretty object for a microscope that magnifies very much, especially if it be bright weather and the light of a window be cast or collected on it by a deep convex glass or water ball. For then the whole surface of the shell may be perceived all covered over with exceeding small pits or cavities, with interposed edges almost in the manner of the surface of a poppy seed. But that these holes are not an hundredth part scarce of their bigness, the shell, when the young ones were hatched, which I found an easy thing to do if the eggs were kept in a warm place, appeared no thicker in proportion to its bulk than that of an hen's or goose's egg is to its bulk, and all the shell appeared very white, which seemed to proceed from its transparency, whence all those pittings did almost vanish, so that they could not, without much difficulty, be discerned. The inside of the shell seemed to be lined also with a kind of thin film, not unlike, keeping the proportion to its shell, that with which the shell of an hen egg is lined. And the shell itself seemed like common egg shells, very brittle and cracked. In divers others of these eggs I could plainly enough, through the shell, perceive the small insect lie coyly round the edges of the shell. The shape of the egg itself the figure pretty well represents, though by default of the graver it does not appear so rounded and lying above the paper, as it were, as it ought to do. That is, it was for the most part pretty oval endways, somewhat like an egg, but the other way it was a little flatted on two opposite sides. Divers of these eggs, as is common to most others, I found to be barren or addle, for they never afforded any young ones, and those I usually found much whiter than the other that were prolific. The eggs of other kinds of oviparous insects I have found to be perfectly round every way. Like so many globules of this sort I have observed some sorts of spiders' eggs, and chancing the last summer to enclose a very large and curiously painted butterfly in a box, intending to examine its gaudery with my microscope, I found within a day or two after I enclosed her almost all the inner surface of the box covered over with an infinite of exactly round eggs, which were stuck very fast to the sides of it, and in so exactly regular and close an order, that made me call to mind my hypothesis, which I had formerly thought on for the making out of all the regular figures of salt, which I have elsewhere hinted. For here I found all of them ranged into a most exact triagonal order, much after the manner as the hemispheres are placed on the eye of a fly, all which eggs I found after a little time to be hatched, and out of them to come a multitude of small worms very much resembling young silkworms, leaving all their thin hollow shells behind them, sticking on the box in their triagonal posture. These I found with the microscope to have much such a substance as the silkworm's eggs, but could not perceive them pitted. And indeed there is as great a variety in the shape of the eggs of oviparous insects as among those of birds. Of these eggs a large and lusty fly will at one time lay near 400 or 500, so that the increase of these kind of insects must needs be very prodigious, were they not preyed on by multitudes of birds and destroyed by frosts and rains. Hence 'tis those hotter climates between the tropics are infested with such multitudes of locusts and such other vermin. End of section 46. Recording by Philip Gould. Section 47 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Observation 42. Of a blue fly. This kind of fly, whereof a microscopical picture is delineated in the first figure of the 26th scheme, is a very beautiful creature, and has many things about it very notable, divers of which I have already partly described, namely, the feet, wings, eyes, and head, in the preceding observations. And though the head before described be that of a grey drone fly, yet for the main it is very agreeable to this. The things wherein they differ most will be easily enough found by the following particulars. First, the clusters of eyes of this fly are very much smaller than those of the drone fly in proportion to the head. And next, all the eyes of each cluster seem much of the same bigness one with another, not differing as the other, but ranged in the same triagonal order. Thirdly, between these two clusters there was a scaly prominent front B, which was armed and adorned with large tapering sharp black bristles, which growing out in rows on either side were so bent toward each other near the top, as to make a kind of arched arbor of bristles, which almost covered the former front. Fourthly, at the end of this arch about the middle of the face, on a prominent part C, grew two small oblong bodies DD, which through a microscope looked not unlike the pendants in lilies. These seemed to be jointed onto two small parts at C, each of which seemed again jointed into the front. Fifthly, out of the upper part and outside of these horns, as I may call them from the figure they are of in the 24th scheme, where they are marked with FF, there grows a single feather, or brushy bristle, EE, somewhat of the same kind with the tufts of a gnat, which I have before described. What the use of these kind of horned and tufted bodies should be I cannot well imagine, unless they serve for smelling or hearing, though how they are adapted for either it seems very difficult to describe. They are in almost every several kind of flies of so various a shape, though certainly they are some very essential part of the head, and have some very notable office assigned them by nature, since in all insects they are to be found in one or another form. Sixthly, at the under part of the face FF were several of the former sort of bended bristles, and below all the mouth, out of the middle of which grew the proboscis GHI, which, by means of several joints whereof it seemed to consist, the fly was able to move to and fro, and thrust it in and out as it pleased. The end of this hollow body, which was all over covered with small short hairs or bristles, was, as 'twere, bended H, and the outer or foremost side of the bended part HI slit, as it were, into two chaps, HI, HI, all the outside of which were covered with hairs and pretty large bristles. These he could, like two chaps, very readily open and shut, and when he seemed to suck anything from the surface of a body, he would spread abroad these chaps and apply the hollow part of them very close to it. From either side of the proboscis within the mouth grew two other small horns or fingers, KK, which were hairy, but small in this figure, but of another shape and bigger in proportion in the 24th scheme, where they are marked with GG, which two indeed seemed a kind of smellers, but whether so or not I cannot positively determine. The thorax or middle part of this fly was cased, both above and beneath, with a very firm crust of armor, the upper part more round and covered over with long conical bristles, all whose ends pointed backwards. Out of the hinder and under part of this grew out in a cluster 6 legs, 3 of which are apparent in the figure. The other 3 were hid by the body placed in that posture. The legs were all much of the same make, being all of them covered with a strong hairy scale or shell, just like the legs of a crab or lobster, and the contrivance of the joints seemed much the same. Each leg seemed made up of 8 parts, 1, 2, 3, 4, 5, 6, 7, 8, to the 8th or last of which grew the soles and claws described before in the 38th observation. Out of the upper part of this trunk grew the 2 wings, which I mentioned in the 38th observation, consisting of a film extended on certain small stiff wires or bones. These in a blue fly were much longer than the body, but in other kind of flies they are of very differing proportions to the body. These films in many flies were so thin that, like several other plated bodies mentioned in the 9th observation, they afforded all varieties of fantastical or transient colors, the reason of which I have here endeavored to explain. They seemed to receive their nourishment from the stalks or wires, which seemed to be hollow, and near the upper part of the wing LL, several of them seemed jointed, the shape of which will sufficiently appear by the black lines in the second figure of the 26th scheme, which is a delineation of one of those wings expanded directly to the eyes. All the hinder part of its body is covered with a most curious blue shining armor, looking exactly like a polished piece of steel brought to that blue color by annealing, all which armor is very thick, bestuck with abundance of tapering bristles such as grow on its back, as is visible enough by the figure. Nor was the inside of this creature less beautiful than its outside, for cutting off a part of the belly and then viewing it to see if I could discover any vessels, such as are to be found in greater animals and even in snails exceedingly manifestly, I found, much beyond my expectation, that there were abundance of branchings of milk-white vessels, no less curious than the branchings of veins and arteries in bigger terrestrial animals, in one of which I found two notable branches joining their two main stalks, as it were, into one common ductus. Now to what veins or arteries these vessels were analogous, whether to the vena porta or the mesaraic vessels, or the like, or indeed whether they were veins and arteries, or vasa lactea properly so called, I am not hitherto able to determine, having not yet made sufficient inquiry. But in all particulars there seems not to be anything less of curious contrivance in these insects than in those larger terrestrial animals, for I had never seen any more curious branchings of vessels than those I observed in 2 or 3 of these flies thus opened. It is a creature active and nimble, so as there are few creatures like it, whether bigger or smaller, insomuch that it will scape and avoid a small body, though coming on it exceedingly swiftly, and if it sees anything approaching it which it fears, it presently squats down, as it were, that it may be the more ready for its rise. Nor is it less hardy in the winter than active in the summer, enduring all the frosts and surviving till the next summer, notwithstanding the bitter cold of our climate. Nay, this creature will endure to be frozen, and yet not be destroyed, for I have taken one of them out of the snow whereon it had been frozen almost white, with the ice about it, and yet by thawing it gently by the warmth of a fire, it has quickly revived and flown about. This kind of fly seems by the steams or taste of fermenting and putrefying meat, which it often kisses as 'twere, with its proboscis as it trips over it, to be stimulated or excited to eject its eggs or seed on it, perhaps from the same reason as dogs, cats, and many other brute creatures are excited to their particular lusts by the smell of their females, when by nature prepared for generation, the males seeming by those kind of smells, or other incitations, to be as much necessitated thereto as aqua regus strongly impregnated with a solution of gold is forced to precipitate it by the effusion of spirit of urine, or a solution of salt of tartar. One of these put in spirit of wine was very quickly seemingly killed, and both its eyes and mouth began to look very red. But upon the taking of it out, and suffering it to lie 3 or 4 hours, and heating it with the sunbeams cast through a burning glass, it again revived, seeming as it were to have been all the intermediate time but dead drunk, and after certain hours to grow fresh again and sober. End of section 47. Recording by DrPGould. Section 48 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information, or to volunteer, please visit LibriVox.org. Micrographia by Robert Hooke. Observation 43. Of the water insect, or gnat. This little creature, described in the first figure of the 27th scheme, was a small scaled or crusted animal, which I have often observed to be generated in rainwater. I have also observed it both in pond and river water. It is supposed by some to deduce its first original from the putrefaction of rainwater, in which, if it have stood any time open to the air, you shall seldom miss, all the summer long, of store of them frisking to and fro. 'Tis a creature wholly differing in shape from any I ever observed, nor is its motion less strange. It has a very large head in proportion to its body, all covered with a shell, like other testaceous animals, but it differs in this, that it has, up and down several parts of it, several tufts of hairs or bristles, placed in the order expressed in the figure. It has 2 horns, which seemed almost like the horns of an ox, inverted, and as near as I could guess were hollow, with tufts of bristles likewise at the top. These horns they could move easily this or that way, and might perchance be their nostrils. It has a pretty large mouth, which seemed contrived much like those of crabs and lobsters, by which I have often observed them to feed on water or some imperceptible nutritive substance in it. I could perceive through the transparent shell, while the animal survived, several motions in the head, thorax, and belly, very distinctly, of differing kinds, which I may perhaps elsewhere endeavor more accurately to examine, and to show of how great benefit the use of a microscope may be for the discovery of nature's course in the operations performed in animal bodies, by which we have the opportunity of observing her through these delicate and pellucid teguments of the bodies of insects, acting according to her usual course and way undisturbed. Whereas when we endeavor to pry into her secrets by breaking open the doors upon her, and dissecting and mangling creatures whilst there is life yet within them, we find her indeed at work, but put into such disorder by the violence offered, as it may easily be imagined how differing a thing we should find if we could, as we can with a microscope in these smaller creatures, quietly peep in at the windows without frightening her out of her usual bias. The form of the whole creature as it appeared in the microscope may, without troubling you with more descriptions, be plainly enough perceived by the scheme, the hinder part or belly consisting of 8 several jointed parts, namely A, B, C, D, E, F, G, H, of the first figure, from the midst of each of which on either side issued out 3 or 4 small bristles or hairs, I. The tail was divided into 2 parts of very differing make, one of them, namely K, having many tufts of hair or bristles, which seemed to serve both for the fins and tail, for the oars and rudder of this little creature, wherewith it was able, by frisking and bending its body nimbly to and fro, to move himself any whither, and to scull and steer himself as he pleased. The other part, L, seemed to be, as 'twere, the 9th division of his belly, and had many single bristles on either side. From the end V, of which through the whole belly there was a kind of gut of a darker colour, MMM, wherein, by certain peristaltic motions, there was a kind of black substance moved upwards and downwards through it, from the orbicular part of it N, which seemed the ventricle, or stomach, to the tail V, and so back again, which peristaltic motion I have observed also in a louse, a gnat, and several other kinds of transparent-bodied flies. The thorax, or chest of this creature, O, was thick and short, and pretty transparent, for through it I could see the white heart, which is the colour also of the blood in these, and most other insects, to beat, and several other kind of motions. It was bestuck and adorned up and down with several tufts of bristles, such as are pointed out by PP. The head Q was likewise bestuck with several of those tufts, SSS. It was broad and short, had 2 black eyes, TT, which I could not perceive at all pearled, as they afterwards appeared, and 2 small horns, RR, such as I formerly described. Both its motion and rest is very strange and pleasant, and differing from those of most other creatures I have observed, for where it ceases from moving its body, the tail of it seeming much lighter than the rest of its body, and a little lighter than the water it swims in, presently buoys it up to the top of the water, where it hangs suspended with the head always downward, and like our antipodes, if they do by a frisk get below that superficies, they presently ascend again unto it, if they cease moving, until they tread, as it were, under that superficies with their tails. The hanging of these in this posture put me in mind of a certain creature I have seen in London, that was brought out of America, which would very firmly suspend itself by the tail with the head downwards, and was said to keep in that posture with her young ones in her false belly, which is a purse, provided by nature for the production, nutrition, and preservation of her young ones, which is described by Piso in the 24th chapter of the 5th book of his Natural History of Brazil. The motion of it was with the tail forwards, drawing itself backwards by the striking to and fro of that tuft which grew out of one of the stumps of its tail. It had another motion which was more suitable to that of other creatures, and that is with the head forward. For by moving of his chaps, if I may so call the parts of his mouth, it was able to move itself downwards very gently towards the bottom, and did, as 'twere, eat up its way through the water. But that which was most observable in this creature was its metamorphosis or change. For having kept several of these animals in a glass of rainwater in which they were produced, I found after about a fortnight or 3 weeks' keeping, that several of them flew away in gnats, leaving their husks behind them in the water, floating under the surface, the place where these animals were wont to reside, whilst they were inhabitants of the water. This made me more diligently watch them to see if I could find them at the time of their transformation, and not long afterwards I observed several of them to be changed into an unusual shape, wholly differing from that they were of before, their head and body being grown much bigger and deeper, but not broader, and their belly or hinder parts smaller, and coiled about this great body, much of the fashion represented by the pricked line in the second figure of the 27th scheme. The head and horns now swam uppermost, and the whole bulk of the body seemed to be grown much lighter. For when by my frightening of it would by frisking out of its tail, in the manner expressed in the figure by B.C., sink itself below the surface towards the bottom, the body would more swiftly reascend than when it was in its former shape. I still marked its progress from time to time, and found its body still to grow bigger and bigger, nature, as it were, fitting and accoutring it for the lighter element of which it was now going to be an inhabitant. For by my observing one of these with my microscope, I found the eyes of it to be altogether differing from what they seemed before, appearing now all over pearled or knobbed like the eyes of gnats, as is visible in the second figure by A. At length I saw part of this creature to swim above and part beneath the surface of the water, below which, though it would quickly plunge itself if I by any means frighted it, and presently reascend into its former posture, after a little longer expectation I found that the head and body of a gnat began to appear, and stand clear above the surface, and by degrees it drew out its legs, first the 2 foremost, then the other. At length its whole body perfect and entire appeared out of the husk, which it left in the water, standing on its legs upon the top of the water, and by degrees it began to move, and after flew about the glass, a perfect gnat. I have been the more particular and large in the relation of the transformation of divers of these little animals which I observed, because I have not found that any author has observed the like, and because the thing itself is so strange and heterogeneous from the usual progress of other animals, that I judge it may not only be pleasant, but very useful and necessary towards the completing of natural history. There is indeed in Piso a very odd history, which this relation may make the more probable, and that is in the 2nd chapter of the 4th book of his Natural History of Brazil, where he says, Porul praetor, tot documenta fertilitatis circa vegetabilia e sensitiva marina telluris emula, accedit e illud, quod pacus aparanambucensi miliaribus piscatoris uncum citra intentionem contagat in figi vadis petrosis, e loco pisi spongia, coralla, aliasque arbusculus marinus capi. Inter haec inusitate, forme prodit spongiosa arbuscula, sesquipedis longitudinus, brevioribus, radicibus, lapideus, nitens vadis, e rupidus infixa, erigiturque in corpus spongiosum, mole oblongum, rotundum, turbinatum, intismiris cancellus e alves fabricatum, extisatum tenaci glutine instar opum propolis, undique vestitum, osteosatis patulo e profundo insumitate relicto, sicut ex altera iconum probe depicta videre licet. See the 3rd and 4th figures of the 27th scheme. Ita ut apiarium marinum veridixeris, primo enim intuitu et mare ad terram dilatum, vermiculus catabat caruleus parvus, qui moxacalere solis in muscas, vel apis potius esc, exiguus e nigris transformabantur, circumvolantesque evanescebant, ita ut de eorum maleficatione nihil certi conspici datum fuerit, cum tamen que rosa materia propolis apumque cellae manifeste apparerant, atque ipsa melis qualis cunque, substantia proculdubio urinatoribus patabit, ubi curiosius inquisiverant haec apiaria, iaque in natale solo e salo diversus temporibus penitius lustrarent. Which history contains things sufficiently strange to be considered, as whether the husk were a plant growing at the bottom of the sea before of itself, out of whose putrefaction might be generated these strange kinds of maggots, or whether the seed of certain bees sinking to the bottom might there naturally form itself that vegetable hive and take root, or whether it might not be placed there by some diving fly, or whether it might not be some peculiar propriety of that plant whereby it might ripen or form its vegetable juice into an animal substance, or whether it may not be of the nature of a sponge, or rather a sponge of the nature of this, according to some of those relations and conjectures I formerly made of that body, is a matter very difficult to be determined. But indeed in this description the excellent Piso has not been sufficiently particular in setting down the whole process as it were to be wished. There are indeed very odd progresses in the production of several kinds of insects, which are not less instructive than pleasant, several of which the diligent Godartius has carefully observed and recorded, but among all his observations he has none like this, though of the Hemorrhobius be somewhat of this kind, which is added as an appendix by Johannes May. I have for my own particular, besides several of those mentioned by him, observed divers other circumstances, perhaps not much taken notice of, though very common, which do indeed afford us a very coercive argument to admire the goodness and providence of the infinitely wise Creator in his most excellent contrivances and dispensations. I have observed at several times of the summer that many of the leaves of divers plants have been spotted, or as it were scabbed, and looking on the undersides of those of them that have been but a little irregular, I have perceived them to be sprinkled with divers sorts of little eggs, which letting alone I have found by degrees to grow bigger, and become little worms with legs, but still to keep their former places, and those places of the leaves, of their own accords, to be grown very protuberant upwards, and very hollow, and arched underneath, whereby these young creatures are, as it were, sheltered and housed from external injury. Divers leaves I have observed to grow and swell so far as at length perfectly to enclose the animal, which by other observations I have made I guess to contain it, and become, as it were, a womb to it, so long till it be fit and prepared to be translated into another state, at what time, like what they say of vipers, they gnaw their way through the womb that bred them. Divers of these kinds I have met with upon gooseberry leaves, rose-tree leaves, willow leaves, and many other kinds. There are often to be found upon rose-trees and briar bushes little red tufts, which are certain knobs or excrescencies growing out from the rind or barks of those kind of plants. They are covered with strange kinds of threads or red hairs, which feel very soft and look not unpleasantly. In most of these, if it has no hole in it, you shall find certain little worms, which I suppose to be the causes of their production, for when that worm has eaten its way through, they having performed what they were designed by nature to do, by degrees die and wither away. Now the manner of their production I suppose to be thus, that the all-wise Creator has well implanted in every creature a faculty of knowing what place is convenient for the hatching, nutrition, and preservation of their eggs and of springs, whereby they are stimulated and directed to convenient places, which become, as 'twere, the wombs that perform these offices. As he has also suited and adapted a property to those places whereby they grow and enclose those seeds, and having enclosed them provided convenient nourishment for them, but as soon as they have done the office of a womb, they die and wither. The progress of enclosure I have often observed in leaves, which in those places where those seeds have been cast have by degrees swelled and enclosed them so perfectly round as not to leave any perceptible passage out. From this same cause, I suppose, the galls, oak apples, and several other productions of that kind, upon the branches and leaves of trees, have their original. For if you open any of them when almost ripe, you shall find a little worm in them. Thus, if you open never so many dry galls, you shall find either a hole whereby the worm has eat its passage out, or if you find no passage, you may by breaking or cutting the gall find in the middle of it a small cavity, and in it a small body, which does plainly enough yet retain a shape, to manifest it once to have been a worm, though it died by a too early reparation from the oak on which it grew, its navel string, as 'twere, being broken off from the leaf or branch by which the globular body that enveloped it received its nourishment from the oak. And indeed, if we consider the great care of the Creator in the dispensations of his providences for the propagation and increase of the race, not only of all kind of animals, but even of vegetables, we cannot choose but admire and adore him for his excellencies. But we shall leave off to admire the creature or to wonder at the strange kind of acting in several animals, which seem to favor so much of reason, it seeming to me most manifest that those are but actings according to their structures, and such operations as such bodies, so composed, must necessarily, when there are such and such circumstances concurring, perform. Thus, when we find flies swarming about any piece of flesh that does begin a little to ferment, butterflies about colworts and several other leaves, which will serve to hatch and nourish their young, gnats and several other flies about the waters and marshy places, or any other creatures seeking and placing their seeds in convenient repositories, we may, if we attentively consider and examine it, find that there are circumstances sufficient, upon the supposals of the excellent contrivance of their machine, to excite and force them to act after such or such a manner. Those steams that rise from these several places may perhaps set several parts of these little animals at work, even as in the contrivance of killing a fox or wolf with a gun. The moving of a string is the death of the animal, for the beast, by moving the flesh that is laid to entrap him, pulls the string which moves the trigger, and lets go the cock which on the steel strikes certain sparks of fire which kindle the powder in the pan, and that presently flies into the barrel, where the powder catching fire rarefies and drives out the bullet, which kills the animal. In all which actions there is nothing of intention or ratiocination to be ascribed either to the animal or engine, but all to the ingeniousness of the contriver. But to return to the more immediate consideration of our gnat, we have in it an instance not usual or common of a very strange amphibious creature, that being a creature that inhabits the air does yet produce a creature that for some time lives in the water as a fish, though afterward, which is as strange, it becomes an inhabitant of the air like its sire, in the form of a fly. And this, methinks, does prompt me to propose certain conjectures as queries, having not yet had sufficient opportunity and leisure to answer them myself from my own experiments or observations. And the first is, whether all those things that we suppose to be bred from corruption and putrefaction may not be rationally supposed to have their origination as natural as these gnats, who 'tis very probable were first dropped into this water in the form of eggs. Those seeds or eggs must certainly be very small, which so small a creature as a gnat yields, and therefore we need not wonder that we find not the eggs themselves, some of the younger of them which I have observed having not exceeded a 10th part of the bulk they have afterwards come to. And next I have observed some of those little ones which must have been generated after the water was enclosed in the bottle, and therefore most probably from eggs, whereas those creatures have been supposed to be bred of the corruption of the water, there being not formerly known any probable way how they should be generated. A second is, whether these eggs are immediately dropped into the water by the gnats themselves, or immediately are brought down by the falling rain. For it seems not very improbable but that those small seeds of gnats may, being perhaps of so light a nature, and having so great a proportion of surface to so small a bulk of body, be ejected into the air, and so perhaps carried for a good while to and fro in it, till by the drops of rain it be washed out of it. A third is, whether multitudes of those other little creatures that are found to inhabit the water for some time, do not at certain times take wing and fly into the air. Others dive and hide themselves in the earth, and so contribute to the increase both of the one and the other element. Postscript. A good while since the writing of this description, I was presented by Dr. Peter Ball, an ingenious member of the Royal Society, with a little paper of nuts, which he told me was sent him from a brother of his out in the country, from Mamhead in Devonshire. Some of them were loose, having been, as I suppose, broken off. Others were still growing fast upon the sides of a stick, which seemed by the bark, pliableness of it, and by certain strings that grew out of it, to be some piece of the root of a tree. They were all of them dried and a little shriveled, others more round, of a brown color. Their shape was much like a fig, but very much smaller, some being about the bigness of a bayberry, others, and the biggest, of a hazelnut. Some of these that had no hole in them I carefully opened with my knife, and found in them a good large round white maggot, almost as big as a small pea, which seemed shaped like other maggots, but shorter. I could not find them to move, though I guessed them to be alive, because upon pricking them with a pin there would issue out a great deal of white mucous matter, which seemed to be from a voluntary contraction of their skin. Their husk or matrix consisted of 3 coats, like the barks of trees, the outermost being more rough and spongy, and the thickest, the middlemost more close, hard, white, and thin, the innermost very thin, seeming almost like the skin within an eggshell. The 2 outermost had root in the branch or stick, but the innermost had no stem or process, but was only a skin that covered the cavity of the nut. All the nuts that had no holes eaten in them I found to contain these maggots, but all that had holes I found empty, the maggots, it seems, having eaten their way through, taken wings, and flown away, as this following account, which I received in writing from the same person, as it was sent him by his brother, manifests. In a moorish black peaty mould, with some small veins of whitish yellow sands, upon occasion of digging a hole 2 or 3 foot deep, at the head of a pond or pool, to set a tree in, at that depth were found, about the end of October 1663, in those very veins of sand, those buttons or nuts sticking to a little loose stick, that is, not belonging to any live tree, and some of them also free by themselves. 4 or 5 of which being then opened, some were found to contain live insects come to perfection, most like to flying ants, if not the same. In others insects, yet imperfect, having but the head and wings formed, the rest remaining a soft, white, pulpy substance. Now as this furnishes us with one odd history more, very agreeable to what I before hinted, so I doubt not but were men diligent observers, they might meet with multitudes of the same kind, both in the earth and in the water and in the air, on trees, plants, and other vegetables, all places and things being, as it were, animarum plena. And I have often, with wonder and pleasure, in the spring and summer time, looked close to and diligently on common garden mould, and in a very small parcel of it found such multitudes and diversities of little reptiles, some in husks, others only creepers, many winged and ready for the air, divers husks or habitations left behind empty. Now if the earth of our cold climate be so fertile of animate bodies, what may we think of the fat earth of hotter climates? Certainly the sun may there, by its activity, cause as great a parcel of earth to fly on wings in the air, as it does of water in steams and vapors. And what swarms must we suppose to be sent out of those plentiful inundations of water which are poured down by the sluices of rain in such vast quantities? So that we need not much wonder at those innumerable clouds of locusts with which Africa and other hot countries are so pestered, since in those places are found all the convenient causes of their production, namely genitors or parents, concurrent receptacles or matrixes, and a sufficient degree of natural heat and moisture. I was going to annex a little draft of the figure of those nuts sent out of Devonshire, but chancing to examine Mr. Parkinson's herbal for something else, and particularly about galls and oak apples, I found among no less than 24 several kinds of excrescences of the oak, which I doubt not, but upon examination will all be found to be the matrixes of so many several kinds of insects, I having observed many of them myself to be so among 24 several kinds, I say. I found one described and figured directly like that which I had by me. The scheme is there to be seen, the description, because but short, I have here adjoined. Teatri Botanici DrPGould, Chapter 2. There groweth at the roots of old oaks in the springtime, and sometimes also in the very heat of summer, a peculiar kind of mushroom or excrescence, called uva quercina, swelling out of the earth, many growing one close unto another of the fashion of a grape, and therefore took the name the oak grape, and is of a purplish colour on the outside, and white within like milk, and in the end of summer becometh hard and woody. Whether this be the very same kind I cannot affirm, but both the picture and description come very near to that I have, but that he seems not to take notice of the hollowness or worm, for which 'tis most observable. And therefore 'tis very likely, if men did but take notice, they might find very many differing species of these nuts, ovaries, or matrixes, and all of them to have much the same designation and office. And I have very lately found several kinds of excrescences on trees and shrubs, which having endured the winter, upon opening them, I found most of them to contain little worms, but dead, those things that contained them being withered and dry. End of section 48. Recording by Philip Gould.
Section 49 of Micrographia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by deongines, Salt Lake City, Utah. Micrographia by Robert Hooke. Section 49. Observation 44 of the tufted or brush-horned gnat. This little creature was one of those multitudes that fill our English air all the time that warm weather lasts, and is exactly of the shape of that I observed to be generated and hatched out of those little insects that wriggle up and down in rainwater. But though many were of this form, yet I observed others to be of quite other kinds, nor were all of this or the other kind generated out of water insects. For whereas I observed that those that proceeded from those insects were at their full growth, I have also found multitudes of the same shape, but much smaller and tenderer seeming to be very young ones, creep up and down upon the leaves of trees, and flying up and down in small clusters in places very remote from water. And this spring I observed one day, when the wind was very calm, and the afternoon very fair and pretty warm, though it had for a long time been very cold weather, and the wind continued still in the east, several small swarms of them playing to and fro in little clouds in the sun, each of which were not a 10th part of the bigness of one of these I here have delineated, though very much of the same shape, which makes me guess that each of these swarms might be the offspring of one only gnat, which had been hoarded up in some safe repository all this winter by some provident parent, and were now, by the warmth of this spring air, hatched into little flies. And indeed, so various and seemingly irregular are the generations or productions of insects, that he that shall carefully and diligently observe the several methods of nature therein will have infinitely cause further to admire the wisdom and providence of the Creator. For not only the same kind of creature may be produced from several kinds of ways, but the very same creature may produce several kinds. For as diverse watches may be made out of several materials, which may yet have all the same appearance, and move after the same manner, that is, show the hour equally true, the one as the other, and out of the same kind of matter, like watches, may be wrought differing ways, and as one and the same watch may, by being diversely agitated or moved by this or that agent, or after this or that manner, produce a quite contrary effect, So may it be with these most curious engines of insects' bodies. The all-wise God of nature may have so ordered and disposed the little automatons that when nourished, acted, or enlivened by this cause, they produce one kind of effect, or animate shape, when by another they act quite another way, and another animal is produced. So may he so order several materials as to make them, by several kinds of methods, produce similar automatons. But to come to the description of this insect as it appears through a microscope, of which a representation is made in the 28th scheme. Its head A is exceeding small in proportion to its body, consisting of 2 clusters of pearled eyes, BB, on each side of its head, whose pearls or eyeballs are curiously ranged like those of other flies. Between these, in the forehead of it, there are placed upon 2 small black balls, CC, 2 long jointed horns, tapering towards the top, much resembling the long horns of lobsters, each of whose stems or quills, DD, were bristled or brushed with multitudes of small stiff hairs, issuing out every way from the several joints, like the strings or sproutings of the herb horsetail, which is oft observed to grow among corn. And for the whole shape it does very much resemble those brushy vegetables. Besides these, there are 2 other jointed and bristled horns, or feelers, EE, in the forepart of the head, and a proboscis, F, underneath, which in some gnats are very long, straight hollow pipes, by which these creatures are able to drill and penetrate the skin, and thence through those pipes suck so much blood as to stuff their bellies so full till they be ready to burst. This small head, with its appurtenances, is fastened on by a short neck, G, to the middle of the thorax, which is large, and seems cased with a strong black shell, HIK, out of the under part of which issue 6 long and slender legs, LLL, LLL, shaped just like the legs of flies, but spun or drawn out longer and slenderer, which could not be expressed in the figure because of their great length, and from the upper part 2 oblong but slender transparent wings, MM, shaped somewhat like those of a fly, underneath each of which, as I have observed also in diverse sorts of flies and other kinds of gnats, was placed a small body, N, much resembling a drop of some transparent glutinous substance, hardened or cooled as it was almost ready to fall, for it has a round knob at the end, which by degrees grows slenderer into a small stem, and near the insertion under the wing, this stem again grows bigger. These little pendulums, I may so call them, the little creature vibrates to and fro very quick when it moves its wings, and I have sometimes observed it to move them also whilst the wing lay still, but also their motion seemed to further the motion of the wing ready to follow. Of what use they are, as to the moving of the wing or otherwise, I have not now time to examine. Its belly was large, as it is usually in all insects, and extended into 9 lengths or partitions, each of which was covered with round armed rings or shells, 6 of which, OPQRST, were transparent, and diverse kinds of peristaltic motions might be very easily perceived, whilst the animal was alive. But especially a small clear white part, V, seemed to beat like the heart of a larger animal. The last 3 divisios, W, X, Y, were covered with black and opacious shells. To conclude, take this creature altogether, and for beauty and curious contrivances it may be compared with the largest animal upon the earth. Nor doth the all-wise Creator seem to have shown less care and providence in the fabric of it than in those which seem most considerable. End of section 49.